Welcome to the second day of the 2022 CMU Portugal Summit, New Frontiers in Tech. We will soon start with our third keynote speaker. To introduce him, please welcome Bill Sanders, Dean of the College of Engineering, CMU.
Welcome, everyone. Time to sit down. I'm honored to introduce our first keynote speaker this morning. It's Professor Nicolas Christin. He's a professor in the School of Computer Science and in the College of Engineering at Carnegie Mellon University. And in these colleges, he's affiliated with the Software and Societal Systems Department and the Engineering and Public Policy Department. He's also a core member of SciLab, that's CMU's Security and Privacy Institute, and he currently serves as the director of the Societal Computing PhD program. His research interest is in computer and information systems, and most of his work, as a lot of work is at CMU, is at the boundary of systems and other disciplines, and in this case, networking and policy research. Most of his recent work is guided by empirical measurements. So today he'll talk about the broad topic of societal computing. Please go ahead, Christin.
Thank you very much, Dean Sanders, for the introduction. Yes, I'm going to introduce the notion and the topic of societal computing today, because I think that it's a very important topic for all of us in computer science and computer engineering to engage in. In fact, I would argue it's a critical topic. So let's take a step back. And what I want you to do is, for about 5 seconds, think about how you got here. Not professionally, I mean here in this room. You probably booked a flight, you have arranged transportation, you might have looked for a hotel, maybe you took an Uber to come here, or you rode on one of those nice little scooters. How did you do this? You used computers. Maybe you used your cell phone, but contrary to what you would have done 5 or 10 years ago, you probably did not arrange this with a concierge service or a travel agent or any third-party help. Maybe you did a little bit, but not to the extent you would have 10 years ago. And I would argue that this is a byproduct of technology in the sense that we have adapted our behaviors. How do we decide which movie to watch? We look at reviews online. We look at maybe what the recommender system is proposing to us. Maybe sometimes we still do the old-fashioned thing of having a friend of ours telling us, yeah, you should watch X or Y. But by and large, more and more, we are using data that has been curated by automated algorithms. And so this is kind of an evidence that computational technology is really changing our behavior. At the same time, besides being regular citizens, some of us are also computer scientists, computer engineers who are building those systems. And for us, we are creating an environment that, as I hopefully have demonstrated, is changing society at large. But as an engineer, very often, the question that we are not asking necessarily are these changes good? I mean, is this what we really want? We are building cool technology, but is it really going to be used in the way we think it should be used? So that's kind of the societal computing challenge, so to speak. And I would say that it brings 2 questions. How do we design new computing technologies that are addressing pressing societal needs? That's number 1. And number 2 is, whenever we're designing technology, how can we guide that design so that, again, it serves essentially a social good? Let's take, again, a small break to think about one aspect of societal computing, which is data privacy. Most of us, if not all of us, are using some, if not all, of those services. We use Google to essentially search for information. We watch movies on Netflix. We connect with friends on Facebook. Buy pretty much everything on Amazon, especially during the pandemic. We were using Amazon a lot. Maybe we get some newsfeed recommendations from Twitter. And some of us watch funny cat videos on TikTok. All of those companies provide very valuable services, maybe not the cat videos, but in general, provide valuable services, but it's in exchange for getting a lot of data about us, and essentially it is the most private data about us. Anybody who look at my Google search history probably has a better picture of me than I have myself, right? And they don't do that for free, right? They're monetizing this. So it's really a sea change compared to what we used to do before, where we were purchasing a product, we were paying for some hardware, and we would get it and we would be done with it. Now there is this constant interaction where we are essentially giving away almost private, almost precious data in exchange for services. Even for companies whose business model is not totally centered around data acquisition, that's the example of Apple, those companies may collect also a lot of data about you. If you have an iPhone, this thing is basically holding your most private secrets. And what can happen is that because the data is potentially available, governments may want to have access to it. In the case that is represented in this picture, the FBI wanted to have access to a specific phone of an individual accused of terrorist activities and asked Apple to get this data for them. And there was a bit of a tussle because Apple said, well, we can't give you the data because it's encrypted and we cannot decrypt it. And this is interesting because this is telling you that perhaps technology can actually help put some walls and barriers against overreach. In that specific case, was it overreach from the FBI? Maybe not. But in other cases, you might feel a little bit distressed if the government really wants to have unfettered access to all of the data that you're willingly giving away. So some folks have made the argument that we are experiencing the next industrial revolution. And if you remember the previous industrial revolution, well, I'm kidding, I mean, no one was born, but it came at a huge price. I mean, it was a wonderful development for society. It lifted a bunch of people out of poverty. It really accelerated a lot of progress, but at the same time, it came at a fairly big price. I mean, we are still paying some of these bills with, climate change and related issues. And so today, if we are experiencing the next industrial revolution, which is kind of the argument that Shoshana Zuboff is making, the drawback is that we may be also installing some sort of global panopticon where we are constantly being watched and observed and spied on by private and public interests, which may not be ideal. So from a data privacy standpoint, we need to build mechanisms to kind of limit these drawbacks. I want to make the argument that it's not just a matter of technology changing us at an individual level, it's technology also changing how society operates. This picture is of a demonstration in France. We're in Portugal, you're next door, so you know that public demonstrations are a national sport in France. I mean, we've been doing that for, well, literally more than 200 years. But what was new in those protests from 2018 is that for the first time in history, they started in a completely decentralized manner. They were essentially federated by people talking to each other on Facebook, as opposed to being spurred on by a central authority, a union or a trade group or what have you. It was completely decentralized. And this has been made possible by technology that did not exist 15 years ago. But likewise, governments are also using this technology in some cases to try to control the narrative. There is this example of the People's Republics of China using social networks to spread a certain point of view about what was happening in Hong Kong, again, 3-4 years ago. So this is primarily, the examples that I just gave you are primarily from the data privacy and data manipulation angle, but societal computing is much broader than that. It's basically anything that has to do with computers and society in general. So I'm not going to read all of those. The point of this slide is not for you to read it, but just to realize that there's a lot of aspects that are being covered. And they range from, again, privacy and security to things that you may not even think of, like preventing poaching from happening in natural reserves. How do we accommodate new regulations? How do we how do we deal with new financial models? And many of those questions now involve computers and involve computing. So what I'm going to do in the second half of this talk is that I'm going to focus on one specific aspect. So we're going to switch to something a little bit more technical, and I'm going to talk about some of the technical efforts that we've been making to identify censorship on a global scale. Why would we want to measure that? Isn't it obvious when something is censored? Don't you get a banner telling you the authority of the government of X, Y, and Z has declared this website illegal, you cannot go there? That happens often, but what also happens is covert censorship, where you don't get a block page telling you, no, you cannot go to that gambling site, or you cannot go to that religious site if you're in certain countries. Instead, the adversary, the government, just injects something in the communication that you're trying to establish with that website that causes the communication to terminate. What does that mean in practice? You're at your computer and you're like, the internet is broken, doesn't work anymore. And in fact, there are even devices that specialize in doing this kind of things. So overt censorship is not really an interesting scientific problem because it's overt, it's obvious. Covert censorship is, because you need to be able to distinguish between a deliberate action from an adversary and basically disambiguate the fact that it is a deliberate action compared to a random fault from the network. I mean, we've all been there, trying to connect to a website and it doesn't work for whatever reason. But when it's due to an adversary, it would be good if we could identify this. So this is kind of what motivated this whole arc of research on censorship. So I'm going to give you a very, very quick networking lecture with apologies to my colleagues that are teaching computer networks. What happens when you try to establish a connection to a website? Let's say that, so you're the client, you're that little person in the middle, and you want to connect to, say, Facebook. The first thing that your computer does is to ask what's called a DNS server. It's essentially a directory. Where is Facebook? Because at the network level, we don't know what Facebook is. We don't know what Google is. All the network knows about is numbers like this 3113, 7136 that represent the location in the network of the resource that you're trying to access. Okay? So it's essentially, for those of us who are a little bit on the older side, like looking in a phone book, what's the phone number of the person you're trying to reach? And so that's what the DNS server does. It resolves Facebook to a network address. Once the client has that, it can then talk to the web server. And the way this works is through what's called the TCP three-way handshake. Essentially, the client says, hey, server, I want to talk to you. The server says, OK, we can talk. And the client says, OK, now I'm going to start to talk. It's a little bit of a convoluted process. There's reasons, technical reasons I don't want to get into why it's done that way, but it's basically a three-way thing. At that point, after that three-way handshake, the client can start requesting data from the server and get, the Facebook front page. So why am I showing you this? Why am I going into those details? I'm going into those details because if you look closely at this picture, you immediately figure out that there are two main ways the censor could block communication. They could block it here. They could tell, oh, you want to go to Facebook? No, you're going to governmentoversight.com instead, right? So they could do what's called DNS manipulation. They could do blocking at that level, or they could wait for the communication to be established to either terminate it surreptitiously or to replace it with a block page. So there's essentially two places where the censor can act. And so what we decided to do, and what took literally a decade to put in place, was to build a global censorship measurement infrastructure where we try to observe censorship events all over the planet. And this poses formidable challenges. The first one, my apologies. So this has been going on since 2016. We started building it in 2012, 2013. It's still running. It's covering 62 countries and 234 autonomous systems. An autonomous system is basically an organization. CMU is AS9, for instance. All right, so we've got a number of vantage points. We want to observe, again, censorship from many different countries. And those vantage points consists of 264 VPNs and 17 volunteers. The problem with volunteers is that they have this annoying tendency to go to prison when things don't go well. And so we don't want to use them. Historically, we used them, I think, in 16, 17 maybe, and then we try to stop. We try to automate as much as possible to avoid putting people at risk. So those volunteer vantage points, they're basically on the way out. I'm happy to say that currently we do not use any volunteers. We exclusively rely on virtual private networks. Essentially, we purchase access to a machine in a bunch of different countries. That's great. It's got high availability and high bandwidth, usually much better access than somebody connecting over a DSL line. But VPN providers lie all the time about where their servers are. So you try to purchase a VPN that tells you, we've got a host in North Korea and in Pitcairn Island. Systems administrator must be a penguin or something. And it turns out that it's in a data center in Germany. And the funny thing is that you query publicly available geolocation databases that tell you where a machine is, and they tell you, yeah, this thing is in North Korea. And then you realize that's probably not the case. So what we did was to build a geolocation checker. It's extremely simple. You know how GPS works? You take 3 different measurements, you triangulate, based on the time it takes for a communication to go back and forth. We do exactly the same thing here. And we end up realizing that some of those VPNs are absolutely not where they claim to be. Some are, but some don't. So that was the first challenge that we had to resolve, which is to make sure that where things are. All right, so we've got our VPNs. We know now that they're not lying. We know that they're in the right places. What do we do next? Well, we need to get a list of things to test, right? You study censorship by testing what could be potentially censored. And for that, we rely on lists that are publicly available. So that's great. There are places like the Berkman Center at Harvard or Citizen Lab at the University of Toronto that provide you with lists of things to test. List of web pages. Yeah, test that. That's a blog of an activist, blah, blah, blah. It's probably censored. What we realized, though, is that those lists are static. Well, we didn't realize that. That was a given. But they age very quickly and very poorly. So a current research question that we're facing is, how do we dynamically update those lists without resorting to volunteers telling us, yes, I stole a list of censored thing from government X. Instead, how can we automate that? And that's one of the challenges that we're currently facing, because those lists, again, tend to age fairly quickly. All right, so assuming that you've got decent lists, what do? Well, you've got control of the machine that is making the request, right? You've got a server somewhere in Iran, for instance. Well, not Iran, actually, Iran we don't. You got a server somewhere in Thailand, and you connect to a web page somewhere, and you get essentially everything that is happening in that connection. So you can see pretty much everything that I was describing before, whether the DNS has changed, whether there's something weird in the web page request, whether somebody is trying to fool you into accepting a broken security certificate. You can get information about the route that your packets are taking to go from your machine to that server. You get everything. And so the point that I'm trying to make here is that there's a couple of censorship measurement infrastructures that exist. Some have better coverage than ICLab. But what we have is deeper coverage than pretty much anybody else, because we actually can see the traffic in a very fine-grained manner. So everything that I discussed earlier, we can see. We can see DNS manipulation, we can see packet injection, block pages, and so forth. What we observed is that for 4 years, between 2016 and 2020, I apologize, I didn't update those numbers for this talk, but out of more than 50 million measurements, we saw a significant number of incidents. And what is perhaps the most interesting on this slide is this part. There's half as many packet injection attacks where the connection is silently terminated as there are block pages. So covert censorship happens a lot. Governments don't always tell you, no, don't go to that website. Sometimes they just cut the cord without you noticing. Another thing that we observed is that one size does not fit all. Governments, states use a variety of methods. They very often combine different methods to censor traffic. And what we also looked at was keyword filtering. So everything that I've discussed at this point is connection establishment. There's something that is even nastier, which is where the government lets you connect, and then they realize that you're saying something that is forbidden, and then they kick you out. Does that happen? Well, reports tell us that it happens a lot in the People's Republic of China. And so we wanted to test that. We wanted to see if this was happening and where and how. So this was a paper that was published last year, which involved one of the students from one of our universities in Portugal. And the idea is that if a sensor wants to do that, it starts to get really, really hard because they need to look inside your traffic to see that you're saying or listening to something that is forbidden. And we wanted to see to which extent this happened. So again, we leveraged our infrastructure. I apologize, this is way too small to see, but you can see the dots. They're basically all over the world, and we're trying to connect to machines that are in China. And what we noticed is that keyword censorship is a real mess. It's context dependent. It sometimes depends on where the forbidden word is placed in a request. Sometimes they let you through, sometimes they don't. And whenever you're searching for data, you've got a higher chance of being censored. It's also route dependent. That was totally surprising to me. If you're trying to access a host in Shanghai from Hong Kong, or if you're trying to access the same Hong Kong host from Shanghai, you don't get the same results at all. It's like completely asymmetric. We also noticed that when you're within China and talking to another Chinese host, there's a lot less censorship, which is very interesting to us because we would expect, the watchful eye of the government to be on us. No, they're mostly looking, or at least they were mostly looking at the boundary when you were crossing in or out. And the third thing that we observed is that keyword censorship itself is time dependent. Doesn't come as a surprise to us, but it was nice to see it. So there are some themes that are recurrent. If you're looking for June 4th incident in Chinese, you're going to get blocked. Why? It's a euphemism for Tiananmen, right? But on the other hand, if in 2019 you were looking for pneumonia-like disease, no problem. 2021, slightly different thing. It refers to COVID, that's blocked, right? So it's very interesting to see how those lists of censored keywords evolve over time, because that tells us something about the geopolitical dynamics of a given country. For instance, who is falling out of favor if a specific individual name starts to be censored, and if that person is still in charge of something, you can probably safely assume that pretty soon they will not be in charge of that thing anymore, right? They're falling out of favor. So this type of work is really, to kind of close the loop on what I was saying in the beginning of this talk, it's really interesting and important for people outside of computer science. Geopoliticians, sorry, that's not a real word, but political scientists, people who study this type of dynamics from a social angle, from a social sciences angle, are really interested in that type of stuff, and we are here to help them with that infrastructure. So what do you take away from this talk? Computing is embedded in everything that we do, whether we like it or not. I mean, my parents are very much opposed to anything that has to do with computers, and they have no choice, they have to use them. And I'm arguing that we really need to complement what we do, technical computer science research, and open it to other disciplines. I gave you the example of censorship measurement research, and I did a little bit of a deep dive in the technical aspects to convince you that this is technically deep research, right? I mean, we are doing network security. We also have, I didn't talk about this, but there's quite a lot of machine learning in there. And there's an impact beyond computer science, and it's really important. Other examples include some of what we discussed yesterday, for instance, ethics of AI and ML. That's an important point. What is also important is security of ML, if you think about it. We are putting our lives into the hands of automated systems. What happens if somebody compromises that system and changes its output? It's not just about ethics and making sure that systems are behaving properly. It's also about making sure that they're not vulnerable to miscreants. Other examples include, well, if you follow a little bit what's happening with cryptocurrencies, it's a mess, and the regulators are somewhat clueless. about what's happening, we can help because we know how those things work. So that's the reason why at CMU we do have a PhD program dedicated to societal computing. And I hope I piqued your interest. I hope that I'll have a few questions to talk more about this. My contact information is here at the bottom. Please feel free to reach out to me. Thank you.
So thank you, Nicolas, for a really invigorating talk this morning. Get ready for your questions. With the permission of the organizers, we will go another 4 or 5 minutes since we started 10 minutes late. I'm going to take the prerogative and just start with one.
Okay.
We all know the saying that any technology can be used for good and bad.
Right.
And so I want to focus right down on this really nice example you gave about how you determined levels of censorship. The fact that you could get that much information about packet traffic says that there's a privacy issue, right? Because you knew a lot more than you told us. You knew a lot about the people that were sending that traffic. How do we balance that? And how do we balance your ability to detect these kind of things with the need to make our internet more private?
So the approach that we've been using in our research is basically to experiment on ourselves, rather than, with the exception of the few volunteers that I talked about earlier, we really try to push these people out because of the exact reason that you mentioned. If you experiment on yourself, you know what you're saying to a server, you know what you're getting from that server, and you can, basically, you don't harm anybody. If you're doing that on somebody else, that poses a huge privacy problem, and in fact, I don't want to do that at all. So I think that those are somewhat self-imposed rules to some extent. Privacy-enhancing technologies, encryption, anonymization, can be used to actually prevent third parties from doing that. But then the question is, well, wait a minute, you're giving us, for instance, the ability to pay anonymously on the internet. Can that be used for terrorist financing? And the answer is, yes, it totally can be, because it's a bunch of ones and zeros, and doesn't care, whether it's used for good or for bad. So that's why we need to enrich our technical approach with conversations and involving people who are coming from different perspectives, because some of those problems cannot be resolved at a technological level.
Absolutely. So because you were good, you did your research in an ethical way. But if you were not good, and if some other researcher was trying to block your make this more private, then you wouldn't be able to do your research. So it's a double-edged sword.
Yes.
Who's next? Please go ahead there, and then up in the front.
So when thinking about these types of problems, I always like to think about the old separation between mechanism and policy, which, and in particular, so my question for you, running a graduate program, students doing a doctorate in this area, how do you help them keep that distinction in mind, particularly that, say, you look at mechanism for censorship, but different authorities that might be doing the censoring may have different motives, and the researchers themselves may have their own views on what is good or bad versus bad, difference in the values. So how do you manage those distinctions, and do you have some lessons to tell us about how to do that best in the context of research and education?
Right. Yes, thank you. This is a very important question, and the way we address it at CMU is through education. So we mandate that in the societal computing program, we mandate that students take a bunch of core technical courses so that they can understand the technical underpinnings. But we also mandate that they take social science courses, courses on ethics, courses on political science, for instance, are some of the offerings that we have, so that they can understand also how the other side thinks and speaks. And then I think that's the most we can do. We give them the training. After that, it's on an individual basis. They can form their own opinion. But we emphasize that dual training. Yes.
Nuno, I think, is next. Please go ahead. Mic up here.
Thank you, Nicolas. It was very interesting talk, and actually it shows the importance of the partnership, trying to follow some of the things that are happening there at CMU. We have the first student, Carolina, enrolled in the societal computing PhD here. My question is related to what type of students do you see enrolling in this program, and what type of jobs do you anticipate? I know that you probably don't have any graduates yet, but what type of jobs do you think these students are going to get in industry, in academia? And a final provocative question, I would say that most of this is HEI research. What do you think about that?
Oh boy, you're getting me with the last question. Aren't you an HCI person?
Be careful after this one.
I know. In terms of students that we recruit, we typically want students that have a strong computational background or the ability to get it quickly, right? So by and large, I would say, I'm making up the statistics on the spot, but 85% of our students are computer science, electrical engineering type of graduates at the undergraduate level that have really an interest in going a little bit beyond and a little bit broader. The 15% that remain are people who have different type of training, usually quantitative, so people in physics or related field, but who do have the computational background. Maybe they acquired it on the side to be able to thrive in that program. In terms of outputs, we do actually have a couple of cohorts that graduated already, and it's pretty much your usual mix of people who go into academia. For instance, we've got alumni at the University of Chicago, at Vanderbilt, at a couple of other places. Some folks go to industry. There are some companies that start to pay attention to those things, in particular in the realm of ethical AI, ethical ML. You can get a job at Facebook, not to name names, but because they really want to try to clean some of the audience tables that they've been running. Google also hires quite a lot in the program. And I think we do have some folks, I'm trying to remember, but I think we probably have 1 or 2 students who went into government-like jobs, advisory roles or things of that nature. Regarding your question about, isn't that HCI? I would say, yeah, to some extent it is. Yes, we're involving humans and computers. I think that the difference between HCI and societal computing is that societal computing really focuses on humans as a group, as a society, whereas HCI tends to focus on everything, but perhaps primarily on direct interaction between individuals and machines. It's not completely true, but I would say that's the distinction. But we're very good friends with the HCI, the HCI department. I mean, a lot of students go take classes in HCI, so yeah, those are really sister programs.
And we should say the boundaries between departments in CMU are very fluid. Nicolas is in 2 departments. Did you have a question? Please go ahead.
Well, 2 short provocative questions. The first one is whether your work is censored in some countries. That is the first one. And the second one, when I hear about social computing, maybe I am too naive, but I think about the impact for good.
Right.
But it looks like you see it from the other way. Do you want to comment on that? And
sure.
Don't forget about the censorship of your work.
No, I can answer. So I don't think our work is censored anywhere. The censorship work on like the keywords in China probably is. The first author of that paper, if you saw the little footnote, his name is Raymond Rambert. That's a fictional character. That's the journalist that is the main character in The Plague. And that's because that first author really doesn't want to have anything to do with the Chinese government for reasons that should be somewhat obvious. Regarding, computing for social good, that's definitely one of the lines of work that we have in the department. Fei Feng, who is one of our faculty, focuses almost exclusively on AI for social good. A lot of us focus on making sure that, so from a security and privacy standpoint, making sure that the technologies and tools that are developed and used are used also for good rather than for ill. So it's definitely one of the central missions of the PhD program, yes.
Well, thank you, Nicolas. I think we have to move on, but what a great opening to the morning.
Thank you.
So let's have 1 round of applause.
Thank you for having me.
Thank you very much.
Next, we will have the roundtable, AI for Extracting Value from Data. This roundtable will be moderated by Giulio Sandini, CMU Portugal ERC member and senior researcher, founding director at the Italian Institute of Technology, joining Paulo Marques, CMU Portugal Program Scientific Director and co-founder and technical fellow at FeedSci. We welcome the project representatives to move to the stage.
So I stay on that side and you on this side, and yep.
Okay. No, it's okay. I'm fine. Perfectly fine. Thank you.
I don't mind, honestly.
No, I'm good.
Hey. So, welcome to this session, which is about AI for extracting value from data. And we are going to have 4 project presentations with discussion. Each project will have 15 minutes to present, and then we discuss for about 5 minutes, and we move on. So the first project is called Building Hope, and will be presented by Carlos Silva and Ana Pereira.
Yes.
And the floor is yours.
Thank you. Okay. Hi, good morning, everyone. So we will do this presentation a bit differently because we wanted to share the stage and to turn this presentation a little bit more dynamic. So I'm Ana Pereira, and I'm the innovation manager at DST Solar, which is a company that basically installs PV centrals, photovoltaic centrals. And I'm here because we are the leaders of this research project that is building holistic optimize of presumed energy, which is the shortcut Building Hope. How can I move the presentation? I'm sorry. Yeah. Okay, so we are doing this only because we have this diverse and multi-topic team that works on different areas such as energy, software design, computational modeling, and here are our partners. So DST Solar, Técnico de Lisboa, Innovation Point, what is Coimbra University, and of course the Carnegie Mellon University. So the main goal of Building Hope is to develop and validate a tool for holistic optimization of presumed energy of buildings. And with that resulting technology, we hope to add new dimensions to the energy management systems, as by characterizing in detail energy services consumption, performing asset management, optimizing the operation across multiple energy systems and multiple buildings, and aiding building owners with contracts management. For doing that, we are using 3 case studies, which is very important because we are taking data from these case studies, which are 3 different typologies of buildings. We have an industrial building, which is in the SC Group complex. By the way, it's in Braga, for just a curiosity, which is by Still FS. We have a services building, which is here in Lisbon, in the campus of Instituto Superior Técnico, which is a building that they are taking data from there for a while now. And we also have a retail building, which we have the support of Sonai, which is a Continente Bom Dia, which is like this smaller supermarkets, let's say it like this. So for 2 of those case studies, we also did an installation, and that is the part of DST Solar. Basically, we did installation of some batteries. These here are the batteries, and some indoor sensors for the environmental conditions inside the building. We did this in the industrial complex and as well in the sorry, in the Continent Bondia. In Continent Bondia, we also had to adapt a little bit and make a little promotion of the project because we couldn't put the batteries inside the facility. But so we took that as an opportunity to try to talk a little bit more about building Go. And now, without any further ado, I will pass the word to my colleague, Sir Carlos Silva, that will give you more details about this project.
Okay, Anna, thank you very much. Good morning, everyone. So now I will try to show you how we are trying to use the data for good, answering Igne's question to Nicolas a while ago. So this is actually the output of the project. Will be a tool, Building Hope. I don't know if it will stick as the final name of the tool, but here is just already the mock-up of the software that has been being developed and will be ready in 6 months, more or less. And what I'm going to try to show you is how the different 4 objectives that we had that I present to you are being tackled, and especially with the aid of artificial intelligence. So one of the first steps is we have a lot of data being generated in these facilities, but data per se is not interesting. So the first thing, if you want to do a proper energy management of these facilities, is actually understand exactly where the energy is being used. It's not possible, even with all IoT sensors that we have available now, to basically collect everything that we are spending energy on. So in that sense, we are implementing algorithms for energy service disaggregation. So first we have these facilities in Portugal, because they are required to have an energy performance certificate. They have energy models, energy simulation models, and what we do is actually we pick up these models, which are basically physical models of the infrastructures. We have the real data. These models have been developed before the construction, so they have some conditions which are not really properly modeled. So we use the real data actually to optimize and minimize the errors of the model. And with that, we have an energy disaggregation by different services given by the model. And then what we do is we pick up this model data, and using real data again, what we use is artificial intelligence algorithms developed by the partner What-is, which basically disaggregates by service in real time what's been going on in terms of energy consumption. And we have a fairly good idea where this energy is being spent on the different systems. We mean HVAC systems like the one we are seeing here, lighting, and different type of equipments. And this is the result. So for the customer, for managing the facility, that we will have a real-time graph where he knows exactly where he's being spending the energy. A very important aspect of energy systems now is flexibility. So because we're having more renewables in the system, it's more and more important to be able to connect or disconnect some of the loads in real time, so to adjust the weather conditions and the renewable generation inside. And so what we do also is taking advantage of these algorithms is actually to characterize the flexibility of each system. So based on the operation data that we have and on our models, we try to understand when, in which periods of the day or under which conditions we can actually switch on or switch off some of the devices. And with that, we create a flexibility curve, which basically tells us for each equipment when can we switch on and where can we switch off. DST, as Anna presented, well, one of the main activities is actually the installation of PV systems at different scales, industrial scale, but also utility scale now. And for them, it's really important to have a proper real-time monitoring of what's going on in their equipments, whether it's PV system, but also the storage. And what we are doing is, again, with developing predictive asset management for PVs and batteries, which basically tell us for the different equipments if they have failures or which type of failure they actually are having. And with this, in the final output of the tool, we'll have basically it will tell us which inverter is operating and what's the failure that is happening. It's not that they don't have this system already in place, but not in real time. So this basically the current systems provided by the inverter manufacturers. They give you just a warning when something is wrong, and we are trying to do it in a preventive way. Then, of course, we have, as the name of the building, we have an holistic optimization. So basically, we have different buildings or different facilities in a building, and we want to optimize how each of the systems should operate in order to minimize cost or energy consumption. It depends. And this is just the result. So basically, the tool will tell which systems should switch on and off, basically just providing a demand response answer. And this is something new. It's being developed by our partners in Coimbra. It's basically after the new directive of buildings in Europe from 2018 requires that all buildings have a smart readiness index. So basically telling us how smart is our building regarding different aspects. So in terms of energy, in terms of flexibility, in terms of information to occupants. So basically we have a tool now that is basically able to tell us what is how smart the building or the facility in this case is. And finally, and relating a little bit with what Nicolas presented to us, we also have a module where we are helping the customers to manage contracts. So energy management, energy supplying contracts are becoming more and more complex. So especially now due to the energy crisis that we're having, many of the retailing companies are offering contracts which are based on real-time pricing. And basically this is very difficult for a regular consumer or regular customer to manage, to know exactly what is going to be his energy bill in 1 month, because the market fluctuates a lot within a day. So basically this implementation tries to in real time, so it depends on the time period, we have implemented in every hour to try to assess exactly what is being going on in the terms of the contract, and it's being validated both by the customer and by the retailer. This is we are using blockchain technology. We have the contract which basically allows not only the direct exchange of energy between the client and the energy service company that is supplying the energy, but actually exchanging contracts between different users in a peer-to-peer network. And so this is already an implementation we had using Ethereum blockchain. It's not the best choice, but it was the one where we did this mock-up project. And what you see here is in real time, the customer knows exactly at each hour how much they are going to pay for each energy they consume for the customer, or how much they sold to other consumers. And I think this summarizes the project. And well, I hope DST is very happy at the end of the project. Thank you very much.
Thank you.
Thank you. Thank you so much. Do we have any questions at this point?
No. Like.
José?
At what level of granularity are you measuring the consumption and controlling? For example, you mentioned 3 very different examples: industrial facility, a continent, kind of a surface, commercial surface, and then you have a building at the IST. Are you monitoring for example, at IST, the office occupancy? And so at what level of granularity are you controlling these things?
So thank you for the questions. For each facility, as you mentioned, we have different granularities. For example, at IST, we are actually, we have the granularity of building. Okay, so although the buildings have different size, in continent we have a fantastic granularity because, well, I think retailing companies are more advanced in terms of energy management. So we know exactly in each sub area of the shop is being spent, and the occupation and the control. In the industrial facilities is also at the building level, so we don't have so much disaggregation. And in industrial segment, it's even more difficult because each factory is really different. So this one by Steel is they develop well, I don't even know the proper name in English, but develop
Yes.
aluminum profiles for facades, etc. So, and they change the activity almost daily, the type of consumption. So, I would say, in average, the granularity is at the building level, although we have some cases where it's more detailed. Okay, I hope I addressed the question. Thank you.
I just have a quick clarifying question. First of all, thank you for your talk. You used the word prosumption somewhere in the talk.
Prosumer, yeah.
Prosumer, as opposed to consumer.
Exactly.
So, I mean, what does that exactly mean? Is it that you're trying to be, does the pro refer to being proactive in influencing their use of energy? Or I'm just trying to understand what that meant.
Sorry, thank you for the question because it's important to clarify. So prosumer is a word that came out in the regulation, which stands for production and consuming. So basically, a prosumer is a facility which is able to produce energy and sell it if necessary, but also consume it. And so the point is that it may have an active role in the market to sell also energy and not only to consume. Okay. Thank you.
Sorry, I also have a short question.
Yeah, sure.
I mean, in this system, how much is the system reactive and how much is anticipating on short term, for example, through weather forecast or other, activities that could be anticipated by this? Is this a reactive system based on?
No. So reactive systems is what we more or less have. So the whole idea of the project is to be reactive. Reactive is not the word, sorry. But anyway, to be anticipating the events.
Okay.
Our preventive, thank you. So we are working now for the different customers at the hourly scale, and we can, well, for example, for energy consumption, for energy generation forecast, we are working at the hourly scale, but forecasting for at least the next day. So
okay.
that's our, and for the maintenance also, for the asset management.
Okay.
Thanks.
Thank you.
So I also have a question. So I liked your presentation a lot, and I actually read the report. And you state in the report that the improvements that you see are probably between 10 to 20%. So one thing that I was wondering is, if we actually model the activities that are taking place on the building, could we actually suggest policies that change behavior? Because one thing is to optimize when the sun comes up or what you can produce and so on and so forth. But for really great changes, you actually need to alter the procedures or the way people work or the way machines work. So I'm not sure if you are taking into consideration modeling the activities of the building itself.
It's a great question. We are not in the project, so we are not, but it's with the data that we are generating or processing, it could be done, but actually was not the scope of the beginning of the project. Maybe in a second generation of the project, we could tackle that because it's very interesting.
Okay.
Thank you.
So thank you so much for your presentation and the project. We are now going to move to the second presentation. It's a project called G2Waste Crypto, and is going to be presented by Jens Scott and Rui. So thank you so much, and the floor is yours.
All right, so I guess with all the great conversation we've had on machine learning and big data, I think it's a good time for us to change the topic a little bit. So let's talk about trash. Not talk trash, but talk about trash. My name is Ray. I'm from Carnegie Mellon University, Civil Environmental Engineering. I'm here with my colleague Ian Scott from Nova Information Management School. So we're here to represent our project consortium, to present to you our project, G2Waste Crypto, and hopefully to bring you on a short 15-minute journey to reimagine the solid waste management in the future smart cities. Right, so our journey started with our shared vision of what the waste management system could look like in the future. So we think It should have a collection system that really motivates the citizens to sort their waste in responsible ways, and have a smart logistical systems with high spatial and temporal efficiencies, and a suite of technologies that can really maximize the economic, social, and environmental benefits. And all these things can be hosted under a central data hub for automated and transparent data collection and disclosure. So with this vision, B2Waste is our product. It's a complete software package to upgrade the decades-old system by leveraging the innovations in IT or ICT, as we heard yesterday, and harnessing the power from data, right? So we want to inject the same excitement we have had these 2 days into this decades-old system, at least for the United States, that's the case. So I'm going to talk briefly on the back end, which is the decision-making module of the system, and my colleague Ian is going to talk about the user interface and user experience. So our ultimate goal for designing this decision-making module is to, number one, figure out the system configuration, which means what happens to the things that we throw into the trash bin, the recycling bins, or compost bins, and that to maximize the cost efficiency and to minimize the environmental footprints. But also we want to go one step further to identify the policy levers that can mobilize the social and financial capital to really help to transition to a more sustainable state, to overcome the system inertia. To accomplish that, we're taking a decision module that's mainly based on a mathematical optimization model of mixed integer programming that takes from a lot of data that we collected over the course of the project, mainly from our existing journal articles, databases, but also we conducted extensive on-site visits to the facilities near the Lisbon area. And also we believe when our product is up and running in the future, we'll have a continuous flow of high-quality user feedback. So to accomplish all these research, our overarching research paradigm we're taking is what we propose as a hybrid problem-solving approach. As we're facing these sustainability challenges, which are usually nonlinear, complex, and multi-stakeholders, they're usually not amenable to explicit analytical forms. So traditional science-driven approaches and data-driven approaches, they both fail because the science of the problem is just too complex and there's not enough data for us to learn from. So we're proposing a deep integration and a close collaboration between these two approaches, just like a CMU Portugal collaboration, to really address this problem, because the science domain knowledge can really impose structures and put constraints on the search space of data-driven models so that less data and computation is needed. On the other hand, so the data-driven models can really reveal the complex science behind the problem that is probably embedded into the patterns of the data. So the analogy here we're showing is like digging a tunnel from both sides, right? The more data we have, less knowledge we need, or more knowledge we have, less data is needed. So just to give you one quick example to finish my part, so we're looking at a complex decision-making context of the entire system, right? So we're not only looking at the technical aspects of waste management, but also looking at the social, governmental, and behavioral aspects of all these variables and decision-making conditions, and we are integrating everything into one framework. But also we're imposing this scientific framework onto a traditional neural network architecture. So in a sense, we're hand building the neurons and connections. We're also imposing the science knowledge to constrain these weights. And also we're adapting like the customer loss function and also like a skip connection configuration to accommodate for the complex system dynamics. So the hope is that we're not only be able to generate predictions with less data available, but also to tell you a little bit more of why the machine learning is giving us these kind of solutions. So with that, I'm going to pass it on to my colleague Ian to explain how we can translate this to human behaviors.
Okay, thanks, Ray. So Ray's been talking about this kind of high-level system planning approach to how can we improve our waste management systems. But we're also interested in the much more granular problems of facing consumers, how can we change behavior, right? And this is a very big open problem because actually the waste we produce at home, this municipal solid waste, is considered a very complex stream to process because there's just all sorts of material that can end up together in that stream. And at the moment, really the only economic, practical way to deal with it is to have people separating their waste at home, right? And these sort of waste separation rates differ a lot by country, but a number of countries, particularly including Portugal, have rates reasonably low and well below their kind of EU mandated targets. So we're interested, what role can technology play to improve this? So given we're going to introduce a technology to consumers, we want to know what will drive them to use this technology. So we look to the technology adoption literature to try and model this relationship. And so we start with three things we're trying to look at. Behavioral intention, do consumers intend to use this product? System use, a more granular look at what actually would you use in a waste management system, and intention to recommend, which is like just another measure of if the consumers have a positive view of this product. And basically, we start with what's called the universal theory of the use and acceptance of technology, number 2, okay? And this is the sort of very well-known framework for kind of predicting the adoption of new technologies. And what we find is, in our case of waste technologies, 3 things are particularly important. The effort expectancy, how hard is it going to be, the social influence, and the hedonic motivation. So both effort, how much effort it takes, and social influence are really important in recycling. That's very well known. The hedonic motivation, how much will people enjoy it, was a little bit of a surprise, but is quite interesting for us. So what we do, though, is we add to that some technological components. And what we find is that gamification can play a real role in modifying these relationships. And of particular importance is trust. And trust really drives all 3 of these outcomes we're looking at. Finally, we didn't at first find any relationship with kind of financial penalties or rewards, but when we looked a little bit further in the detail, we found that kind of rewarding people for good behavior worked particularly well for people that didn't otherwise kind of recycle or have good pro-environmental behaviors. So we've also thought this is something that we should target. So the important things here is really these rewards, gamification, and trust. And what is the technology solution that can be introduced here? And this is basically where we look to blockchain, which is this technology that in theory is a technology about trust and about transparency. And transparency is really one of the solutions that's been proposed to kind of lack of trust in waste management, which is this kind of low trust environment. So basically we have a system, it works something like this. We have a user at home, has plastic bags, sorts their material. And what actually happens is each one of those plastic bags is identifiable with an RFID, right? And so that RFID is registered to the blockchain, so we know which bag belongs to which person. The person, after separating the materials, deposits it wherever they normally do. And depending upon the technology at the deposit point, we can measure that weight and register that to the blockchain. Finally, when it's collected, the collection vehicles are installed with these industrial RFID readers, and they read all these RFIDs that are going through, and we can see what's been collected. When it arrives at the sorting facility, we can kind of provide quality ratings, spot checks on how well are people actually recycling, sorting that material. And finally, when it's repackaged as on-sold recycling material, we can again register this to the blockchain. But so what it does is it provides us with all this information on the journey of the recycling and waste after it leaves the house, so that we can demonstrate to users that, look, this is worth doing. You know, there's a lot of kind of anecdotally people saying like, why should I separate waste? It all ends up in the same place, things like this. And the idea is that blockchain gives us this platform that can help demonstrate transparency what happens to these to our waste. It also allows the local municipality to really in a detailed way track performance, and so set the waste payments based upon people's actual production of waste and rewards. I don't know if you know this, but in Portugal, how much you pay for waste management depends upon how much water you use. It's completely unlinked to how much waste you produce. And so this offers us a solution to that problem. Okay, so we can set cost and reward levels, And with blockchain, we can kind of introduce these payment systems, reward people with the cryptocurrency, which ideally then they can sort of spend in a local environment, local businesses, etc. Just to mention the particular technology we're using, because we're wanting to be adding a lot of transactions to the blockchain, it's basically not very practical with a public blockchain. And so what we're using is what's called a blockchain network. So we run our blockchain, but every single block that we add is validated by a much larger blockchain. So we don't have really control of it. It has to follow the rules that we have built. But again, this should introduce trust because we can't modify what happens on that blockchain. Okay. Finally, there's an app for kind of delivering these gamifications, competition between neighborhoods, rewards, and basically all these good things. And so basically that's our vision for what we have developed to kind of try and bring some of this technology into the area of waste management. And yeah, thank you very much for your time.
So the floor is open for questions. I see a few hands already.
So the immediate reaction I have for this, what about privacy? I don't want you to know what kind of waste I generate in my household. Blockchain is open for everybody to read.
So it's a good question. So it starts off as pseudonymous, right? So I don't hold any personal information on the chain, both for GDPR reasons and for general privacy reasons. So it's pseudonymous, but it is the case that maybe we would get to the point where people could, track down your level of production of waste, basically. But it's like saying that, in Portugal, it's very common to share a garbage bin with all your neighbors. And so people see how much waste you are producing, and people get annoyed at the person that's always filling it up. And there's actually research showing that this really leads to better behavior in terms of recycling if someone can identify what you're doing. But I mean, it's a concern. There are technical solutions to that, but for us, we're just trying to see if the transparency kind of can help, I guess.
Hi, thank you for the presentation. My question is more, this solution is directed towards the user, right? So it's more for the consumer than for the producer. My question would be, would this also enable some kind of tracking on the part of the producer? So from what I know, I've seen recently some studies which said that most of the plastic we produce isn't even recycled, because from the 7 most common types of plastic used, only 2 of them are recyclable, and even those, as they are mixed with the other ones, even when people do separate the trash, aren't even recycled at high yields. So it's about 25% for those two most those 2 that can be recycled. What would be the solutions in that way so that producers also are incentivized to produce with more recyclable types of plastic, and also the consumer to be able to distinguish, because it's also difficult for the consumer to distinguish between those types of plastics? Thank you.
So just to start out, you're telling me you don't trust what happens to the recycled material that leaves your house, and you're telling me there's good reason not to trust it, right? So look, this is the motivation for providing more information to consumers. But yeah, the next step is to kind of go up the value chain and track from the level of products through the system and kind of these reverse supply chains, all these kind of areas. I don't know if you have a comment on that, or
there's another question, I guess. Yes.
Thank you for the presentation. I rather like this project. I liked it when I first saw it, and I like it now. Notwithstanding the questions that surround it, it seems to me it enables us to look forwards a bit. But of course, really, you also want behavior change. There are other ways of getting behavior change, and this is just a suggestion in case you've not looked at it. I come from the UK. The UK has something called the Nudge Unit, the Behavioral Insights Team. Relatively small things done, informed by behavioral insights research that can influence behaviors. Factoring that in and complementing, if you haven't already, might be well worth thinking about.
Just to comment, I agree completely. And I was actually applying for funding to psychology institutions saying that, look, I can measure behavior in terms of recycling at a detailed level. So let's try some nudges. Let's try some different behavioral interventions, because we suddenly have the system that can really measure results. But yeah, that's absolutely, to achieve this goal, behavioral intervention is very important. We're just testing the question, is transparency one of these interventions that is going to make a difference?
José, one question.
Thank you very much for this presentation. The project is so futuristic. And so my question really is, the project is about, what, 2 years or 3 years? So what are you going to actually deliver at the end of your project? Who is the customer, and what are you actually going to give to that customer?
So a good question. So the technology that we've built is quite flexible to do a lot of things. Now that we're trying to run a pilot and hitting the real world and dealing with municipalities, utilities, different incentives, things get more complex. But we have finally, I think, reached an agreement that navigates all the interests so that our pilot will kind of focus on the separation of bio-waste that will be separately delivered and tracked on this blockchain system. But at the level of kind of our project is going to be collecting that waste and making sure it's disposed of properly and kind of registering all of that, because there's some difficulty dealing with the utility not wanting to have extra responsibilities. But the blockchain is like one half. There's also the kind of planning tools, which is another sort of service and product that is sold to the municipalities.
So one final question.
Yeah, thank you. I also enjoyed this, and I'm a civil engineer, so I very much appreciate this kind of an approach. How do you verify that what goes into the bag and people are getting paid for? Because part of the problem with recycling is you get mixed, you get people throwing other stuff in, and we know the waste management industry is one where they could figure out how to take advantage of it by maybe putting more of other types of waste in. Do you have some mechanism at the end that verifies that what comes in on that bag is in fact a fully recyclable load?
So one of the ideas is trying to add that information, right? So because each bag is identifiable to an individual, it can be checked and can be traced to an individual, right? So we suddenly have this ability to do that. In practice, you can't check every bag, right? So it's going to be spot checking. And I guess we're also trying to rely on this behavioral idea that people suddenly know that what they're producing can be traced back to them. And maybe that creates more of this incentive for them to be a little bit more careful. But some of it's just about not having the knowledge on how to do it. And, that's a different question. Yeah.
Thanks.
So thank you so much for your presentation. Thanks.
Okay, thanks. So we move to the third presentation of this session. Name of the project is Floyd 5G SDN Intelligent Systems for Low Latency V2X Communications in Cross-Domain Mobility Application, and will be presented by João Silva, with Telecom Research and Innovation Engineers at Capgemini.
Okay,
Please.
thank you very much.
Yeah.
So my name is João Silva. I work in Capgemini, where I'm working for the Floyd project. And for this presentation, I will show a brief overview of this project. So in terms of organization for this presentation, I will show first the entities that are involved in the project, then the motivation and the main objectives that led for the existence of this project, the project structure in terms of work packages, and then to be able to detail a bit more about each one of the work packages. So about the entities that are involved, so it's Capgemini Engineering, Altis Labs, Sister, Instituto de Telecomunicações, Vortex Colab, and also with the support of the Carnegie Mellon University. In terms of motivation for this project, so currently there's a big evolution or progress in terms of the mobility industry, especially for autonomous features. And one of the main goals with that is to try to achieve the full autonomous driving concept. There are several benefits and advantages that can come from that. The reduction of accidents resulting from human error, to be accessible to a wide range of users, since there's no need for the driving process, to improve traffic flow, fuel economy, and many, many more. And some of the key drivers to achieve this will be 5G networks. One of the subsets of the 5G networks, which is ultra-reliable and low-latency communications, which is essential to achieve the low-latency requirements of the autonomous driving concept, artificial intelligence, and also autonomous driving applications to assist the vehicle in their journey. For the objectives part of the project, the main goal is to improve mobility services and to accelerate the integration of autonomous driving into society. In this project, we are more focused in a specific real-world application, which is vehicular platooning. So this is basically a method of driving a group of vehicles together and in a coordinated way. To achieve this, we are aiming to build a full-stack end-to-end solution that will be able to support the platoons with the required levels of low latency, reliability that are essential for these type of use cases. Now, moving on to the project structure in terms of work packages. There are 6 that we are working on for the project. So the first one about coordination and management. The second, more focused in the identification of the requirements of the business models for the definition of the use cases of one of each partners that are included in the project, and also to build or to make the overall system architecture. Work package 3 and 4 are more technical work packages. So the third one it's more for network management and enhancements, and the fourth one for vehicular connectivity and applications. The fifth, it's for the integration, validation, and demonstration of all these concepts. And the last one, the work package 6 for dissemination, exploitation, and communication strategy of the project. So now to detail a bit more about each of the work packages. So this is for work package 2. In this figure, we have basically the 5 use cases that were defined by each one of the partners. So on the right side, we have from Altis Labs, it consists in the handover between public and private domain. The second one from robust and efficient platoons from Vortex. The third one to build an emergency braking system to be able to make some object detection so the vehicles can react on time and brake in case there's the need for that. Use case number 4, to be able to offload some of the traffic using Wi-Fi. And use case number 5 for the management and orchestration of all these components. So in this slide, it's, let's say, a summary of the value proposition for each one of the use cases that I was mentioning. So the first one will be to support the communications of the platoon between public and private domains. The second one is to improve the security and the privacy of the data that is exchanged between the platoon members. For the third one, which is focused in the safety scenario, the emergency braking system. So it will be the reduction of human lives lost, equipment damage, improved service quality, and so on. For the fourth one, the idea it will be to improve spectrum usage by using Wi-Fi, so by using unlicensed bands. And so we are able to reduce the traffic that is on the licensed bands. And for the fifth one, it's to be able to manage and to adapt the computational resources if required in the system. Now, to give some more details of work package 3, the main objective is to design and develop the network management and enhancements to support the platoon for these 5 use cases that I mentioned, namely for focusing the private networks, which is it's becoming a more common scenario today for the companies and organizations to own their own private infrastructure. For the monitorization, the network quality of service, and to be able to predict how the network will behave in the future. Edge computing, because it's something essential to be able to achieve the low latency requirements for the platoon, and also the closed loop orchestration for the V2X services. We have in here present the organization of the work package in terms of tasks, and this one focuses more in the use case number 1 and use case number 5. So just to give a brief overview about the use case number 1. So the idea is to be able to do the handover of a platoon of vehicles from a private domain to a public. So in this case, there are two types of private networks. We have in the first figure, the SNPN, which is the 5G standalone private network, which is completely built in a private infrastructure. And on the right, the PNI NPN, which is a private network that is integrated in a public domain. The idea is that the platoon is able to do the handover from the public to private, and also the opposite way, from the public to the private domains. This use case brings several challenges. One of those will be to be able to deploy the edge computing nodes along the path, and to make sure that the platoon leader, in this case, will be connected to the nearest UPF, to have net operations configured automatically in the UPFs, so the service is always available at the same virtual IP, to be able to establish quality of service control loop based on the metrics and statistics collected from the network, to use the N3 IWF, which is the non-3GPP interworking function, to be able to transparently access the service from public and private domains, and also to use access traffic steering, splitting, and switching to be able to manage handovers and traffic across the public and the 5G standalone domain. In this figure, there are some more details for use case number 5. So one of the things that we wanted to do is to apply the follow me edge cloud concept. So basically the idea is to have a vehicle always connected to the nearest base station and also to the nearest edge data center where is consuming some application function for autonomous driving assistance. So we can see on the figure that the vehicle in the time t0 is connected to the nearest G-node B and also edge data center. And the idea is in the future, when that starts to become too far away, it will do the handover to the second base station data center. And for the figure on the right, it's a summary of the monitoring diagram that we have to be able to collect some metrics from 5G core, 5G RAN, and to forward that to the orchestration for the decision making. Moving on for work package 4, for vehicular connectivity and applications. So this work package is more focused in the use case 2, 3, and 4. Like we can see on the image on the left, the elements that are more involved in this work package are the platoon of vehicles, also the roadside camera for object detection, the edge cloud data center, and also the wireless link between a vehicle and infrastructure. We have in here a summary of some of the work that is accomplished for each of the tasks. There are 4. I will name a few. So, for example, for the first task, it was made some model for MIMO links between vehicles. And for the task 4.2, some test bed and simulation robotic test bed was done for the emergency braking scenario to be able to evaluate the end-to-end latency. The other 2 tasks, for the third one, for example, it's important to be able, the vehicle to be able to choose the best Wi-Fi access point. And some algorithms database algorithms were developed for that. And for the fourth tasks, more about the security and safety, of the information, a cryptographic library was integrated in the wireless safety and security layer. For the fifth work package, the idea is to be able to, let's say, to put all these pieces together from the 5 use cases into one end-to-end solution. So to be able to integrate that, to validate that, to evaluate using the metrics and KPIs that we will be able to collect, and also to be able to demonstrate the implemented V2X solutions. Also in the slide, the organization in terms of tasks for this work package. To be able to achieve the end-to-end solution for this project, it was defined some smaller integration lines between the partners. So we have 5 in here in this table. So the first one, some integration work between Altis Labs and Capgemini for the handover between public to private network. The second one for the local cooperative awareness. The third one for the offloading of the traffic using Wi-Fi. The fourth one for the analytics part, also using NWDAF for the 5G core to be able to collect some metrics. And the fifth integration line, it's basically the second one, but with some add-ons, or for example, to have an edge host application, and also to be using multipath for that. In this slide, we have the system architecture that we are proposing for this to include all the use cases and the integration lines. So on the left side, with the blue color, we have the public domain. On the right side, with the orange color, we have the private domain. And in terms of components that are present in the architecture, we have on the bottom right, the user equipment, which will be the platoon leader of the vehicles. Connected, that can be connected to 5G communications or to Wi-Fi if it's available, consuming some autonomous driving application in the edge cloud for latency purposes, to have the 5G core functionalities, and also to have an end-to-end orchestrator for all of these components. For work package 6, the last one, which will be more for dissemination, exploitation of the project. So far, it was already shared the logo, a poster, and the brochure for the project. There are plans to have a website and social media presence. We are planning to have that until the end of the year. We have already a LinkedIn page. And in terms of scientific and technological dissemination, so far, since the beginning of the project, 12 publications were shared in international conferences, and we have several students working in the project in their respective theses. So we have 5 PhD students, 12 master degrees, and also 7 bachelor degree students. For the last task of this work package, which is a stakeholders engagement, the project is active with the advisory board, which is currently composed with the companies Luís Simões and also Visabeira. And in this slide, we have just an example of the LinkedIn page that we have already working, and also the poster that we have shared for the project. And this leads me to the end of the presentation. Thank you very much for the attention.
Thanks. Thank you very much, Val. Questions? Yes. Yes, Jose.
Great project. A question. Do you have a test bed? Are you working with actual companies with trucks and testing?
Sorry. Currently, we have a test bed at least for the work package 4. So for the emergency braking scenario, so if for the vehicle to be able to detect an object and to brake on time, for that we have a smaller scale test bed. And in terms of companies for the project, we are just in contact with the advisory board to have some feedback, and also with the companies that are involved in the project.
So if you really want to get in touch with autonomous trucks companies. There are quite a few, more than one in Pittsburgh. And some of them, at least one of them that I know well, is a spin-off from CMU. They are very successful. They have a bunch of trucks going around. And if your technology gets to the point where trucks would be useful to test them, let's try to do that.
Okay, thank you very much for the information.
Okay, other questions? Well, I had a similar curiosity because in some sense you are proposing a platooning system, but then for the emergency, you are saying that you are going to rely also on onboard cameras and devices like this. So it seems to me that you go back to the, let's say, to the full autonomy, to the idea of having a full autonomous car, because if it is acting in emergencies, then and exactly at the most difficult place of the old system. So I wonder if you see this as a big weakening point, or how do you plan to solve that? Because I suppose these cars will be going around in a mixed environment. There will be also other cars driven by people, by humans. So I wonder how you avoid in the emergency situation the difficult issue of understanding what the other drivers are doing.
Yes, exactly. It will be required to have, let's say, all the equipment within giving information to the system. So the platoon is aware of all the vehicles that are on the road, all the pedestrians, the vulnerable road users. So that will be a challenge, and it will take some time to achieve. But for platooning and autonomous driving concept, it will be essential to have, for sure.
Okay. So you will need to solve the autonomous driving issues. I mean, the big issues there also.
We are trying to, let's say, to give some solutions, because the autonomous driving concept involves several topics. So we are trying to work on some of them to be able to accelerate integration of autonomous driving. But yes, that's some of the work that we are doing currently.
Okay, thanks. Other questions or curiosities? Okay, so we can move on then. Thank you. Oh, sorry, sorry, I didn't see you. I didn't see you.
I really just wanted to make an observation. Thank you very much for the presentation, and I enjoyed it. And thank you also for telling us how you're going to do things. I'm picking particularly on the communication and so on aspect.
Yeah.
And now I want to make it more general. I think a number of these big projects are addressing problems that society will recognize as societal problems, challenges that we face in that way. In that sense, I think it's worth looking at that external communication issue with another dimension as well. If they're societal problems, I think young people will respond well to them in terms of appreciating what ICT and engineering and so on can do for society. And we actually have a challenge of getting young people to sort of come in, getting the gender mix that we need in this sector. So maybe projects like this could take that as a particular thing that they focus on in their communications thing of how do we get out a bit more widely in that sense? Just something to think about maybe for the program as a whole.
Yeah.
Sorry, I didn't completely. Yeah.
Okay.
Thank you.
So thanks again. Thank you very much.
Thank you very much.
Thanks, Joao. Yes, we move now to the last project of the session. The title of the project is Safe Forest, Semi-Autonomous Robotic Systems for Forest Cleaning and Fire Prevention. And the presenter is Michael Couceiro from the CEO of Ingeniarius, with the company involved in the project.
Thank you.
Please.
Yeah, so my name is Michael Couceiro. I'm the CEO of Ingeniarius, the leading company of the Safe Forest project, and we've been working together with ISR and ADAI from University of Coimbra as well as the forest company Silvapore, and of course, CMU. And the objective is to deliver robotic systems for forestry applications. I don't think I need to go to much length to motivate you towards this, I guess. We all know the impacts of wildfires. That's not new. People have been talking a lot lately about climate change. Well, they've been always talking about that. But anyway, climate change has a very, very strong impact on wildfires as other hazards. The difference is that this hazard is very particular because it also has an impact on climate change. It's a cyclic thing. So we need to stop this. Sorry, we will not stop this. It's a natural hazard. It will always happen no matter what we do. But we need to mitigate these numbers. We need to be able to reduce the propagation of fires. And we can do it. There are ways to do it that's well studied. We need to perform some ecological forest management, or more specifically within this domain, what we can do is to somehow control the vegetation, the fuel. And with that, we can definitely reduce the impact of wildfires. And this has been done in many, many ways. Prescribed fire is one of them. People have been using animals as well to reduce vegetation. And another way, a little bit more interesting for us, I mean, we are from robotics, right, is the use of machines. These machines are usually like compact track loaders equipped with forestry mulchers. And what they do is that they destroy the vegetation and leave it into very small pieces. And you don't need to remove those debris afterwards. They can remain there. Because if you remember the triangle, the fire triangle, you need a heat source, and this will always happen somehow. You need vegetation, and you need oxygen. If you reduce the oxygen in between the particles, you reduce the incidence of wildfires. And that's the whole case we're trying to do. The thing is that these machines work great, but they need humans to operate them, and there's definitely not enough humans interested in doing one of the most difficult and less safe jobs on Earth, actually. So what we want to do is to make this machine autonomous. I'm going to start with the scientific impact that we've been achieving so far, the results, because this will give you a better idea of what we're doing. And as opposed to AI-only projects, this is not an AI-only project. This is a collaborative embodied AI project. So it deals with collaborative robots. And because of it, we need to take a look at social sciences and psychology, which is all this triangle comes from, actually, where we have the agent, in this case the robot, which is deployed in a given environment, the forest, and needs to perform a given task. For this to happen, we need to work a lot on what we call the perception-action couple. We need the perception, the robot to be endowed with perception to be able to read the environment, to extract affordances or opportunities for action, and then we need the system to be able to select the best action and execute it. So how can we achieve that? Well, let's start with action, because this is where everything started. We decided to not start from scratch because it does not make any sense. There are big companies out there like Bobcat, John Deere, and so on, dealing with these machines for quite a lot of time. So what we decided to do was to start with one of these machines, try to understand how the inner modules talk with each other, and build a bridge that would allow the mobile robotics modules, the things that we do in the lab, to talk with the machine. So we built this bridge, and we made then the system autonomous. Of course, this required a lot of sensors, 3D lidars, depth cameras, thermal cameras, multispectral cameras, inertial measurement units, and GPS, and so on and so forth. And it required a very, very reliable architecture, which is what you see there in your left. And this architecture needs to deal with something called SLAM, simultaneous localization and mapping, as well with navigation, with path planning, and so on and so forth, all to make the robot to navigate safely within scenarios. Here in this video, you can see one of the pilots that we have run, where the robot, or the machine, if you prefer, whatever, is moving autonomously in a scenario that it does not know. So what the machine does, it extracts useful information, it creates an occupancy grid or a cost map, and through a frontier-based approach, it moves autonomously without colliding with anything. And you will not want a 4-ton machine to collide with anything, I'm pretty sure. So this was the first stage of this project. We are currently dealing with the control of the mulcher, which works quite well. We can control the rotation, the speed, the position, and so on. But there's one big thing missing here to perform this last task very successfully, which is all about perception. And this is where the AI part kicks in. Of course, we do have some AI on path planning and navigation, definitely, but it's not the same. Perception is key. So, and because perception is key, we are no longer dealing only with the ground robot or ranger, as we call it. We have an assistant, the scout, which is a UAV, a drone, and we are also exploring virtual environments to generate synthetic data, because I don't know how many of you work in AI, especially in image segmentation and recognition and so on, but labeling is a very, very difficult task, and we need to try to avoid it. So let's start here exactly in where I left. So we've been developing this Unity-based simulator with very realistic graphics, so that it can generate data that we would acquire in the field, but without going to the field. And the cool thing about this is that the data comes labeled, because game objects already have a given label, and we can use that. And we did some interesting results already. You can see here a point cloud extracted based on real world data, and we're able to segment the data quite efficiently. I mean, you can see the vegetation, you can see the road, you can see the wooden lane, you can see the sky, and so on and so forth. This is exactly what we need. The robot needs to understand what's vegetation and what's not. You will not want the robot to destroy something that it should not want to destroy. And now what we're trying to work on right now in terms of perception of segmentation is to try to identify, because we also don't want the robot to remove all the vegetation for us, right? We only want to remove certain vegetation. So in terms of scout, of UAV, this was very important to augment the perception of the ground robot. We cannot have the ground robot deployed in a forest and expect it to explore and map the forest. This takes time, it takes energy. So there's no point. If we can have an aerial perspective, which is a way better perspective, by the way, because it doesn't move throughout the vegetation, even though it needs to move under the canopy, of course, then the better. And the drone would be able to extract a map that would be provided to the ground robots for the ground robot to operate safely. So this is what we've been working on. We have a prototype with a sensing toolkit, with, again, 3D LiDAR, with cameras and so on. And what the drone does is to extract a very rich point cloud. And with this rich point cloud, it extracts then a multi-layered grid map. And this multi-layered grid map represents not only where the obstacles are, which in this case could be trees or houses if we are near critical infrastructure or whatever, but it also represents where the vegetation is, where the high densities of vegetation are. So with that, we can have a path planner working on top of that extracts the ideal path for the ground robot to perform. And then we're not wasting energy anymore. Then we're spending every single second of our battery to remove vegetation. So I'm going to move forward because we don't have time to present so many things. And then we've been working lately on something else, on augmenting the path planner that we have. So I've been talking to you about occupancy grids. I know that probably you're not familiar with these terms, but imagine that you have a 2D map, okay, from Google Maps, and you navigate through it. It has several disadvantages, especially in forests, where you can have a given planar location. Imagine seeing the top view, but you can have different levels. You can have a bridge, you can have a cave, or whatever. So in a 2D representation, you do not have this richness of information. So we've been studying the way to do this with octrees, which is a very efficient 3D representation of the scenarios, to be able to generate very efficient paths for the UGV, the ground robot, to perform. This is still ongoing work, this one, and it will remain so until the end of the project anyway. So now, let's talk about a few milestones that we've achieved in terms of science, of course. So we had a few technical papers, a few scientific papers, and we've organized 3 workshops. I want to emphasize on this last one because it shows the collaboration between the partners, especially on the workshop organized in ICRA 2022 in Philadelphia. This was a great opportunity for the whole consortium to travel to the US and to meet the CMU team in person as well. We had 12 presentations, 6 panelists, and 313 registration, which is quite a decent number. Again, we're talking about the largest and best conference of mobile robotics in the world. And from these panelists, we extracted a lot of very useful information, not only for us, of course, as a company, but also for research. What are the lines of research that we need to invest on in the near future to make this happen? Because we know that this solution will not fix everything, will not mitigate completely wildfires. We have a whole series of other political sciences and everything around this that we need to take into account. So now I'm going to focus on the business impact, which is also important, especially for a company. I mean, we need to do something with this in the end. And from past experience in other projects, we know that in the end, we will not have a product to put in the market. That's not realistic. It's not the point here. We're going to have a prototype. That's the whole idea. But we know that several components within that project will be reused, as we've been reusing in other applications as well. But what's the whole point? So we've invested a little bit on the business challenge. What is the business challenge of this kind of project? We want to be able to demonstrate that this technology, these robotic systems, increase the dignity of operations, because, again, forestry is a very, very complex and hard operation. Making them safer while reducing operating costs, which is also key. If we cannot reduce costs, this will not sell anyway. The secondary challenge, even though not easier to achieve, is that we need to have the ability to show that this new technology is attractive to vegetation management companies, because they are the ones putting this technology in the market. We generally lack experience in IT-related technology, so it's not easy to talk with them. That's why we have a company, a forestry company within the consortium, to help us talk the same language that they talk. So we defined a few KPIs, a few performance indicators, business performance indicators. They are not related with the scientific aspect of it. Of course, there's some relationship, but they're not directly related. So we need to focus on the safety of human operators. So we want to minimize injuries. This is a key selling point if we're able to do that. We want to increase the hectares covered by these machines. We know that machines are known to be 24/7 sort of kind of operation as opposed to human operators. We need to reduce the severity of fires. This is inherent to a decent ecological forest management approach. And we need to reduce operation costs. Again, as a selling point and as an economical factor that needs to be foreseen in a project like this. This was the first canvas model that we have built. I will not go through all of it. I just want to focus on a few points here. Namely, I want to focus on the kind of partnerships that we can have. Because again, we are an SME and we are working together with academia. We do not have the infrastructures to build these machines, neither we want to. Our key purpose would be to find a partner that does this. And there are several European partners and Americans as well. Well, Americans, they have more naturally. But of course, our first purpose was to find European partners able to deal with that due to proximity, as it is expected. And we have a few companies developing electric compact loaders. Even Bobcat already announced in December last year their first prototype, electric prototype. This is a first step because the machine you've seen there is a diesel machine. This does not sell. I mean, you have a robot, autonomous, and so on. We're aiming at ecological tasks. We're aiming at climate change, and then we're using a diesel robot. Well, it is a technology we have available. That's the next stage. But we do need a partner dealing with the manufacture of these manually operated machines so that we can deploy our system. And how would we build a model like that? Well, we could sell the intellectual property of the hardware itself, the integration of the hardware. That's not our focus. Where we could, however, gain, it would be through a B2B licensing model on the software. This is how it should be done for a small company like ours, because we don't have the infrastructures to do it any differently. Anyway, as I said, I'm not going to go over all this. So I just want to emphasize on a few milestones, business milestones related. We had a demonstrator. We actually had more than one, but it doesn't matter. Flyers, promotional videos, press release, TV show as well. We were in the national TV, and trade fair. I want to emphasize on the trade fair. We were at Automatica Munich 2022. It's one of the largest technological trade fairs in the world. And we had a 25-meter square stand, a decent number of visitors and follow-ups. But the cool thing is that we had a unique selling point. No one else had a machine like this out there. They were deploying, they're showcasing manipulators, AGVs, eventually a couple of UAVs, but definitely none of them were showcasing a machine like this. And that was quite cool. So at last, to end this presentation, I just want to talk about the mobility aspect of it. There's been a lot of mobility, even though in the beginning we were a little bit affected by COVID as everyone, but we had a few runs in with the team from CMU. They came here a few times. We went there a few times as well. And we're going to have long-term stays. Namely Duda, Maria Eduarda will be there for 1 year next year, which she's doing the CMU PhD affiliated project. And we're going to continue doing this. We still have a workshop to prepare before the end of the project. So it is very likely that we're going to meet up probably in the States within the next 6 months. So that is all. Thank you.
Thank you, Michael. Thank you very much. This was very interesting. And please, yes.
Hey, this is really interesting. To what extent are the methods and results dependent on working with the commercial planted forests as opposed to more naturally developing forests?
Yeah, that's a good question. So far, we have a forest site of a few hectares available that was made available through the civil protection. And the forest is quite a very good starting point because it's a forest used by big companies of paper companies. So the forest is nice. It has not a very regular terrain to start with. The trees are well planted, well separated. And we've been working on that scenario. And so far, the results are quite impressive. But we are aware, and this is something we need to admit, that this solution will not go everywhere. It's impossible. Not only because of the plantation of the trees themselves. When they run wild, it's impossible to go in between the trees. We need at least 1.7 meters in between them, and we cannot guarantee that. But also because of the terrain itself. In Portugal is a very good example, Greece as well, and other countries, where you have very steepy regions, which are impossible to move with these machines. And so we cannot guarantee that. But we can guarantee that we can cover a decent area. And good examples of that were the fires that happened in Serra da Estrela this year, which were very devastating. But many of those regions, we could have covered them with this kind of technology. Not all of them, of course.
Yes, let's go. Yeah.
Yeah. Great project also. Looking ahead, 3-4 years, but building those partnerships, okay? Of course, Portugal is a prime example of fires and all that, and I'm sure the Southern Europe, you'll find many. But the other big point coming from the US is, of course, California, okay? In California, you have these huge fires every year. I'm sure you are aware, or maybe you are not, but the former minister, Manuel Aitor, he visited and established relations with whoever in California handles this. And he's trying actually to establish a relation. So you may want to, looking for partnerships, you may want to get in touch with him. And I'm not sure he's aware of the project. Maybe he is, maybe he's not. But establishing early relations with these people in whatever organizations he's in touch with. So, and let me just, on the other hand, CMU used to have a big partnership with Caterpillar. Now, I don't know if Caterpillar uses electric vehicles or uses diesel, but maybe something similar could be a partner for your machines.
Thank you for the suggestion. As I said, we've been focusing on European companies, but there's a reason for that. It's not only about finding a partner to build the machine, because there are plenty of them, and the US actually has more, definitely. We have like 2 companies in Europe that develop electric machines like these. But it's also about legislation, because I'm not aware at all of the legislation about operating autonomous machines in force in the US. So I'm trying to learn, I'm starting to learn now how this could be achieved in Europe, because it's where we are anyway. And as you said, and well, it's one of the worst regions affected by fires, especially the south of Europe. The truth is that even if we were to move forward very fast with a partnership with a manufacturer from the US or Europe, we would still struggle to make this solution go to the market in the near term, because we need legislation. And while, for instance, we've been working in other domains like agriculture robotics that are meant for the private sector, we know that these robots can reach the market because they are for private lands. Here it's a little bit different. Here we would need to deal with problems that we are not prepared to deal right now. But anyway, thank you for the suggestion. It's definitely going to be something that we're gonna explore in the future as well.
Thanks.
If I could just comment, I'm looking at not the whole system, but I'm looking at some of the technologies that you are developing. For example, those point clouds and trying to identify
okay.
and those subsystems. Those could be very useful in regardless of the policies and regard of the legal environment and so forth. So it's in that sense, maybe not the whole.
Okay, thank you.
Thanks. Yes, we have time for a couple of questions, still a couple of questions. Yes, please.
I think we have one there already.
Yeah. Yes, there is one. Yeah, please.
So my question is, you have collided, thank you so much, that you have collided two technology, one is perception, second one is the sensor one. The problem is like the UAV can reconstruct the land which have like very clear, but in forest we have very congested areas. So how you reconstruct that one, and what algorithm you use for it, like graph neural network or deep learning? The second question is about the animal ethics. If we will remove all of this dead grass, so the small animal will be like affected. So there is any possibility that we will between two parts of the forest, and we will clear a small portion, and we will keep the animal as in natural state, also the forest to be protected. Thank you so much.
Okay, I'm afraid I didn't understand completely the question in the beginning. It was related with the drones and the perception and so on. So just to clarify, we're moving in two parallel directions. So we have the drones, but we still have the ground vehicle anyway, and performing very similar methods in a way. So they do extract point clouds, reach point clouds, and then they do apply CNNs on top of that to try to segment relevant classes within the point clouds. So this is the general approach, and we can do it with drones or with the ground vehicles. Of course, that, as I said a while ago, we're still working on a site that it's not very complex in terms of structure of trees and so on. So we've been successful so far, but we will need to test on more challenging regions. As for dealing with animals and the flora and the fauna, so when we say about removing vegetation, we're not talking about removing trees that we want to keep there. We're talking mostly about removing ground vegetation, okay, which is what we need to remove. Of course, this affects anyway the ecosystem. It's inevitable. But if a fire happens, well, it affects a little bit more, right? So I'm not the one that's going to dictate what needs to be removed or not. We're just facilitating the technology, okay? Ecological forest management is a science on its own. So we need to let the people from that science to study what should or should not be removed. And then the machines, I'm pretty sure they're going to be able to do that in the long term better than humans can do.
Okay, thanks. Maybe the last question, John?
So thank you once again. I like the project, of course. I want to pick up on what you said about the legal issues or regulatory issues, as I would say it, and just relay some experience. Maybe you're doing this. But some years ago now, working with the aerospace industry, we were working on mixing people with robots for really big things, which was at that time not allowed. And we ran a big project with industry. And the guy organizing it did something really smart. He got someone from the health and safety executive to become a member of the team so that they became part of the solution, not the problem at the end. And interestingly, partway through the project, realization dawned on him. He said, you know, this could be safer. So maybe you already are, but I mean, really what I take from this is, if there's going to be a blockage around regulations, get the regulators
We
involved
need to attract the right
early,
people.
and it can be transformative.
Okay, thank you for the
Okay.
suggestion.
Okay, thanks. So I think this was a comment. So let's thank again. I think we can close the session, and then thanks all the speakers today. They were all interesting projects, and we break up for 5 minutes. Okay, thanks. Thank you very much.
Thank you.
We will now pause briefly for a 10-minute coffee break located at the back of this room. We will resume for the panel, Explorative Ideas for Ambitious Goals.
Okay. Okay, so can we start the session? Welcome to the session on the exploratory projects. So we'll have 3 talks about the new 3 exploratory projects. And the first one is by José Fragoso, who's going to present the project Divina. José, would you like to start?
Eu uso isto para andar para frente. So, hi everyone, I'm José Fragoso Santos. I'm an assistant professor in Técnico and a researcher at Inesc ID. I'm going to talk to you about our exploratory project Divina, detecting injection vulnerabilities in Node.js applications, that brings together a team of researchers here in Portugal, Inesc ID and IT. So me, Nuno Santos, also from Inesc ID, and Pedro Adão from IT. And on the CMU side, Limin Jha and Luyo Bauer. So Node.js applications are everywhere. So we have, I'm looking at this because these were not exactly the last, it's not exactly the last version of the slides, but there's no issue. So, but coming back to the topic, so Node.js applications are everywhere. In particular, they are used by many high-profile companies, such as those that you can find in the slides. They are used for many different things. They are used to build server-side web applications. They are used to build IoT applications, and they are used to build desktop applications, but they are mainly used for server-side web applications. And when it comes to these server-side applications, they are actually the developers, Node.js is actually the developers' technology of choice. We see here in this diagram that it's the first technology of choice. This survey is slightly old, it's from 2020, but I've checked the current survey, the current results today, and Node.js is still in the first place. So it's still the preferred technology to build server-side web applications. And even though Node.js is very popular, it comes with important security risks. Some of these security risks are shared by other technologies, but others are specific to Node.js, and in particular to its development model. In particular, and what are those specific risks? Well, they have to do with the fact that in Node.js, developers are really encouraged to share their code among each other. So when I'm building a Node.js application, I can use my own code, but I also rely on other people's code via the Node.js package manager system, NPM. This means that me, as a developer, I developed my own module, and I'm free to publish it in NPM for other people to use. But I'm also I'm also free to import other modules developed by other people, This, as I see, it's both a great strength of Node.js and a great weakness as well. Why is it a strength? Because me as a developer, I'm allowed to build on other people's work. So I don't have to develop everything from scratch. I can just rely on other modules developed by other people. But in doing so, I might be bringing security vulnerabilities to my own applications. I don't know whether or not these modules are trustworthy. Should I trust them or not? And we know that developers don't have much time. So imagine this scenario. I'm doing a new feature. I would like to use an existing module developed by another person, but I don't know I'm not entirely sure whether or not this module is trustworthy. It can have a vulnerability. I don't know. What will I do? Develop that module from scratch myself in order to be completely sure that it doesn't have a vulnerability, or just rely on it? So most developers will just rely on it. So developers have little time and actually little help. And what we want, and to answer exactly those questions, which packages should be trusted? Is my package vulnerable? Should I update my package? And the point is that these security risks are real. They are not just theoretical security risks that might or might not happen in practice. These are real security risks that result in real vulnerabilities that are exploited by attackers to mount sophisticated attacks. So we really should try to do something about this to fix this situation. And this is exactly the goal of the Divina project. What we want to do is to develop new techniques and tools for identifying injection vulnerabilities in Node.js applications. Because this is an exploratory project, we will focus on a specific type of vulnerabilities, these injection vulnerabilities. These vulnerabilities allow attackers to run arbitrary code in the targeted execution platform. And what is the Divina team? Here it is. So I've already described the faculty members. So on the CMU side, Limin, on the Limin and Luyo. It's missing Luyo. Luyo is there, so my mistake. And on the Portuguese side, we have me, Nuno, who is also going to present another exploratory project, and Pedro Dão. Pedro Dão is here. We have three wonderful PhD students working with us, Nuno Sabino, Felipe Marques, and Tiago Brito. Nuno as a dual degree CMU Portugal scholarship, and Felipe as a CMU Portugal affiliated program scholarship. And this is great because they will be able to continue the work that they are currently doing in the context of this project throughout their PhDs. We also have 5 master students working with us, and for RAs, the number of master students fluctuates, so this 5 is approximative. So, as I was saying, our goal with Divina is actually to find injection vulnerabilities in Node.js applications. How are we going to do this? So our plan, what we're doing is that we are combining dynamic tank tracking with symbolic execution to achieve better precision and effectiveness. The dynamic tracking aspect, on the dynamic tracking aspect, we are leveraging on the work that has been performed by the CMU side of our team that have a long track record on developing taint analysis for JavaScript. And on the symbolic execution side, we are leveraging a symbolic execution tool that we had developed here in Technic, but also at Imperial College before Technic. And what are we actually doing? Very simply, and in one slide, this is more or less the idea of the project. We pick a Node.js package, we compile this package to a simpler intermediate language, but in this compilation step, we are inlining a taint tracking mechanism, and then we feed the resulting program to a symbolic execution engine that has some primitives, extra primitives to reason about taint and how taint propagates. And this is ongoing work, so the project will end in March 2023. But we've already good results, we think. We have set up a data set consisting of 973 real-world projects annotated with their existing vulnerabilities. We have extended a compiler for JavaScript from a very, very old version of JavaScript to a more modern version of JavaScript, and we have developed this OmniTaint, a dynamic taint analysis tool for identifying ACE and ACI vulnerabilities in Node.js packages. And so this concludes my talk.
Okay, are there any questions? So there's a question here.
Hi, thank you very much for the presentation. So my question would be, if I understand correctly, you make first an analysis of the flow of the program, and then you execute it symbolically, right? So in this second, as JavaScript is a highly dynamic language, how do you make the symbolic part is quite difficult. So how do you, if you had a perfect symbolic execution tool, for instance, you could just run the symbolic execution tool and see when it crashes or when it detects that tainted properties and that sinks, when the attributes get to that sinks. Do you think that this tool could be developed? If so, how much time would it require for it to be developed? What's the medium to long term research space in this area look like?
This is slightly funny because this is my student asking a question. And what he's pointing out is that it's difficult to have a symbolic execution that works well with JavaScript because JavaScript is very dynamic. So there are too many. Symbolic execution explores multiple executions of a program with symbolic inputs instead of concrete inputs. But in JavaScript, because it is dynamic, it has such a complex semantics, there are too many paths to explore. So in a sense, we have to guide the symbolic execution to the paths that we care about. And what are the paths that we care about? Are the paths that may lead to a security vulnerability. So we need to actually complement our approach with heuristics that actually tell us some paths are not interesting because for sure they will not lead to security vulnerabilities. And you have to focus on these specific paths that actually may lead to security vulnerabilities. And in a sense that is, so the short answer is that symbolic execution will not work well on its own. It needs to be complemented with some heuristics that guide it to the paths of interest. But I didn't tell him to ask me that. Yeah. Yeah.
If there is prospect for it to being a complete symbolic execution tool, and if so, what would be the timeline for it to happen or to appear?
That I cannot answer. I don't know.
Okay, thank you. Any more questions? So maybe I can ask one. Have you compared your tool with the other state-of-the-art tools? And if so, how does it compare in terms of precision, recall, and metrics like that?
So the point is that this is an ongoing project. And we think the comparison is really, really important. And we have to compare, because what we're saying is that we want to be more precise and more effective. So comparison is key. To do this comparison, what we started by establishing this data set of Node.js applications, okay, real Node.js applications that have vulnerabilities and that are annotated with the precise locations where those vulnerabilities occur. And that is done. And so this data set gives us a great ground truth to exactly perform this comparison that you are suggesting. But given that this is an ongoing project, we are not at the point of the project where we can perform this comparison. But the short answer is that we really want to do that, and we spent a lot of work and effort establishing a data set that will work as a ground truth to give us a really, really good comparison. And that's and also that data set obviously is a trick, because this data set gives us because we have the data set a priori, we can use the data set to guide the design of the tool. And that's what we are actually using. We have this data set, and we are using this data set to guide the design of the tool and to make it really effective. Then we also want to apply this tool to Node.js packages in the wild, and not only just those that have been previously identified as containing security vulnerabilities.
Okay, so and then just to finish, do you have any specific plans for technology transfer? For example, making your tool available as part of a popular IDE or a GitHub application, something like that?
So as I see it now, the use case for this tool, rather than the integration with an IDE, would be it will be part as testing pipeline. So the tool would run after you commit your code to the server, and then it would be at commit time that the tool would run. But yes, the short answer again is yes. We want to make the tool available, and we want to help to, and we want to make, and we will make an effort to make it as easily accessible as possible.
Okay, thank you.
Well, let me just do a follow-up on that, actually. Like, so you mentioned about that your tool will have this vulnerability report, right? That maybe an analyst will look at it. So I guess it's not just important to find a flow of potential vulnerabilities, but it's also important to have usability so that the analyst can actually check if this vulnerability is a false positive or not. Are you thinking of actually working on that report to make it more easier to be identified if it's actually a true positive or not? Or are you just focusing on a part of actually trying to detect this flows?
The point is that with symbolic execution, and this is a point for symbolic, but also for dynamic thing tracking as well, is that these vulnerabilities, they come with a proof of vulnerability, so to speak, because you will get the concrete inputs that actually drive the attacker-supplied input into the sink. Yeah. So in the report, you will have, okay, here is the sink, here is the source, and here are the concrete inputs that drive. Now we could spend an indefinite amount of energy making this report as good as can be. For instance, what we could do, we could highlight the lines, highlight the path in the code. There could be an immense number of things. Whether or not we will have the resources to do that, that remains to be seen. But that's, again, it's something that we care about very much, which is how do we make developers care about the reported errors? Because it's not just about giving them, here are the errors, but actually showing them that the errors do exist so that they can act upon the errors. So it's a thing.
Yeah, thank you very much.
Okay, well, let's thank Jose once again. Thank you.
Thank you.
All right, so our next speaker is Alexandre Ferreira da Silva. So he's a professor and researcher at the Escola de Engenharia da Universidade do Minho. And he's going to talk about Prometheus, which is a framework designed to make it easier to do research and education to access to space.
Yep. So thank you, and good morning, everyone. So my name is Alexandre Ferreira da Silva, as colleagues said, and I'm from the University of Minho, and I'm the PI of the project Prometheus. The project Prometheus is done between the University of Minho, Technical Year in Lisbon, and the CMU colleagues as well. So our goal is to provide easy access to space. It's like Prometheus, the Titan that gave the fire stole the fire from the gods and gave it to the mankind as a knowledge. So we want to do a similar thing, but with a satellite. We want to be able for you to learn satellite design on a classroom with a real satellite that you can play with it in the classroom and knowing that that satellite that you are handle is in space. That's the goal. So we are not playing with a kind of a toy or a kind of a model that resembles a satellite, but we are really playing with a satellite. Of course, they're doing this with a real satellite, one of the CubeSats or things like those or bigger. It's very expensive. It's not compatible with classroom or research purposes. So we decided to make an open source design that anyone in this room, if it is enthusiastic or if it is a researcher, can build it, can play with it, can program it, and can be sure that if it does the right steps, it can send it to space. So our goal is that Prometheus aims at giving access to space for everyone. So we divided our research into 3 threads that we feel that is necessary for you to be able to launch your satellite and build it. One thread is regarding the license and regulations and service, and this is very country dependent. So it's hard for us to follow a model because colleagues from the SMU have experience, but their experience is not fully transferable for Portuguese scenario. There's a few regulations here that are a little bit different, so we need to be able to know that and learn or teach about that because there is no guidelines. So there is no documentation really available that tells you what are the steps that you need to do and help you fill all the forms and things like that. So it's a very complicated process that we are trying to streamline. It's not easy, especially in Portugal where we are doing our first steps in terms of space access, right? We have our PT Space Agency born 3 years ago. So we are still in the early steps. So these processes internally are not streamlined. Then you have the hardware, the satellite itself, and then you have the outreach. So let me talk about the licensing and the regulation. So we have at least three elements that are mandatory. One is the register of the frequency. Your satellite is going up there. So you'll have a frequency, a communication frequency, and it needs to be registered. It needs to be known. And this needs to be disclosure to the entire, basically, world, or at least European Union. So we need to do that advanced publication information. It's a kind of a form that you fill out, but then the question is that it's not submitted by you. It's submitted by ANACON, our Portuguese communications agency. And this is a little bit tricky process because then you send this to ANACON, but ANACON, and then you lose control of it. So ANACON deals with the entire process. So it's not a very streamlined process. Also, there is a few requirements. First requirement is that you need to have an amateur radio license. Well, I took one. Then when I was submitting, well, there are 3 levels of those licenses. I just had the first level. It was needed the second or the third level. So I wanted to do the second level. I need to wait 2 years because I did the first level. So we ended up registering the satellite to amateur radio association, AMRAD, because we were not able to do it ourselves. So these are one of those learning curves that we need to be aware. So that's why, for example, here in the University of Minho, we are trying to foster our students for the first year that they are doing telecommunications engineering or aerospace engineering to really take their licensing test, because otherwise, when they are on the third year, they are not able to register their satellite. Then you have the frequency coordination that you need to fill out another form, send it to US, to that International Amateur Radio Union. It's a panel of amateurs, radio amateurs, but still you need to ask them, and they will tell you which frequency you can use it as well. And then there is the launch service agreement. So you need a launcher provider, right? Someone has to launch it, right? So we are doing this through SpaceX. SpaceX will launch the satellite, but we are not working with SpaceX. We are working with a broker that basically sells those launching service. In this case, it's Foster Systems. It's a Spanish company founded by a 17-year-old guy that is amazing, and he's doing this, and he launched the service. And he also does one thing that you need to do for launching, is that ensure that your satellite survives the launching. So it needs to do the testing and everything that ensures that green light is given to you and say, okay, your satellite is good to go. And this is only for launching. It's not in terms of functional. It can be launched and it doesn't work out up there, but that's another question, okay? So we have all this paperwork that we need to take care. The launch service, for in our case, is a little bit more tricky because we are a 3-party consortium. So it means that 2 are Portuguese, 1 is the US, the CMU colleagues, and there's export situations here that we are dealing, so it takes a little bit more time. But hopefully for future ones that want to launch here in Portugal, it's a little bit easier. Then it comes the hardware. It's a pocket cube. It's a 5 by 5 centimeter cube. So it is very small. It fits on your hands. It's very small. It's very light as well. This is already the prototype that is available at the CMU. It's based on COTS components, so components that you can easily find on electronic component suppliers, right? They don't have like military grade or something like that. They don't have it. We are using things that are available for everyone to use. It needs to be that premises. It can be programmed in Python, a language that most students nowadays work and know how to program. And we try to do as less expensive as possible. I didn't put low cost, not cheap, because it's not cheap, okay? Still, it's not cheap, okay? But we can try to lower the cost by ensuring that all the design can be hand soldered, and we are using COTS that are easily available, and there are small prices. You can see all the different boards, the batteries here. The only thing that is missing, is not showing here, is the outer shell of the satellite. This is full of solar panels for charging the satellite. But then we have the satellite upstairs, but you need a second part of the hardware. This is the ground station, something to communicate with it, right? So we are using Centro Espacial Português is a permanent ground station here in Lisbon, in Técnico, in Tagus Park. And we can use it for tracking the satellite and communicate with him. But still, if you are doing this on a classroom, your student cannot come here to Lisbon every time he needs to communicate with the satellite, right? So we need to figure out different approaches. And the different approaches is using these other do-it-yourself designs. We have two models available right now that are the TinyGS and the SatNogs. That are two models that are widely available, that anyone can build their own ground station at their homes and communicate with the satellite. The TinyGS is a very low-cost one. It's with a fixed antenna. It can track all the satellites with a given frequency. And the SatNogs is a little bit more, it's like a improved version, because it allows you to have a rotation antenna that gives horizon to horizon field of communication with the satellite. And the interesting part of these ground station designs that you have a lot of them spread all over the world by people like us, amateurs. They are not professional. They are very enthusiastic people that want to use them. And they use it to track satellites, to do pings, to retrieve information, for example, from the NOAA satellite with weather information or pictures when it passes by you. And another detail of this is that it allows you to use a ground station from the other side of the Atlantic if you want, because many of these ground stations are network-based. So, for example, the TinyGS, all information is available online in terms of when a given satellite has passed by that ground station. So you know that it passes, and you have like a log entry with the entries and some data that you was able to download. On the SatNogs as well, but the SatNogs is more interesting because it's like a first in, first served. So you basically book the ground station, you program it to do a given rotation with elevation and altitude, and it follows the satellite, so it allows you to communicate. And you can control it. It's a ground station that you can control it remotely. So we have these two ground station designs that we are working on as well. But then you have the outreach. It's more like how you can build it. I have the design, I have for the satellite, for the ground stations, I have all the paperwork done, but then I have to ensure that you are able to do as well. And that's a little bit trickier. So we are trying to do we have a repository available now, where we'll try to put all this information in a very easy way for you to make it. So that we'll have the requirements that you have to have beforehand. Before you start, you have to know what you need to have in order to launch your satellite, how to register the satellite. Then you have the assembly instructions. We can give you the board designs fully open. This is all open source. There is no proprietary situations here. So this is all open source, as well as the ground stations. The idea is for this to become all fully available to anyone. So the part of the project is to validate how to do this disclosure, how to do this outreach, how to specify and how to provide all this information. And then possibly give some workshops to teach people how to program or specific other teaching components that we might feel necessary. So how are we in the project? So far, basically, we have been dealing with the paperwork. It's been a chaotic thing. So we have finished the ITU thing. We are waiting for the outcome. The ERU, we are waiting for the outcome. I sent the presentation last week, but we have sent this to the ERU this week already. FOSA systems, all the entities like CMU, University of Minho, and the IST are having their lawyers reading the agreement, just to be sure that there is no questions of liabilities and customs involved. On terms of hardware, well, you all know we have a stock, lack of stock in terms of ICs and things like that. So we are completely always revising this bill of materials, because some components that we are using this prototype now are only available by the end of next year, which is impossible for us to do this way. So we need to replace those with other designs. Hopefully we are closing this so that we can start the assembly early next year. And hopefully the launch will be on the third quarter of next year. So that's what the agreement says. So it means that we need to send the satellite at least 2 months before for testing and for being then sent to the SpaceX. Long term, and these like the spillovers or what goes beyond the project. Well, we have the design, we have the satellite running up there. So what we want to do is ensure that we have a kind of a kit of 10 cubes, 10 pocket cubes on a classroom, so that we can try to really do education work with those pocket cubes. And even for people that want to do experiments and microgravity, they can use the satellite design as they only have to do the payload and they can send it up there. So this is it. This is the team. And for those that want to go or might go to the University of Minho once, that's Prometheus, the statue at the entrance of the campus of Gualtar, hanging on a cliff with a liver exposed, but with a fire in his hand, always telling the way. Thank you so much.
Thank you so much, Alexandre. So do we have any questions from the audience?
So using Python, which is a very convenient language, students know.
Mm-hmm.
The thing I worry about is there's no way of rebooting this thing.
Oh yeah.
So
yeah.
is there a layer, operating system layer with a heartbeat and other things to make sure that it never dies for good?
It is, and it is a requirement. So on one of the process, the ERU process, we need to do what happens if you lost contact with the satellites for a given period. So our strategy is there's a firmware there. So there's a watchdog timer that basically triggers, and depends on, for example, for 5 days, if there's a reboot. If you don't do a kind of a contact for 5 days, it reboots the satellite. If it is by 7 days, it will do a factory reset. And if it's for 2 weeks or 1 month, then we shut down the satellite itself. So we need to, this is something mandatory. We need to be sure that if something happens, the satellite by himself can turn off. Okay, you'll be up there for around 2 years before re-entering on the atmosphere.
Okay. Any more questions? So I do have a question. So you're trying to do this in a classroom, right? So there are going to be some teaching goals.
Yes.
So what kind of activities can the students actually like program or try to interact with the satellites?
Yeah. So for example, the first level is like understanding the subsystems that are involved in a satellite. Then you can divide it. You can have students working on the attitude control of the satellites. We are not worried about this right now because we don't have time for that. Basically, if it goes, it will be tumbling on space. But you can have students working on attitude because he has IMU, he has magnetotorquers, so it allows you to control the attitude of the satellite because he has a camera. By default, he has a camera on the payload. So if you want to take pictures, not that great, but you can use it to take pictures. Then you can also use to learn or to teach about telecommunications. Because it's done by Laura. So the frequencies and the antennas design, both in the satellite, but also on Earth, how you can build all your antennas, having the best pattern in terms of radiation so that you can really communicate with it. So there's a few things that you can basically disassemble the satellite and work as a package. Basically, each one of those boards basically can be seen as one package for teaching.
Okay, awesome. I think we have another question here.
So congratulations for your project. Just to point out, all these projects are explorative research projects, so the funding is quite short. Yeah. It would be better to have more funding afterwards, but I was trying to realize, for example, Jose mentioned that there were PhD students involved. That means that the project will finish, but somehow the research will continue. in our case, what are the plans once you run out of money?
Yeah, I didn't talk about, we have master students involved, but our goal on with this design is that we can have, let's say, we can try to have a recurrent launch every 2 or 3 years of a satellite that has been improved somehow, or is a new design given by already made by some students, or that can feed then a research as a user of the payload, if you want. If you are not interested in the satellite, but you are interested in running a kind of a experiment in microgravity for a period of 1 year or 2 years, and then you can use the satellites as a host, right? And you design the payload so that you can run the experiment, or it can be just improved designs, and that people can do their PhD in terms of attitude control, better methods. Because there's another issue here is when the satellite is launched. For a couple of weeks, we are not able to communicate with him because he will not go alone on the launching box, right? So he'll go with a bunch of satellites with him, and when they are launched all together. But when they have different masses, with time they start spreading, right? But for the first couple of 2-3 weeks, we are not able to communicate because they are all together still, and this is also a research issue that we have. It is one of those research questions that we don't know how to figure out, but there's a few things that this will open for research purposes.
Well, thank you very much, Alexander.
Thank you.
Okay, so the final talk of this session will be delivered by Nuno Santos from INESC-ID and Instituto Superior Técnico, and he'll present the project Dianon. Thank you, Nuno.
Okay, thank you very much for the introduction. My name is Nuno Santos. I'm from IST, and I'm happy to co-lead this project along with Bernardo Portela from Universidade do Porto, and also with the help and the support of Nicolas, Christin from CMU. So the goal of this project is basically to develop a set of tools to help the law enforcement authorities in cybercrime investigation occurring and taking place in the on the dark web. Okay, and so I'd like to draw your attention in this slide. So this slide here shows a snapshot of a website, and that website looks quite a lot like Amazon, a bookstore like Amazon or eBay, where you can buy, books or other kinds of assets. As it turns out, if you look closely, this kind of website there, you can buy other things. You can buy drugs, illicit drugs, and other kinds of things that are not legal. Okay, and so this is the kind of stuff that we happen to find in the dark web. Essentially, this is basically an ecosystem of websites and service providers that basically offer their services and sell their goods to other customers for these specific kinds of illegal activities. Okay, selling drugs. In some other cases, there are services for selling data for the purpose of identity theft, credit card information, and even selling services as they're also termed today as cybercrime as a service, like hacking services or even hitman. Okay, so this is serious stuff. And so what makes the dark web so special? The dark web is special because it essentially, from the high level, it doesn't give you any different kind of experience than the typical web experience, but it is backed by an infrastructure that gives the users and service providers a high degree of anonymity. Okay, so what we are seeing here today is like imagine that you have a dark web site deployed on our right-hand side here, and then we have a client, and essentially what this means is all the traffic is relayed through a bunch of series of intermediate nodes deployed around the globe, which essentially they encrypt the traffic multiple times, and then they pass those packets from one hop to the other until they reach the destination. Okay, so what we're showing here is a typical anonymity network, and the popular network today that offers this kind of services is the Tor network. Okay, and what makes this so hard is that even if ISPs, your internet service providers, will collaborate in order to investigate this kind of communications on the internet, they're quite limited because they only have a vision of a very limited section of the network. Okay, so you can only see what's happening at the client side, or in the middle of the node, or in the middle of the communication, or near the dark web site, but you don't have the entire awareness of what are the endpoints, the source and the destination endpoints. You don't know the ultimate IP addresses of these communications, and so it's very difficult to track the source and destination. Okay, and so it's this level of difficulty that makes it hard for police agencies to investigate what's happening in the dark web. Okay, and so our goal here is essentially to try to assist, right? How can we come up with a system that can help law enforcement authorities to investigate what's happening in these situations, and offer a useful service that will help them to conduct cybercrime investigations. Okay, and so this is our idea. Okay, essentially the high-level idea is to build a system, a distributed system, large-scale system that will help to de-anonymize the communications end-to-end. How? So the idea is to essentially intercept the traffic in multiple ISPs across the globe. So this traffic is not going to look inside the packets themselves, because that would be useful because packets themselves are encrypted. So you can only observe some statistical properties like the volume of the traffic or the time between packets, so all that kind of statistical information. And so the idea is to have multiple vantage points deployed around the globe, involving the cooperation of ISPs. And so those ISPs would basically collect that information, centralize that information, and then try to perform a series of analysis over that traffic in order to correlate those endpoints. Okay, and so the idea is that by providing this service, you will have the ability to identify with a high degree of certainty which clients are communicating with which service. So this is the general idea. Okay, and so essentially to make this happen, we are currently designing a tool that we're calling Torpedo. So Torpedo, because it's the system Tor, we're not basically, or this is focused on Torpedo, but the general techniques that we're developing can then be applied to other systems. And so essentially the idea is to build the system as a federated, decentralized system, okay, which will be deployed with cooperation of multiple ISPs. So some ISPs can be located in Portugal, others in the US, others Germany, anywhere in the world, as long as they are willing to cooperate with that. And of course, this will also involve the police authorities themselves, because they have to mandate the proper acquisition of traffic statistics. Okay, and so once this is done, so the idea is to build an infrastructure that will basically allow for collecting, analyzing this traffic, and then offer a query interface to law enforcement agents, okay, so that they can ask questions like, I would like to de-anonymize sessions taking place at this date between that time and that time frame, okay, potentially involving certain ISP restrictions. And so our ultimate goal is that our tool, by performing this analysis, will give away like a list of potentially correlated or correlated sessions that we call Tor onion sessions, revealing the IP addresses of the source and the destination. Okay, so we are building this. In order to build this, we are basically working around. Our solution is basically relies on a set of stages, like a pipeline of processing stages that are based on multiple machine learning classifiers, which we train so that they perform individual tasks, and as we collect the traffic from one endpoint, and then we move on step after the other, so that in the end we have matching flows between endpoints. So I'm not going to go through all the stages, but essentially the idea is as we move from the left to the right, we have those ISPs collecting some of the features from the traffic, and then we then distinguish whether they are clients or onion services. We move on to exclude some flows that are not relevant. And then after that, we perform a series of combinations where we try to match certain clients to certain destination endpoints, and then perform an operation. And this is the correlation, so-called correlation stage. And this is the heart of our system, where we're actually going to match to see if these flows are correlated with high degree of certainty. Okay, and so in the end, this will give us like a scoring system, or a scoring, or a particular score that will tell us how confident we are regarding the potential levels of correlation between endpoints. So the pipeline itself is already novel, but we want to push the research frontier a little bit further. And here the real challenge is regards the correlation stage. So at the moment, we are basically relying on the state-of-the-art solution, which relies on a deep learning technique, which is very slow. Okay, this is very slow, and it's not producing, or it was not producing the best results in terms of accuracy, because in our system we want to ensure that the system is really precise. We don't want to incriminate any innocent people, of course. So the system needs to be very accurate. And so this was one of the research problems that we're facing. So how can we basically scale up the system so that we have enough power to monitor the entire network, and then to produce results with high accuracy results and at real time? Okay, so this was one of the research questions that we have. In particular, we had not only this question in terms of research direction that we were pursuing in this Explorative project in terms of the improving pipeline scalability, but also other two very important points, which is the second one regards the aspect of privacy in terms of protection of consumers' privacy of ISPs, clients, customers. So ISPs, they don't like to exchange information about the traffic going on in their networks, and there's also legal frameworks that prevent sharing of that kind of data. Okay, so the question is, can we actually still run the system? And on top of this, we employ some techniques to enable this kind of processing in a privacy-preserving manner. So this is our second research question. And then the third one is, how can we prevent abuses? Okay, because this has the other this can be abused for, and we're already, people have raised this question in terms of potential risks for mass surveillance, of course, okay, and we're aware of that. And so can we prevent those kinds of abuses and ensure that the system is used only for lawful purposes? And so far, I think we've been doing very good progress in all these fronts, but especially in the first one. In the first one, we, over the last few months, we managed to come up with some very cool techniques that actually we managed to improve performance by 4 orders of magnitude. So it's really fast now, and with the benefit that we don't even need to resort to deep learning classifiers, which means that we don't even need to train traffic, which is fantastic. So this technique that we have right now is very promising. In the other fronts, we have also we've been exploring how we can employ techniques like multi-party computation to ensure that the pipeline can still work in a fully distributed manner, while the ISPs only share, they don't share anything, practically anything about the local data of their customers. And finally, in terms of the security aspect, we are thinking, or we are currently developing a distributed protocol, access control protocol systems to ensure that you need to have not only multiple ISPs collaborating, but they can only make progress insofar as they have the authorization of one or multiple legal entities that will grant access to the platform. Okay, so all of these points are currently in progress. So most of this work, I mean, the really hard work has been conducted by our PhD students, Daniela from Portuguese side, and Mark from CMU. And then I have the pleasure to be working with a lot of fantastic people here, from Nicolas from CMU that I've already mentioned, and then Bernardo, who's also around, and other folks. Okay, and so yeah, this is it. So in terms of conclusions, currently the police the police agencies, they face a lot of difficulties in terms of investigating cybercrime on the dark web. We are developing this system that can provide assistance, this kinds of assistance, and we are at the moment developing techniques to ensure that the system, if deployed and when deployed, hopefully, will be used in a responsible manner. And this is it. This is my contact information. Thanks a lot. I'll be open to take your questions.
Thank you very much. Questions? So there's a question there.
So on the concerns on legal matters, so for example, when you have, okay, the privacy that is needed for individuals in oppressive regimes, etc. For example, in China, it could be possible to de-anonymize, but you have the solution of saying, okay, we require multiple legal actors in order to proceed with the de-anonymization. My question is, even in countries where that is not the case, we have also some cases, for example, Edward Snowden, in which this could be used against the people, and how can we trust even multiple institutions over the privacy that some individual may require to go against them in these particular cases in which that might be a problem?
Yes, yes. Okay, so thanks for pointing that out. I think one of the aspects that in our system that we hope that will prevent abuse is that the system is not going to work. It's not possible to work unless you have multiple organizations from multiple countries working, collaborating, okay? And if one of them does not or refuses to collaborate, or if multiple of them refuse to collaborate, the chances are is that the tool is not going to be very useful, because you're not going to be able to collect information, enough information so that you can trace the entire path. Because if you remind the diagram that I showed earlier, these paths they traverse multiple countries, okay? So the idea is to have like this federated system, so that you really need to have the cooperation of multiple entities so that they can also make themselves mutually accountable. So this is one aspect. And then the other aspect is that our system is built in a way that, at least the way we envision it, to operate exclusively within the boundaries of the law, okay? Which means that access to this system can only be granted as long as the judge gives you the permission, and the police have warrants to use these tools, okay? So this is what I would say.
Okay, any more questions? Okay, so can I just ask something? Sure. You want to ask a question? Yeah.
With law enforcement agents.
If I have
discussed this project with law enforcement agents.
Indirectly in some cases, but I don't have any specific project proposal or with them. But I'm open to.
But do you have any plans to test the system in the future, at the end of the project, for example?
Well, I mean, at the moment we are still performing a lot of experimental work in terms of seeing how well our techniques scale, and we're building this. Prototype probably will need to develop multiple aspects of the system so that the entire thing will then make sense and is robust and all of that. And I think once we are convinced that the entire system is deployable and is ready to work in the real world, I think we should try to talk to the police authorities.
So I noticed in your project description that you use your own data and your own traffic. And my question is, how do you ensure that your data is actually representative of the real data? So in other words, you're developing this based on your data. When you put it into production, can you really detect the bad guys?
Yeah, this is a great question. This is actually something that we are currently designing at the moment in terms of how do you build this data set, a representative data set that on the one hand you cannot use, and you cannot, for multiple reasons, for legal reasons, also for technical reasons, because you cannot intercept people's traffic. And so how can you build this data set, representative data set, that you can use to test your system in a way that it actually mimics or is representative of what we find in the real world. Daniela, who's our leading student, she's currently building this data set, and our approach is basically to have to emulate multiple onion services, multiple service providers, and multiple clients by allocating servers in multiple places around the world. And then we're basically trying to emulate traffic, which mimics real users and real workloads from the server side. And so this is ongoing progress. And let's see then what the reviewers will say.
A final question. So maybe a final question before we go for lunch.
Yes.
So thank you. Very interesting presentation. I actually have a reasonably technical questions. It's probably easy to answer quickly. You mentioned that certain websites on the dark web were only accessible through Tor. And I think I understand how Tor works. How do dark websites link themselves to Tor so they're only accessible through that?
Yes, so I didn't go into a lot of details, but Tor has one basic infrastructure that provides sender anonymity. So the clients, they connect using the Tor browser, and it provides you sender anonymity. The receiver doesn't see your IP address. But then Tor provides an additional infrastructure on top of this, which is named Tor Onion Services, which essentially allows a website provider just to link the service to the Tor network, and it will provide it will hide the IP address of the server itself. You see, so it's a complementary infrastructure to the basic Tor network. You see, and so all of these examples are basically Tor Onion services that are running on the internet.
Thank you.
Okay, so let's thank the speakers once again.
Okay.
And we go for lunch now.
Yes.
Okay, enjoy your lunch.
We will now break for lunch in the CMU Portugal student poster session on the 3rd floor. We will resume at 1 p.m. for the panel Adaptive, Automated, and Autonomic Computing. To start the afternoon, we will begin the panel discussion, Adaptive, Automated, and Autonomic Computing with Isabel Trancoso, Professor at Técnico, and Joel Barros, Chief Platform Officer at Nexar.
Hello, good afternoon, everyone. It's my great pleasure to, together with Joel, to introduce the speakers in this panel session. So we'll start with the representative of the Camelot project, who is Pedro Pizarro. He's co-founder and chief science officer at FIDSAI, the company that promotes this consortium. So the floor is yours.
All right. Posso por aqui?
Qual é?
Sou eu que controlo ou são vocês? Posso ser? Ok. Ready to go? All right. Thank you so much. Thanks for having me. Thanks for the invitation and, of course, the sponsoring of the project. So this is what we are going to cover today. We are at month 28 of a 30-month project, so we are close to the end. We have lots of things to present. I'm going to just recap the project initially to describe the goals and the consortium, the scientific overview of the problems, and then I will go into the results in terms of papers, theses, so on. I will get into just a small peek into a couple of scientific contributions, and then I'll open up for questions. So let's start with the project overview. So FIDSAI, our company, works in fraud detection and anti-money laundering and all sorts of financial crime related with the issuing banks, merchants, acquirers, and so on. We have lots of demanding clients because they are like top banks worldwide. Many of the names we cannot mention because they want to have their privacy. They don't want their names to be associated with fraud detection or money laundering. But we work basically in all continents 24/7 in these very demanding setups where our system must work 24/7, always available, with very high demands in terms of low latency, high throughput, fault tolerant, private. And this is the system setup. But in terms of machine learning setup is also very challenging because it's against smart adversaries, the fraudsters, and we are dealing with incomplete data, delayed labels, so all sorts of messiness of the real world. And we are also a company that is distributed with offices everywhere and working in the cloud in these environments. So we also need to have solution that works at this very large scale. Our secret sauce, which is really not so secret, is innovation and quality of execution. That's why we have been investing in research for more than 10 years now. And that's why also projects like Camelot are important for us. We invest a lot in research, and it's an opportunity to work with the academic partners to collaborate as well. The partners of the project are Universidade de Coimbra, Técnico, School, CMU, of course, and us. And the goal of the project is to reduce operational costs by optimizing the costs in the cloud. So for you to have an idea, when we started the project a couple of years ago, our monthly cloud costs were about $500,000 per month, and now they are already more than 1 million. So in terms of, just for you to have an idea of the growth and the scale, and this is just the cloud that we pay. Our customers, sometimes they have their own cloud that they pay. So of course, even if you save like 10% or something like that, it's a huge amount of money. We also want to be able to share data across clients. So if you see some sort of fraud going in one bank, we would like to share it with another bank to stop fraud somewhere else. But of course, in a private and anonymized way. We also want to automate the data processing across the pipeline because we have many different processing tasks. what we call our case manager, our exploration engine, the machine learning part, the model serving. So there's lots and lots of pieces, lots and lots of data, lots and lots of storage, and we want to optimize that storage and that processing. And because this is dealing with real-world consequences, we also want to develop machine learning models that are what is now being called responsible AI. So explainable models, fair models, and biased models. Sometimes these models are good in terms of quality of execution or accuracy, performance, but they are not so good in terms of bias. In terms of the allocation or specialization of the partners to the consortium, this is more or less the distribution of work, although sometimes we collaborated across tasks. So Technicu and CMU were working more on the cloud resource optimization, Richard Coimbra more on the anonymization of data and reuse of that data, Cool on the data transformation and synchronization in the entire pipeline, and FITZAI, of course, providing requirements, specification, data sources, and also us working on the responsible AI piece. So now let's jump to the results. As I said, we are on month 28 of 30 months. And by the way, initially the project was 24 months. We got a little bit of an extension because of COVID. So far, I think we have been extremely happy with the results. Lots of publications. So far, 35 publications accepted, several still pending. So we hope that this number still is going to increase. 5 tutorial or keynote presentations at conferences, 1 book chapter, 4 patent applications submitted, 1 of which already granted in these 2 years. In terms of students, we have had 13 master students, of which those 13, 9 already finished their masters, and we have also 5 ongoing PhD students. You also have pretty good recognition in terms of awards. So we have 4 awards so far. One of them by André Cruz, a master student that was working at FITZAI and also University of Porto for his thesis, that he got actually 2 awards for that thesis, one of which from the IEEE Portugal. Also got a Best Paper Award from Catarina Gamboa, and a 3rd place in the real-world benchmark on Gecko by the Alcide Fonseca group with a genetic engine. The project also allowed mobility for a number of people that were able to go to David Garland's group at CMU in Pittsburgh. And we are also able to hire, with funding from the consortium, a number of really specialist people working in these areas. So that was one of the goals of the consortium, was also to retain talent and attract talent to Portugal. And now I'd like to take a small peek into 2 scientific contributions of the project, one of which is Fairband. Fairband is a technique that uses an algorithm called hyperband to find better machine learning models that, instead of optimizing just for the accuracy of the model, are optimizing also for the fairness of the model. And I would like to explain that with that graph over there. So the x-axis that you see, predictive accuracy there, is showing the quality of models in terms of whatever metric you want, in this case, accuracy of the model. And each one of those little dots over there is a different machine learning model. So normally, if you are optimizing for accuracy, you're going to choose, according to that metric, the rightmost model, okay? Because you're only looking to accuracy. So in that scenario, you would choose model A. So this is the one that is most to the right, so the better accuracy. This is basically the state of the art today. But that means that you are normally blind to fairness, and fairness is the other axis. But that is normally ignored completely today. What we did with Fairband was to reveal that other dimension and discover that there is a very interesting Pareto frontier there that we can explore. And if you look up that model B, the point over there, is almost as good as model A in terms of the accuracy, right? Very close to the right as well, but much, much better in terms of fairness, okay? So this is what Fairband allows to discover this hidden dimension, the fairness, and to find models over there at a very small trade-off cost. It is true, model B is slightly worse than model A in terms of accuracy, so there's a tiny, tiny trade-off, but the benefit in terms of fairness is very high. The other project that I also want to describe is what we are calling COST. COST is one of those projects where we are trying to optimize the cloud usage. And this, by the way, this is involving FIDSAI, Technico, and Fukul in this challenge. What are we trying to do? So many times when machine learning models need to run, we need to calculate instances, and those instances have hundreds of features. And many times those features, some of them can be very simple. For example, calculating an aggregation like average is simple, but some aggregations are much more expensive. For example, a count distinct, because you need to keep more state. So depending on the state that you need to keep, and depending on the distributions of data that you have in your underlying data sets, having more or less aggregations or having more complex or less complex aggregations can represent a very different cost in terms of computation, storage, runtime, and so on. And also in our case, we know that the single most expensive thing that our data scientists do in production is to debug machine learning model jobs that crash. The data set for some reason was too high for a single node, consuming too much memory or consuming too much time, and they are either hanging or crashing, and someone needs to go there, kill the job, restart the job with a different set of parameters, and do it again. With cost, what we are trying to do is to look at the distributions and forecast that memory cost, storage cost, and latency, and avoid running some of those features even from the beginning, because we know that this is going to overshoot memory, for example. So we don't need to do that. And instead, we can run maybe a similar model. For example, instead of calculating an aggregation with a history of, say, 2 months, maybe you can calculate an aggregation with a history of, say, 2 weeks. And maybe in terms of quality of the model, it doesn't change a lot, but in terms of storage would be like 4 times less. So far, what we are able to do is to save about 5 to 10% of storage costs, and we estimating saving more than 10,000 hours of our people working in this sort of problem. So it's a huge cost. If you know that our average time, a person time of 1 hour is about $75. So if you multiply 10,000 hours by 75, you can see that this is adding up to reasonable amounts of money. So this is one super important contribution of Project Camelot. Yeah, thank you. This is actually the last one. And to summarize some of the impacted FIDSAI, which I think is important to mention here. So multiple responsible AI innovations were brought into the product, like Fairband that I explained, and TimeShap. Some of these innovations, like Fairband, are already being used in clients, leading to tens of millions of dollars saved in fraud. In this area, FIDSAI was classified as the worldwide leader in responsible AI by IDC, an analyst, a market analyst. And we have had from the consortium 2 internships of students from the universities at FIDSAI collaborating. So we even invested more in the partnership. And I think throughout the project, I've been feeling that we got to know each other much better. FIDSAI and the universities are able to share data sets, to inspire each other, and to help discover new research. And that's it.
Thank you. Pedro, I've got some questions that I would like to ask all the people here, so I'll start with you. It strikes me that we have a panel of all males, and actually, in this project, it's the smallest percentage of females in the team. Yeah.
This project?
Yeah. Do you think that it's just that women, girls don't like fraud detection?
Well, I don't know if you notice, but actually FIDSI worked with Technico to sponsor the FIDSI Women in Science scholarships, and we do believe that there's an issue with lack of female talent in the industry, and what we are trying to do is to help universities and work further down the pipeline, right? Trying to really promote women in science and giving them. So we just awarded, I think those were the first in Portugal scholarships designed for women. I think 3 master students and 1 PhD student.
That's good. And what about data sharing with universities?
That's a good question. So part of the goal of Camelot was to also produce data sets to share. And actually this very week, we are outputting 6 data sets of about 1 million records. They are, of course, anonymized. So that not only the Camelot partners, but everyone, they are going to be in open source that everyone can use.
Yeah, thank you so much for the presentation. Since we are in the CMU Portugal program, can you point at outcomes that would not have been possible without the collaboration with your colleagues at Carnegie Mellon?
Yes. So as I showed in the last slide, so for example, this project cost that we are working on now, this has been done with a collaboration of the CMU Portugal team, including students doing internships during Camelot at FIDSI. So there's actually one student right now, Guilherme Espada, at FIDSI, working on that. I would never discover, I think, without Camelot, that we had the Portuguese talent, Paolo, Alcide, and Bruno, all of their teams working on these things. Honestly, I thought that they were not working on this. I didn't even realize. Not only they are working on that, they are like right next door, and it's been amazing to be able to see their solutions, to be inspired by their work, and to share students and to work together.
And in terms of knowledge and outcomes, are there specific expertise that you're trying to build here in Portugal that you are gaining from the collaboration with Carnegie Mellon?
Yes. So, for example, Professor Paolo was working also in similar things with hyperband and other machine learning model optimizations, doing things that we were not even doing ourselves, and we thought that we were like the most advanced group in that area doing that work in Portugal, just because we didn't know. And I think we have the opportunity here to build something that has true scientific impact and industry impact. So you know my background, I came from academia. I'm a true believer in scientific investment. And I think that's the way to go forward, to build a stronger ecosystem of science in basically all the areas, not just fraud detection, but any area, computer science. And this has been also an opportunity for us to discover the talent, to invest in talent, to promote the scholarships, to discover these very talented young professionals that are doing internships at FIDSI, and some of them are joining FIDSI as their first job. So clearly, some of these people would be leaving Portugal because many of them have offers internationally. So this, I think, is also a good way to stop brain drain projects like Camelot, because people see that there's an opportunity to do state-of-the-art work in Portugal, in their country.
Well, thank you very much, Pedro.
Congrats to the whole team.
And
yeah.
Thank you.
Congratulations. All right, and next up is Golem, automated programming to revolutionize app development, automate programming, app development, with Rui Abril de Breu, João Costa Seco, and Ruben Martins. And João Costa Seco is giving the presentation?
No, João Abreu is starting.
Yeah, so go for it.
Go.
So, hi everyone. So this is a partnership between OutSystems, Carnegie Mellon, Nova Links, and INESCD. My name is João Abril de Abreu. I work at OutSystems. João works at Nova Links, and Ruben works at Carnegie Mellon. So we're going to give you an overview of why we're doing the project from the point of view specifically of OutSystems, and then João and Ruben are going to show you some of the results of the project. So nowadays, every business needs to become digital. It doesn't matter if you're a supermarket chain, if you're an insurance company, you need to create software to interact with your customers. You need to create software to optimize your internal processes. The problem is business digitalization is actually quite hard. And there are three main reasons for this. One is that the amount of stuff that's being requested from IT departments in companies keeps increasing every year. The other one is that the technologies that are needed to implement software are becoming more complex and more diverse. So for example, business applications 15 years ago were essentially web applications running on a browser. Currently, we need to build all kinds of mobile applications with artificial intelligence, IoT, and so on. And to make things even more complicated, there just isn't enough people in the world that can master these technologies. And so OutSystems has actually been trying to solve this problem for almost 20 years now, actually more than 20 years now. And the way we do it is we provide our customers with a development platform that allows them to develop applications using a very simple visual programming language that allows them to create the business logic of the application, the data layer, and also the UI. And this approach has been quite successful. There's a prediction that by 2025, about 70% of all business applications will be built using some kind of low-code or no-code technologies. So business is booming for OutSystems. But if we start looking ahead and if we don't get too comfortable, we believe that we can do better. Actually, we believe that we have to do better. And in particular, if we think about the talent problem, we don't think training will be the problem. We will not be able to train enough people. What we need to do is we need to give them tools that do not require training. And in particular, our vision, OutSystems' vision, is that people in businesses, people who don't know about IT, should be able to create their own applications or at least evolve the systems that they need, because these are the people who actually understand their business needs. And so to do that, we need to go towards a development mode in which you can specify or define the observable behavior of your applications and not how that behavior is implemented. So for example, if you want to list a list of customers to show on your applications, you should somehow be able to declare that you want to see a list of customers. Okay, and if you're not really able to specify the full behavior, you should be able to give examples. So for example, if you want to define a validation rule for user input, you should be able to give a bunch of examples of positive valid inputs and examples of negative inputs. And so the challenge in Golem is to define this more abstract layer and then find a way to map this new layer into the current OutSystems language. Because in the end, we do want to end up with OutSystems applications using the current language. So João and Ruben are going to show you how we are doing each of those two things.
Okay. So thank you, João. So let me tell you about what we mean by declare what you want. So what we did was to use abstraction to add a new part to the OutSystems language. So we started with user intents that can be natural language, can be just simple gestures in a UI, a powerful UI, or some power operations for experienced developers. So not only non-experienced developers should be helped by this greater abstraction. So we then started pushing down on this abstraction, starting with user intent. So we expressed those programming concepts in user intents using an ontology. So we develop an ontology that can express programming concepts. And those programming concepts are the input for a synthesis process that builds components composition. So we build large compositions of fragments of applications that exist in a library of components that can be curated or mined and curated by OutSystems experts. And of course, that composition language needs to be grounded on a template language. So we also developed the ostrich template language that, of course, is then compiled down safely to OutSystems applications. So the big picture of our meta-programming architecture is this one. So we have the IDE, where we have user interaction, natural language. The user can inspect the application, they can pick components, and then we have the ontology. The ontology represents the programming concepts. Those programming concepts are used by the synthesis engine to produce an executable application model, or if it's not possible to do that, they can generate questions to a suggestion engine. So let's see in more detail what we mean by this. So in the IDE, we could express the user intents just like this. So I want just to show a list of products. And representing that in the ontology can be reduced to some facts here in a logic programming kind of syntax. So some of these elements could come from the application that exists, because usually people don't start from scratch. So there is already something called products, or product as an entity in the database in the application we're using, but clearly the user wants to show something, X, and that X is product. Okay, so what we do is to then use the synthesis engine to produce some outcome, and the outcome is a set of derived elements. And in this case, we need a query, and we need to instantiate some template that will list the results of the query. But there are parts of this program that are not instantiated. For instance, the question mark A over there is the list of products that you want to show, actually. Not just products, but some attributes of the products. And the question mark B is where to place this list. And so those are the elements that are derived as open questions. And these open questions are then treated by a suggestion engine. And there are two possible ways, or actually three possible ways to treat questions. They can have a default answer by built-in rules that are just simply programmed by OutSystems experts, or we can use AI methods like machine learning or synthesis by examples to find the answer for those questions, or if it's not possible, just ask the user. And better than just telling you more, let me show you how this works.
This is the starting point of the application. So we have an already existing page called homepage, still empty, and we have a database table called product with attributes name, price, and stock. So we can start writing our first instruction here. Let's say I want the page to create products. And this sentence is represented by the following ontology facts. So in this case, we are missing a detail saying which is the page on which we want to create the products. So the first question our tool proposes is using the already existing page called homepage. And in this case, we'll answer no. And since we have no other existing pages in our application, then the tool asks us to provide a name for the new page that will be created. So we can call it add a new product. Now that it's finished, we can see the result by opening the resulting file here. And so we have the existing home page and we have our new page with the form to create product. Now the second sentence is we say, I want to see a list of products. And again, in this sentence, we are also missing the location in which we want to place a list. The same as happened before, our tool suggests already existing pages. So now we get the suggestion for the page we created before called add a new product, which will say no. And then we're asked if we want to place the list in the homepage. So let's say yes. And in this sentence, we are also missing the details stating which attributes of products we want to see. And so our tool asks for that. It starts by asking how many attributes we want to list. So we'll say 2. And then it asks us to provide the names of the attributes. So we'll say price, name, and price. And now that it's finished, again, we can open the resulting file. And now the home page has a list with the name and the price of all the products we have in the database. Finally, the last sentence is, well, we have this list here, and we want to have a search box to filter the products by name. So we just write that. I want to filter products by name. And in this case, there is no questions that the system needs to ask us. And so now that it's finished, we can reload the application, and we see that the homepage now includes the search box for us to filter the products. So let's take a look at the final result. We'll publish it. So we have here the list of products in the homepage, and we have our page to add a new product. So let's say we want to add neckband. Now we can search this list here and see the product that we added.
Okay, so that's a short view of how it works. So, Ruben.
Yeah, thank you, João. So next, I'll talk about how you can actually give examples to solve problems automatically using synthesis by examples. Imagine you have a user that has a wedding and is planning their wedding, and he's building an app where you need to collect information about your guests, right? So you can do this at OutSystems, and you may have a form like this where you have an email form. So often this is like a free text form, and there may be no validation. So maybe the user introduced incorrect email, and that can be inconvenient because you want to contact them afterwards, right? So how can we solve this? Well, if you're a programmer, you can think, oh, I'm just going to create a regular expression and define what is a good and bad email. But users don't know how to do that, right? So what we do is that we ask users to give examples. And we ask them to give positive and negative examples. So in this case, let's say a user gives those positive examples and some negative examples. And this is thrown to our magic box, our synthesizer, that we develop in coordination with CMU, Nova, and OutSystems. And then this magic box that uses AI techniques will output you the result, in this case, a regular expression that satisfies your positive examples while excluding your negative examples. So this is a very simple example, but we can actually synthesize very complex regular expressions. So other applications could be, well, now I have all my guests in a database. Now I want to ask some questions, right? But I know nothing about databases or SQL. So how can I do that? Well, again, you can give examples. So maybe you don't know anything about SQL, but you know about tables. I can say, well, I know if I have this table here where I have John, Sophie, and Chris, and I have 2 adults and 1 child, then the output will be 1, right? And your magic box, the synthesizer, will actually be able to synthesize this for you. And I guess we're running out of time, but so I'm going to show like a demo again, how you can actually do this at OutSystems. And this will take 2 minutes instead of 1, but hopefully it'll be okay. Again, by giving examples. I think this is really cool because this is actually using the OutSystems.
Luckily, in our latest update, we introduced a new experience where you can just right-click on the name of the flow, and you can create an action flow from examples. And here you can give your test cases for the functionality that you want, and the flow will be generated for you.
Okay, so do I have to fill them all?
You can just fill one. So my recommendation is that you first fill one and see if you get what you expected.
Okay. So let me just try this one. So I wanted to give me all of the I wanted to give me the minimum between like 2 values. So if I give him 0 and 2, I want me to give 0.
Okay, there you go.
Oh.
Is this what you wanted?
It is. It's actually right. I also wanted to filter lists. So let's say I have a list with a bunch of integers. And I only want the list with integers that are higher than a given number. So let's say I give you a list and an integer, and I wanted to return a list with the filtered integers by that number. let's try. Yeah. Okay, so I want all the numbers in the list that are bigger than 0 in this case. So it doesn't seem quite what I want. So,
Okay, so
do you think adding
in
more
the-
examples works?
Yes, in this case, my recommendation is that you give a second example.
It's almost over.
I'll give a bigger one to see how it behaves. 5, 10, for example, and I want all the ones that are bigger than 3. Yeah, so it should return 5 and 10.
You can pass it.
So what about now?
Yeah, besides some warnings, it seems correct.
All right, so quick question. Pedro was actually very clear about the business case for the project and the value, economic value for Feedzai. From OutSystems' perspective, what is the economic value of the outcomes of the project?
Of Golem.
Mm-hmm.
Well, so we still think that software development has to evolve. Okay.
Mm-hmm.
The company that manages to do that will have a lot of business value. Okay. OutSystems, we believe, is in the right place to do that, but it's definitely not an easy task. What we're doing in Golem is we're looking at a set of technologies that we already knew existed, but have to be applied somehow in an efficient way to the OutSystems environment. So what we're doing is, and this was the last slide, we're already defining a new product, and we're already using some of the technology that's being used, that's being created by Nova and by NSPD and by Carnegie Mellon to enable, to make sure that the product is feasible. So, I mean, this is still confidential. I think that in the next few years, probably we'll put something out there, and if it works, I mean, the business value will be enormous, and we couldn't have done it if we hadn't learned how to do it.
In terms of increasing your revenues and your market share because you have this type of features.
Absolutely, yeah.
And out of all the things that you're trying out in the project, how many of those do you believe are going to end in production from your intuition?
It's hard to tell. I would say from the technology, 40%, which would be a great result. So the 40% of the kinds of technologies that we are learning and using and applying to systems will most likely be used to create a new product. Yeah.
Understood.
I'd have to repeat my question to Pedro. What about data sharing with universities?
Data sharing?
Yeah.
Well, first of all, we've never been asked for data, so the question never arrived. It might happen. Our problem is not so much sharing our data, it's sharing our customers' data.
Yes.
We cannot share customers'
what
data.
I had in mind,
right?
yeah.
So the way we actually work with data is by anonymizing data and making sure it's compliant with all the legislation and so on. Sharing with other people, it will depend on.
Shame on that.
Mm-hmm.
Okay, thank you. Thank you for
All right, so we're
fantastic results.
Thank you very much. Nós só temos 5 minutos, por isso nós temos.
And the last presentation today will be from Project AIDA, Adaptive, Intelligent, and Distributed Assurance Platform. And the PI will be Pedro Fidalgo presenting, who is Director and of Risk Management at Mobileum, which is the promoting company of this project.
Thank you. So let me first introduce what is AIDA. AIDA is an acronym from Adaptive, Intelligent, and Distributed Assurance Platform. This is a presentation that we try to split in 2 different areas. The first one giving a status of where we are in terms of the AIDA. The second one in terms of research. So this is the consortium. It's built of us, Mobileum, Inesctec, University of Coimbra, and Carnegie Mellon University. And before introducing our goals and benefits, let me tell that Mobilium is a company that works in telecom risk. And risk has three different areas: security, fraud, and revenue assurance. And we are working specifically in fraud and revenue assurance. Our main goal is, with the new protocol of 5G, is actually to find fraud in a total different environment. We're going to have different scenarios, so it's no longer the normal 4G or other networks that we had before. 5G introduces business cases, use cases, and specifically particularities that are for the first time in the market. And we try to find a normal behavior, both in terms of fraud and revenue assurance, under a 5G context. To give you like a small example, I can tell you right now we have customers with 100 millions of subscribers. If you go to Indonesia, it's quite easy for you to have 200 million, 300 million subscribers in an operator, which makes you have billions of events per day. In 5G, we expect to have 25 times more the data that we are processing today. So this leads to our first point in here, which is we no longer can have a central part in our network, a central server that collects all the events. We need to have these edge computing capabilities where we process the events locally, and then we have what is the second point that we have there, our machine learning algorithms that first run on the edge computers. They would have to pass all the learning process to the cloud, to the central server, and from that point on, we will build one model that is common and can be propagated to all the edges. Then obviously when you are dealing with customer data, and this data is the kind of data that you have locations, you have addresses, you have who called who, so there is a lot of secrecy in this information that can only be disclosed under some court laws. We need to make sure that there is no intrusion in this data, and we are compliant with all the confidentiality that are associated with this data. At the same time, and this is not the first time we experience this, it's quite easy for fraudsters in some cases to access the network, and if they're able to control all the mechanisms and the servers that are producing fraud, it's easy for them either to cut the information that goes to the system, change that information, or make sure that the system does not alarm. So we also need to work in the parts of security. This is the project status. I'll have a better slide resuming this, but we asked for an extension. The main reason for us to ask for an extension was obviously COVID, but then the other part that it was really hard for us, it was to hire people to work in the AIDA project. So this is the main thing that caused us some delays, and in some cases it was postponed to June 2023. By different areas, we have accomplished already the first one, which is 100%. All the other ones are a little bit more than 80 and 70%. We expect to conclude on time. This is the main catch up from this slide. The only thing that is coming to us as a risk is at the end, we need to put all these different pieces together, and putting this together, it means a 5G lab with all the telecommunications inherent to the 5G lab, with all the different models that we built running in one environment. So this is just a selection of the papers that we submitted, multiple different papers to conferences. A little bit of the architecture that we have, different areas, distributed and orchestration mostly within ESCTech, intrusion and detection and tolerance with the Carnegie Mellon, monitoring and adaptation also with the Carnegie Mellon and University of Coimbra, security and privacy aware data store, also security and also Carnegie Mellon, and security communication, University of Coimbra and Carnegie Mellon. First paper, we had to test that the algorithms we're developing were able to work in a federated environment. We are able to have good results, not only running for the first time, the baseline was better, running at the cloud, but also when we run at the edge, and the model that was produced in the cloud, it had only 1% deviation from the main one. The other paper that we produced in here is fraudsters, they work in networks, and once you find one of the people belonging to that network, it's quite easy for us to disclose the rest of the network. But one interesting thing is we realized that they have nodes in the network. They have roles, so you cannot access a fraud ring or a fraud network just by going to any node. You have to go through specific nodes. In this case, we call it bridge nodes, and then there are some control nodes inside those rings that are able to disseminate information and contact whoever they want inside those rings. One of the things that was one of the metrics we employed in here was influence. We realized that majority of people associated to fraud in these rings, they have a high influence in the network. Another paper, and this is something that concerns us in the 5G context. If you realize here, this is a telephonic denial of service. And the main purpose of the process in here is to forbid you to have access to your communication. So it means if you are a clinic, if you are a hospital, if you are 911 or the emergency number of your country, if I make too many calls to your number and don't allow your number to make calls or receive any calls, you have a service disruption and you cannot use that service at all. They can also do this for toll-free numbers. They can call a lot of your toll-free numbers, which will put your costs at a very high expense. And we realized here that there were many different nodes in the network doing this telephonic denial of service. One of the things this concerns us in the 5G context is, imagine some of the cases you're going to have in 5G, which is autonomous cars, remote medicine. If you realize that they are vulnerable to this kind of denial of services, this is something that really creates a high impact in the network. We were able to not only to identify the same as the operator already had suspicions of, but we confirmed additional nodes that were part of this network. Coal miner, this is something quite important for us because we realized that fraudsters, on the opposite, they also use AI. They're not expecting us, we can use AI. They do not use AI. Yes, they use AI, and we realized that they were having a lot of camouflage. I don't know how this can be propagated to other types of fraud scenarios or different fraud business cases. But in here, it's quite easy for the fraudsters to simulate behavior and hide the bad behavior inside the good behavior. And this is camouflage techniques that we were able to uncover and expose in this paper. Risks, GDPR, some of the things we already talked in here, specifically to data sets. It's not easy for us to expose these data sets to the public without some synthetic work on top of it. And a lot of the information that we use in our algorithms, it depends on the value of the fields that you have there. So it's not the same thing if you call Latvia or if you call Portugal. It's a total different context. And when you try to anonymize data under these important concepts where the value of the information itself needs to be preserved, it's quite easy for us to disseminate the data sets. Also, the 5G lab, it's something that that concerns us, and recruiting, I said already what the problem was, and traveling visas. Most of the students you are working with, they have issues of traveling. So many times they are in university, but they cannot leave the United States. They cannot travel because their visa does not allow them. Recruiting assessment, I'm going to jump this one. Short-term action plan, I'm going to say that the 5G lab, it's our main concern at this point. We need to put all these different pieces working together. This is something that at this point is 20%. This is a concern for us, so we need to really speed up on this process. Financial execution overall, 66%, and that's it. Thank you.
Thank you. Thanks. Fantastic results again. You say that in your report, you specifically say that the recruitment problems were due to lack of the required skills. Does it mean that universities are not teaching what they should?
I would say first that the universe is not really big, so that's the first problem, and then probably there is a lot of competition for those resources. One of the things we realize nowadays, it's quite easy for other companies to come to Portugal. You work remotely, I'll pay you the benefits of some other country all around the world, which is much higher than the one that you have in here, and you just lost that resource. And I believe there was a lot of cases like this one that people that get into this status of a PhD or working in this, they have a lot of people looking at them.
So it's not exactly that we are not teaching what we
No, not at all.
Good.
Well, we do need more, so that's for sure.
Yeah, a lot more.
So can you walk us through the process by which you bring ideas together from the Portuguese universities, from Carnegie Mellon, from the corporate partners, and to come up with this type of technologies?
Okay, so one very interesting thing is some of the people we are working with today from Carnegie Mellon were authors that we were citing already. So this is something that was really cool. All of a sudden, you have these people working with you. So it was quite important for us. So from the moment that you are very familiar with the work of all these authors that are working with us right now, I mean, we are constantly referring. We remember that paper that you did in 2012, or some idea that he was the main author. So it's quite easy to flow in these kind of ideas because we are pretty much on the same page, because a lot of times what we are discussing is based in some papers that the people that wrote them are there. So it's quite good.
And have you found that it was more like Carnegie Mellon teaching, or was it more of a collaboration? What was the dynamic?
Collaboration. It's really a collaboration, because one of the things that becomes notorious when you are working with academia is when you bring the real world problem. Sort of, sometimes you, in the part of the academia, they didn't expect the problem to be that way. Sometimes it's even harder for them to understand the problem. And this is where we come in place and really explain all the different vectors of the problem.
Would any of you here in the panel would like to comment on the fact that there are no journal papers at all in all the 3 reports?
I can comment. I can comment, and I'm going to give you my specific example. It's easier for you to go to a conference because they are very specific on that topic, and on the opposite of a paper. And by looking at some comments from reviewers, many times they don't even understand the problem, or they are seeing the problem in the specific topic of that paper. So if you try to bring a complexity problem, which is the case of fraud, that has many different areas, it can go social area, can be data mining, can be an algorithm, can be many different things. From the point that you have the reviewers from a journal that is very focused on his problem, data mining, and he reads your paper in a data mining perspective, the odds for you to publish in that journal are really low.
Very interesting.
And anyone else wants to comment on that before we go?
Yeah, I find that it is in general easier to publish in conferences than journals. The cycle is much shorter, and sometimes you don't even consider going to journals because it's so slow, right? It's almost like unthinkable to wait 8 months, 10 months for the entire life cycle. Because by the time it gets accepted, it's already legacy, right? And sometimes it gets such a poor review. Some of the worst reviews we get sometimes with submissions is when the reviewers say, I see no value. So they are not complaining about being correct or incorrect. They say that I see no value. And it's like, I'm saving millions.
Yeah.
You are not even in this area. How can you just reject by saying that there's no value? Please just assess this on correctness. Right? And so I feel that sometimes they are a little bit too academic. They know their problem, but they cannot put themselves on the shoes of a company or other researcher that has a different real-world problem.
I can also imagine that from a company perspective, there's more marketing value in a conference than in a journal. Is that a fair statement?
We are not deciding based on that.
Fair enough. We have to go, sir.
Yes.
Gentleman in the back.
Sorry.
Can you hear? That question, Isabel, is a very interesting question for the following reason. And every year in my department, at the senior level, when we kind of look at the progress of faculty, because in my department, there are computer science people and there are electrical engineers, that question always arises. Electrical engineers turn to the computer scientists and say, where are your journal papers?
Yes.
and they say, we don't care, because in our culture, what it matters is the high-ranking computer science conferences. So Isabel, you and I, we share the same. We love the journals.
No, I totally subscribe to what Peter said.
But those computer scientists in the
So
room,
there will be a very interesting fight at the next coffee break,
They
which you
don't
are
care
all
about
invited between CS and the electrical engineers. Well, let's thank the speakers once again, and thank you very much for participating.
Fernando Pereira, CMU Portugal ERC member and VP and Engineering Fellow at Google, will now join our Scientific Director from FIO, Leah Patricio, to moderate the session, Understanding Conversations to Improve Productivity. We welcome the project representatives to take the stage.
Depois apresentar verbal, como queira. Como queira. Acho que nos... Ok.
Red shoes, leather jacket.
Okay. So thank you. We will start now with the two project presentations.
Hey, quiet back there.
So we have here two great projects, and we will start with João Magalhães and iFetch. Thank you for coming, and if you want to present the other team members.
Sure.
Thank you.
Good afternoon, everyone. I'm João Magalhães. I'm from Nova University, and I'm here to present you iFetch, a project that is in collaboration with CMU, more specifically the Language Technology Institute, and here is Alex Rudnicki from LTI, and Farfetch. Pedro Ferreira is also here representing Farfetch. So this is the team that is here. No, well, some of us from the team that is here today. And so if you have any questions, we're happy to answer all the questions you may have here or during the coffee break or even after this session by email. So whatever channel you find more appropriate. So good. So as I said, I'm going to tell you about iFetch. So iFetch is a conversational assistant for online shopping. So the idea is that we can have a conversational assistant that talk to you about the fashion that you like, the products that you want to buy in Farfetch website, and it can guide you through the journey through whatever channel to reach your final end goal, which is to buy some products, some high fashion products in Farfetch website. So this is the vision that we have. And basically we have a Farfetch product catalog, which is very heterogeneous and very rich in the number of features and the number of products that it provides. And the idea is that the conversational assistant will seamlessly walk through the catalog with you hand in hand and tell you what kind of products goes well with which other products, which products are now more fashionable or trendy. So consumers now have other interests, and so like, for example, if some product is ecologically friendly, and so we want to be able to engage in these type of conversations. And so this is a prototype that is working, it's functioning, and if you want, you can try this prototype. This is implementing some baseline functionalities with algorithms that we've been implementing throughout these last 2 years. We also have this on the website, and this is really important for us because we want to test this from the beginning with the user in the loop. So this is really critical so that we deploy the algorithms. The algorithms then can be tested with real-world users. There's a feedback loop, and we can improve algorithms this way by getting knowledge from the fences, if you want to call it that way. And so this is already integrated on the website, on the live website. This is only a prototype, so this is not public. This part is not public. And something that is, allow me the redundancy, more far-fetched, is this 3D environment where you imagine that you're on a tablet and you're browsing the store, and this is a 3D store. And so you want to interact in a more seamless and more natural way. You don't want to type, you want to talk with your voice to the conversational assistant. And so this is the other level that we aim, and we have already this prototype also functioning, and it's available for you to test. We can show you to you if you want. And this already includes some concepts, and this one is not for the medium term. So it's not for the short term or medium term, is more far-fetched, as I was saying. So these prototypes are working, and as I said, we want to engage users very early on in the loop. And so we already conducted some pilots with some far-fetched customers, so real customers, not a lot, because it's a very valuable market. It's a very valuable clientele, and so you don't want to make it too open, and so it's limited in the number of users that we tested the platform, and we tested the number of functionalities to see if we were in the right direction, or which directions we were following they are correctly, and which ones needed to be improved from a deployment of our algorithms in the real world. And so we got some results. So well, me as a scientist, I will look at the bad things, the things that we need to improve. Okay, so we always have this eager, okay, what do I want to improve? And something that we are really keen on improving is the humanness aspect of the bot. So we want to make the bot to feel less robotic and more human. So this is very challenging, and we haven't figured out the right way to do it. And this is obviously the topic of a PhD student, where we need to do more research. And so that's one of the things that we've been working on. So, but basically, I think the big message that comes out of this initial user study is that users are keen on using this technology to access the products, because they can engage in a conversation, so it's more natural. They can quickly ask a question without having to browse point and click paradigm. So it's more fluid for us humans. So there's an opportunity here for Farfetch to use this technology that we are researching. So obviously we have a chicken and egg problem here, because we want to do a conversational bot for a domain for which we don't have conversations yet. We have only a few conversations, but what we've done, we designed a conversational data set, a very heterogeneous data set. So this is a synthetic data set, and it captures a lot of things that we know that will be needed. And this one is not really groundbreaking in the sense that it was obvious even before, like we needed to have so well-defined slots and well-defined intents in the dialogue. So intent is what is it that the user wants to do when he says something, and the slots is when I will say I want a red dress, the slot, the color slot is red. Okay, so this is really straightforward. But then we have other things which we know from interacting with real users that it will happen. Because users are human and users do conversation rumblings. They start talking about whatever they feel like. And what happens is that we don't have all possible intents and all possible shots, all possible slots. And so we have this item here of zero-shot intent detection and slots to avoid catastrophic failures in the conversation and allow us to answer in a meaningful way without completely losing the user throughout the conversation. So this is really important, and it's something we are working on. So, but from where do we really build these conversations? So basically, we built these conversations from search sessions, where users are going through the products on Farfetch website, and with this we built the simulated conversations. And so, although the dialogue is designed by us with some variance, with dot augmentation techniques and so on, the flow throughout the products is real, and the moment where the user actually bought the product is also real, because at the end of the search session, the user bought the product. And so this is the data that we have and that we've been working on. So in terms of research and collaborations, so this is something that is someone is missing here, which is João Paulo Costeira. João Paulo Costeira from ISR, from Técnico, is also in the project. And so the research and the research and innovation collaboration has actually been done through these institutions. So Nova, Técnico, CMU, and Farfetch, the big umbrella and the big drive of this project. So in terms of talent nurturing, so the actual researchers that are doing all this work, besides us, we have this amazing team of PhD students, so dual degree students, affiliated PhD students, MSc students, so several master theses were already done in the context of these projects, some visits and stays. So other thing that we are very proud, but we didn't have time to talk about this, is that we organized 2 international workshops, 2 panels, tutorials. So we were even invited to do a tutorial on the topic of multimodal conversational AI at ACM, ICMI conference. So there's a lot of outcomes out of this project. So now, back to basics. So what is it that we've been doing in terms of research in this project, in IFAIR? So the goal is multimodal conversational AI. And here we have this, I would say, rather simple platform framework where we have the bit that receives what the user said in the conversation, and then it's able to understand what is it that the user said and what is it that the user wants to do in the conversation. And so this is really critical, because if we don't capture this correctly, the conversation will go in a completely wrong way, and it will simply not work, and it will frustrate the user. Once we get the intention and all the slots, we have this dialogue manager, and the dialogue manager has several components, and it's complex in multiple ways, in the sense that we have to capture the context of conversation. And the context of the conversation, it may seem simple, but it's really important to have the same mental state between the user and what the user thinks that the bot is doing. Okay, so both the conversational agent and the user, they need to be on the same page. So this is really critical, not to sidetrack the conversation. And so we have this, so we have the dialogue context and the dialogue state tracking, so that we know where the state of the conversation is, and then the dialogue policy. And this is critical to produce conversations which are more human, which are not too mechanical, that they do not always go into the same flow of conversation, because then it will be completely always a repetition. It sounds mechanical from a flow of the conversation, from a conversation flow point of view. And then we have the natural language generation, which is the generation of the answers of the agent. Okay, and here this is another point where it's really critical to make sure that the answers generated by the agent look more human and not too mechanical. Last but not least, and here we have the knowledge base, which is the product recommendation, which, if you think about it, it's really the end goal of the conversation. Okay, because when you start the conversation, the goal is to get something out of this product catalog and buy this item. So the conversation actually draws on the items that are in this knowledge base. Okay, so this knowledge base is also quite complex, because you have products, you have multiple images of the product. It's not uncommon that the user asks questions about the visual aspects of the products. So basically, the user asks questions about the content of the images of those particular products. So the algorithms that we've been working on for understanding the user. So they are based on the transformer encoder. So it's quite straightforward, this part. So they were trained in the far-fetched synthetic data set, but not just that. So IBM also provided a multimodal conversational data set, but it's targeting the Indian marketplace, India as in India. And so it's different from far-fetched market, segment market. And so the conversations, we have more than 14,000 conversations, which allowed to test this algorithm. And so because of this, we came out with this different architecture where we, instead of using just so this is a transformer, very specific kind of slide, but so instead of trying to get all the intents from one single slot, which will cause a lot of interference between the different possible requests or type of requests that the user does. So the user may ask, I want a product, a similar product. We basically decomposed the intents, and we have different intents to reduce the noise across the products. So the dialogue manager and dialogue policy, we have this line of thinking from the start to the end of buying the products. So we have here some techniques to cope with out of scope. Out of scope is really dangerous in a conversation, and this happens very often. So users ask many things out of scope which were not predicted, predicted when we designed the conversation. And so basically this was evolved into something more complex like this. I'm not expecting you to read all this, but I'm just showing you a little bit of the almost a little bit more of the complexity that we are dealing with. And the product catalog, we wanted to support visual queries. Like I want to address like this. And the challenge here is that some products are very, very similar. And when we organize the products in this embedding space, we want similar products to be close to similar products, but based on the taxonomy. Because the taxonomy is not only the product, but also the characteristics of the products. And so within one product of dresses, we want to reorganize this in a meaningful way. And so the idea is that we can then answer questions like, I'm looking for a red formal dress, okay. Can you show me dresses like this? And then, more challenging, I'm looking for a red dress that looks like this, okay? And in this way, we are combining the two modalities to find dresses which are similar to this one, but with different characteristics. And okay, I need to rush. So we have this idea of generating polite answers. So instead of simply answering the question, can you tell me what is the material of the second product? The answer could be, the answer is made of silk, which is a very dry answer. And the more polite answer would be, certainly, the dress is made of a wonderful soft skill, like just any seller would do in a real brick and mortar shop. And so this is work that was published, but we are improving on that. These are some of the publications that we have. So I'm sure I didn't touch all these publications that we have here. So we are very excited about the project. So we really think that the best is yet to come. So we have targets to do dialogue engagement and negotiation, hyperbolic embedding spaces, interactive product search, knowledge-aware visual question answering. So all these things are in the Forge and will be out next year for the next review. So the outcomes, so I've went through the outcomes in terms of pilots, prototypes, so the data, collaborations, research, and now in terms of business innovation, and I don't think I would, or we would be able to express the excitement that Farfetch is having with this project. And this is the view from the product brand, the brand of Farfetch and how the department sees the project. So this is a video that I'm now going to play for you to see, and this is how Farfetch sees the project.
All right.
And
Thank
this is the
you.
team.
So I'll start with the question because I have to ask this question. But I really like the synthetic data used for dialogues. It's really clever, very well thought out. But in my experience, synthetic data has some challenges. In fact, there are two that came to mind as I watched the presentation. One is the interaction through clicking on various menus and so on is attentionally very different from talking. And maybe actually those sequences are very different from what from the sequences that have if you could interact by voice or even by text. So the second one is, for instance, you gave this example at the end with negation.
On?
Negation.
Negation.
And not read. Like this, but not read. I'm sure you don't have that kind of interaction in your current system because you cannot say negation with a menu, with a GUI easily. Comments?
So the first question, the answer is very simple. We haven't tackled negation yet. So negation is something that has not been a priority yet. And this also is linked to the first question because we're doing a step-by-step. So we gain experience by interacting with multiple users in a different domain. We know now better how they talk in a conversation in a fully automated, so there's no human in the loop here, okay? There's zero human. Fully automated end-to-end. And we know what can go wrong. And so we've designed conversations that way. So we try to have a lot of variety in the synthetic data set. So Diogo Silva built a lot of different answers with different tones, also questions with something completely different. So people can ask, I want the dress similar to the one that Beyonce used, and completely crashes if we're not expecting that. So this kind of questions is more common with real world users, and we're doing a step-by-step approach. And so the data set has, I don't know how many revisions. So we've been doing the data set iteratively.
Thank you. Questions? There's one. There's several, right? One, at least one.
Thank you for the presentation. I would like to ask which parts are open source and could be exported to other domains other than the fashion industry. So I know that there are some similar solutions, for example, in Chinese Alibaba or AliExpress marketplaces. which contributions does this work provide for this area in general, and which ones are open source and could be used by other people potentially? Thank you.
Yeah, yeah. So the open source, well, we are happy to make everything open source, but Farfetch has priority, and so it's something that I cannot answer right now. For us, we do everything open source, but it needs to go through Farfetch. In terms of competitors, so there is some peculiarities in the fashion domain, which makes it unique. So the interests, and in particular this marketplace. So the market segment is very unique. The conversations that you engage with, you don't always necessarily engage with the end user, and so there's someone in between. And so the language is very unique, and well, yeah, the market as a whole is quite unique.
Okay, maybe I would like to ask also a question. So one of the challenges that you identified from the user feedback is that the system seems too robotic and less human. And I was wondering, coming also from service research and on the importance of service employees and their personality and the way they interact,
yes.
to what extent the next step could be to somehow understand different personality of service employees and try to have a more nuanced interaction, because maybe I don't want to interact with someone or something that mimics what but offers me something different. And I may, according to my day, want to interact with someone different or something.
So you're touching a very interesting point, which is the so-called uncanny valley. So you don't want the system to be too human, because then you will not say things that you would say to a machine, because you know that the machine is not a human, and so you're not ashamed. So we've not reached this point yet in terms of scale of users to know what is the best personality that we need to encode in the agent. In other domains where we have 15,000 conversations with real users, and real users range from well-behaved users to trolls, okay? We know the type of personality that we need to encode in that particular domain. And the type of personality is very domain-specific, because when you enter, if you think about it, right, it's obvious. When you enter a high-fashion shop in a shopping mall, you don't expect to be treated like, I don't know, like McDonald's, or not that McDonald's is not good, it's amazing, but it's a different type of, and there's definitely personality traits that need to be encoded in the answers, and that not just the written answers, but the interaction of the answers. So that's something that has been tackled by some of our research students.
I'd love to continue this conversation, but we can't. Thank you very much.
Thank you.
Excellent. So, and now for something somewhat different. Still conversations.
Yeah, I think this is a great panel, because I'm also going to talk about sentiment analysis and empathy and how important that is. Okay, so let's start. First, let me introduce the leads for each institution. So I'm leading the Maya project at Babel. Graham here is leading at CMU. Elena over there is leading at INESPD. And Andre over there is leading at IT, or IT, as you prefer. And our amazing and brilliant project management team is over there, Maria and Nuno, and maybe some students are around. Okay, so let's start with the problem. What are we trying to solve with Maya? Okay, so two things. So the first is the satisfaction of international customers. Okay, many companies in the world, many of them, Unbabel, customers, want to address international customers and satisfy them. But that's a hard challenge. And the second is about the time that each customer service agent spends on a conversation. So, for example, BPOs want to optimize this very much because this is what gives them efficiency and then profitability. So these are the two main issues we are looking into on Maya. But also, in the background, we have this context, is that machine translation has been evolving in terms of quality over time. So we have now new players like DeepL, for example, that are already delivering very high quality machine translation. And so Unbabel can't differentiate only using machine translation, okay? And so, and of course, Google, that is very much advanced, on this area in terms of generic translation. And so we have to have a competitive advantage, and that's through the products, through product differentiation. So when Maya brings that to us. And so the concept here is that we are like augmenting these agents on the left with AI superpowers, multilingual superpowers. And who are these agents that we are really augmenting with AI? So could be an agent that speaks English natively, but now with Unbabel, he can start to speak French. Or he could be an agent that speaks English and then he speaks French, he speaks Japanese, he speaks Portuguese, and so on. And so we have agents that speak, imagine, 30 languages with native quality. We call them the super polyglot agents, something really amazing. And and so these are concrete customers that we have. So for example, the last one is a customer that has 355 agents using Unbabel. And so these are the agents that we are augmenting with these superpowers, the multilingual superpowers. And that's how Maya came up. So Maya, multilingual AI augmented agents, that's Maya. We have a bee as our mascot that inspires us. For older people like me, you remember the bee Maya, many years ago. And and so in terms of the project, so we organized the project in these activities from A1 to A7. So the first activity is about project management. I'm not going to talk about that. So I'll jump immediately into the first activity. But one thing important on this diagram is that we have kind of these three research activities that are contributing to the product. Okay, that's the essential parts of the project, is to really converge into the product and really create business value. But the first one is the one related with data. And we all know that data is absolutely crucial. I remember being on a call with Isabel, and she was so kind of insisting so much, the data. And it really took us a lot of time to get to the data. And now we have a data set based on real customer interactions that we are using. We use this data set on a shared task. So we use this data set in terms of annotating this data set with sentiment analysis that is now leading to empathy. And so this is a real competitive advantage, is working with real customer data. So it's really, really important for us. But we went through a long process to get to this data set. It was a lot of time. I must admit that we underestimated the effort to get to this point. First, we had to change contracts with customers so that they would allow us to use this data for this purpose. We had to go, through privacy, processes to preserve the privacy of people involved. We have, for example, data from travelers that, have their names there. There is sometimes their credit card numbers. So yeah, there was a lot of steps to get to this data set. But we are very happy, to announce that we have the Maya version 1 data set that is available publicly. And so this is a great starting point for all the rest of the project. And so, what are the next activities now that we have the data, back 2 years ago? So the first activity is an activity where we are focused on the latent models for language generation. And here we came up with major achievements that are going to have a big impact on our product. And I'm going to give you a demo about that. So I'm really excited then share the, the latest results on this. But we also achieved, these results on latent structure variable models for explainability. Andrea can talk more deeply about that. And very important, we had as output, many papers. We participated in few conferences. We interacted a lot with CMU on this context, and we won, best paper award on 2 conferences. So really excited about that. And yeah, and I'm going to tell you a little bit more on the product context about this. So the fourth activity is about the context-aware translation activity. And so this activity is something that is very specific to this use case, that is about conversations. And what is that? So it's the context of the conversation. So let me show you this slide just to to give you some context to understand about what are the big challenges on this area. Is that when you are having like a chat conversation, you may, for example, refer in a certain message to my boss, and that person is a female boss, okay? And sometime later, I'm referring to the boss, and I need to translate this. And when I translate it back, I need to know if it's a female boss or a male boss, because if not, the translation is going to be very, very strange. Okay, so suddenly the female boss becomes a male boss, and that we don't want that. And so we have to keep this context along the translation, and this is really, really hard. Okay, for machine translation. So Graham is leading this initiative, and yeah, and it's really, really hard. And so, but still, we made very important advances in this domain. We, for example, combined quality estimation with empty via re-ranking, and so this allowed us to start making progress in this domain and really gain a competitive advantage, because in the end, what we want is to differentiate from a kind of generic machine translation engine that doesn't take into account the things that are specific about the product, okay? And yeah, and so other achievements are described here. Still, it's something that is still very hard to solve, and so we are continuing to research on this area, and yeah, and Graham can tell us a little more about that if you want in the Q&A. So we published 6 papers on leading conferences, and we organized a shared task on WMT, that is one of the most important events on machine translation. So let me move to the next activity. So the virtual agent assistant. So this was the activity led by Inês, and yeah, as major goals, we had initially to address conversational quality estimation, that is to address the quality of conversations, not just single messages, that's what Unbabel does, but to assess the quality of the whole conversation. Second, answer generation. This will address one of the challenges, that is the average handling time of the agent, so to make the agent faster to reply to the customer. And third, the part that is really, really important, that is the empathy of the conversation that we were talking on the previous, previous talk. And so we made major achievements on this activity. So first, we now have an open domain model for answer generation that is now powering our new feature that is about auto-completion. I'm going to show you a quick video about that. We have new models for sentiment analysis now, and so we can detect the sentiment of conversations. And I'm going to tell you a little about how important this is for the product based on the customer discovery program we did with customers. And now we are on track to address empathy. And empathy, as the CPO of Lego was saying last week at the Web Summit, is the key thing about any customer service interaction. So we have to drive the empathy between the company and the customer. That's essentially all that we need to get to. Because many times, the problem is not solved, but if the agent can create empathy with the customer, we are, that's what we can achieve at most. And so it was very interesting to see the CPO of Lego talking about that. By the way, Lego is a customer of Unbabel, so we know it's one of the most loved brands in the world, by the way. Yeah, and so finally, the new metric for conversational quality estimation. And as scientific output, 15 papers, 15 orals, 10 master theses. So we achieved a lot of results in this area, participation in 2 shared tasks, and so on. And so, most important, we have outcomes from this activity that will be part of the product. Really excited about that. So moving forward to the product, okay. And so we are here on activity 6, and I'm going to tell you a little bit by giving you a short demo, okay. I can't resist giving demos on presentations because they may fail, and so it's much more exciting. So it's, yeah. So, and yeah, I'm going to tell you about how we are going to include the advances in quality estimation that we achieved on A3 into the product. And this is something really magic. Yesterday we were talking about this, and I always like to quote Manuela Veloso about this. She talks about QE, or about Enbabel, as a company that is delivering AI, that is developing AI, that knows what it doesn't know, which is really interesting, very inspiring. Okay, so I'm going to switch to them. Okay, sorry. I just have to reshare the screen. Sorry. Okay. Because the computer went to sleep. And okay. 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 And now share. Okay. Sharing now. Is it good? Okay. Amazing. Okay, so this is our sandbox for quality estimation. Let me write something here. Okay, let me, for example, write good afternoon. How can I help you? Okay, this would be a message that an agent would type. Okay, can scroll a little bit higher so that everyone can see. Good afternoon, how can I help you? And then the translation to Portuguese would be something like boa tarde. Okay, como posso ajudar-te? Okay, so for the Portuguese-speaking people here, so they will understand this. Sorry for the other people. Boa tarde, como posso ajudar-te? Okay, and so now I'm going to request our QE model to assess the quality of this translation. Okay, so and here it is. Okay, so I got 5 MQM. MQM is a quality score that is used in the translation industry, and that Enbabel is leading in a sense. You know, we were high participants initially in this initiative, and now we are using MQM everywhere. And so, as you can see here, there's something wrong with this. So the maximum is 100. Okay, by the way. So, and as you can see here, there are some things wrong with this translation. Can you guess what is wrong? Of course, the Portuguese people. I'm sorry for the others. The issue here is that I'm talking with the customer, and I should be talking with the customer in a formal tone, okay? Imagine this is a bank, and I want to treat the customer, in a formal way, and the translation is informal. That's why, and our QE model understood that this word here is not correct. So what I'm going to do now is to fix that, okay? I'm going to put, instead of ajudar-te, the informal, I'm going to put the formal, ajudar, okay? And then I'm going to run QE again. Okay? Hopefully it will work. Yes, 95 MQM. The quality improved. So AI that is understanding when the other AI is not delivering what it should. But there's still something missing here. We still have that small orange square over there. What's wrong with this part of the translation? I don't know, the linguists over there may help. Do you know, Elena? Okay, there's a comma missing here. And I did this before, of course. And so if I put the comma, I will get 99 MQM. And so our model is so good that it even detects when there's an error in the source. The agent forgot to put the comma after good afternoon. And when you are treating someone, you have to do that, okay? And so this is something game-changing in terms of product. We are leading in this area with all the data we have on annotations. And yeah, and this is a major outcome of the Maya project. You can switch to the slides. And the demo worked. Okay, you can switch 2 slides after. Oh, sorry, I have the clicker. Okay, so. Okay, yeah, so let's move to the next activity, or the next product application. So another area that I told you about is how we are going to productize answer generation. So this is a small video that tells you how auto-completion will work in the product. It's something we are still integrating in the product. And you can see here that this was trained with data from this specific customer that is a very well-known airline company. And so the agent is typing, and the auto-completion is generating, all the text to answer a specific question, okay? So this will speed up the interactions, of course, because the agent will type much faster. And now we can leverage this even more with large language models, but it will also deliver higher translation quality. And together with empathy and together with sentiment analysis, we can even make the agents more empathic with the customers, because we can introduce some bias for empathy, as we were talking yesterday. So another of the applications in terms of product is going to be, as I was describing, on sentiment analysis. And so this is something that we did. So we are now able to understand the sentiment of each of the turns of an interaction with the customer. In this case, this is a real, by the way, this is a real message that we took from a customer. And yeah, this customer was really pissed up with this company. Yeah, typical on customer service. And so by giving this feedback to the agent can, over the interaction, improve the sentiment of the customer, drive the sentiment of the customer to a point where it's higher than how we started, hopefully. And yeah, and then empathy. Empathy, as I was telling you about, is really now what everyone is talking about on the customer service world. So about empathy between customers and companies. And we are working on that. So to finish, in terms of activities, dissemination. So we published content online about the project. We have a blog, we have our website, and so on. This was an article by Graham in the beginning. We organized 2 customer-centric events to spread the word about Maya and about all these technologies, all these features. Here we are, is Ricardo over there on the picture. Really nice on the poster. And yeah, over 30 speakers last week. So the last one was exactly last week during the Web Summit. We received these awards about our technology from all these brands on customer service. We have, during the period of Maya, we got these amazing 4 reference customers. And when I was preparing this talk last week, I went to check Nike. So Nike has 617 agents using our technology for Dutch, French, German, and Italian. Really amazing. So Nike, Disney, wow. Who would imagine this 7 years ago when we joined Babel, and that we would have these customers? So we're also spreading our technology through partnerships. So we have 2 big partnerships with Salesforce and Zendesk, CRM providers. And so these are the number of agents that are using our technology on top of these integrations. And we also have our kind of what we call our experimentation test bed. That is a way for customers to start using Babel without the need to have an integration, okay? And we currently have 1,261 agents using Babel interface. So Babel interface is great because it allows us to prototype all these features in a very fast turnaround time. And this is very important to get feedback in terms of usability, in terms of validation, customer validation. So this is a high-level overview of all the activities and all the deliverables that we achieved already. In terms of scientific highlights, we would like to highlight 10 PhD students, 5 internships at CMU. So we sent a bunch of people, not only just these guys, but other people from Babel to Pittsburgh. We have an office there in Pittsburgh, very close to the university. 38 papers, which is amazing. 32 presentations, and we participated in 28 conferences. So I'm not going to go through all the papers, as you can imagine. 38 is a lot, but they are all here. Okay, I'm going to jam. Okay, a lot of papers and a lot of people contributing. In terms of jobs created, something that was really important for us from the beginning. So we created 8 highly qualified jobs. The first one was a senior AI researcher, and this year, I think in the summer, we hired the final one, an AI engineer joining the team. Finally, where are we in terms of product? I presented some graphs like this in the previous ERC meeting. Yeah, these are the number of agents that are using Babel, okay, at this point. for these products, not for all and Babel, just for the Maya products. And yeah, we reached the peak in December last year in terms of the number of agents. Do you guess why? On December, we are getting to this pattern because it was Christmas. And many people interact with companies during Christmas, they travel more and so on and so. And then I was thinking, oh, this is bad because the graph is going down. And so I'm going to present a graph that is going down. People in the audience will think, okay, is the product being less used? It's not that, because the volume is getting up. And so what we are getting to is to having less agents delivering more interactions, okay? Which means, reducing costs. So, and this is real data spread by all the languages. So you can see all the languages that we are supporting on these products. And so we reached our records in October. So really excited to share these numbers for the first time. And 64 million words in October. So I'm sure that next year we'll get to 1 billion words for the whole year. And thank you so much. Q&A now. And yeah, okay.
Thank you.
Your question.
Okay. Okay, maybe I can start with a question. So thank you for, I think these two projects are very interesting, very impactful, both in terms of research and the companies that are involved. So very happy to see this. One question, so you talked a lot about the empathy and about sentiment analysis. And I was wondering how, and this is something that we have been talking during these 2 days, how do you, are this or what you're developing enough to address, for example, cultural sensitivity? Because it's not just the female, there are some conversations that are appropriate in some cultures and not in others. So how do you tackle this issue?
Can you bring the next slide? Is it possible still? Or? Okay, yeah, so that's a great question. And if you put the next slide, I didn't want to talk about this, not to create false expectations.
Right.
Yeah, exactly. So we were just talking with one customer, Beyond Meat. I don't know if you know Beyond Meat, but they are getting very popular in LA 3 weeks ago. And they are afraid of using Babel in China, in Japan, in certain geographies in Asia, exactly because of culture and the lack of cultural awareness. Because, for example, if you ask a Japanese person, how can I help you? This will not be correct. So you cannot address a Japanese person asking, how can I help you? This is, and I learned that. So the correct way, by the way, can you jump to the next slide? Yes. The correct way for the Japanese-speaking people here, and I know Graham knows Japanese, is, and then the next one, the correct way is something, okay, yeah. Irashaimase. And irashaimase is like come in, the literal translation, because in Japan, they use this expression that comes from the old days of the markets, and they would invite people to come to the shops in the market by saying irashaimase. So if an agent starts a conversation with a Japanese customer by saying, hello, how can I help you? That translates to donoyo ni otesai shimai. Okay, sorry for the accent. It's not correct from a cultural perspective. Still, this is a big challenge. We are going to pursue it. Yeah, so it's on our product roadmap.
Okay, and I had not seen your slide before.
No, in fact, we never talked before, so.
Any questions from the audience?
Thank you, Paulo. I was wondering while listening to this that you're using this for fully automated agents. And I was wondering if you also think about using this technology to assist human operators who I know are under a lot of stress when they have to interface with clients and they are not answering properly what they are doing, if that's a business case for you guys.
Yeah, of course. So all this technology can be used to really augment, any kind of person in a interaction with the customer. So the concept here is about augmenting the person with AI, not replacing the person. So we don't believe in empathy generated by chatbots, for example. So we have some examples of conversations, like I always like to refer to this one, when a customer just jumped back into a conversation and said, "I'm sorry to be back only now, but my son was in the hospital during this weekend." And so, how could the chatbot reply to something like that? And so it's always about the combination of the human and AI, working together and really, because empathy is really a very hard, thing for machines to deliver. And so, so humans have to be in the loop.
Unfortunately, we're way behind on those schedules, so I think we'll have to thank our speakers, and these were great presentations. Thank you.
Thank you.
We will now have a brief 15-minute coffee break for the CMU Portugal student poster session and coffee. We will resume shortly for the panel Explorative Ideas for Ambitious Goals 2. We'll have Rima Padman, Trustees Professor of Management Science and Healthcare Informatics at CMU, and Francisca Leach, Director at Hospital de las Learning Health as moderators.
Is it done? I don't know. Well, good afternoon, everyone. Welcome to this last but not least of the panel presentations. We have 3 exciting presentations scheduled today. So let's start with the first one. It's exoskins. That's the first presentation. Shall we go ahead with that? Thank you. I've got the list here. Do you want to say the rest? That's okay. You can ask the questions. Okay. Start the questions.
Just to check if it's working. Okay, good afternoon. So today I'm going to present the project Exoskin, which is about human AI co-design of robotic and personalized compliant exoskins for physical exercise, prosthesis, and rehabilitation. So the PI from Carnegie Mellon, Professor Lining Yao, couldn't be present today. The co-PI is Carmel Majidi. My name is Mahmoud Tabakkoli, and my co-PI here in the University of Coimbra is Anibal de Almeida. So we are going to talk a little bit about the importance of exoskeleton and exoskin, because we see a lot of applications first in virtual reality, and more we see the importance of this in rehabilitation and assistive devices. We know the exoskeleton from the hard technology that uses electrical motors and the traditional actuators that this has attracted a lot of funds during the last 30, 40 years. But what we are looking into is to have what we call exoskin. So exoskin is in fact a term that was used by Professor Lining Yao. And the idea here is that we use the most wearable technology that we have today, which is the textile, right? The textile is the most wearable technology, or other type of soft materials that we can wear actually, and they go very well, they are very compliant, and we don't feel really an external object being carried on us. So our goal in this project is to make an AI-enabled computational design framework to develop patient-specific exoskin using soft actuators and soft sensors integrated into the system. So the research progress, to talk about the research progress, I need to talk a little bit about the background of the soft robotics. As you know, the robotics has started to evolve, and we have started to understand that integration of soft and compliant materials brings a lot of advantages to the robotics system, because traditional robots made out of rigid systems are not safe to work with, especially when we are talking about this kind of system that they should collaborate with the human. And we want this system to be very safe and safe to work with. And when it comes to the wearable robotics, of course, it's obvious that we want systems that they have a mechanical matching with human organs and human skin, so that we are not really feeling that there is an external object there. So the challenge here really is the actuator. How we make an actuator that is soft. And we cannot, of course, rely on traditional actuators such as electrical motors. And so there are a lot of different actuators such as pneumatic muscles, shape memory alloys, dielectric elastomers, and liquid crystal elastomers. And our focus here today is the liquid crystal elastomer, the fourth in the row, because of certain advantages that this liquid crystal elastomer brings. But the most important one that is very interesting for us is the possibility of printing this material, because shape memory alloys are excellent. They have very good high power to weight ratio, but printing of shape memory alloys is not possible. Dielectric elastomers have certain other problems, and so we started to look more closely into liquid crystal elastomers. And here you see a video of LCE, that when we put the LCE in a hot water, this reacts to the temperature, in fact,
And because of the mesogens that are inside the liquid crystal elastomer, they start to change their alignment. We have some sort of motion here. Now, the problem, though, is that we cannot use heat, right? Because we want to have something that can be stimulated by electrical signal. So what we can do is to use the Joule heating. So using the electrical current in order to heat the signal, heat the LCE. And what happened was that some people started to try this, and what you see on the right side of the slide, you see a silver ink that is went around the liquid crystal elastomer to hit the LCE, and then the LCE hits and then changes changes the mesogens and acts. The problem is that most of the ink that we have today, they are not stretchable. So if imagine you want to stretch this many times, and this needs the actuator needs to work and work and work, after 100 cycles, we lose the actuator because the conductive ink that we printed over the LCE is not anymore able to deliver the electrical current that we want. So in my lab, we are working mostly on conductive inks based on the liquid metal. So based on the liquid metal, we are able to make an ink that is printable, and we patented several technologies that permits us to directly print these inks at the room temperature. Doesn't need to go to the oven. It's self-healing. You can stretch this thousands of the time. It maintains its mechanical and electrical properties. So here you see, for instance, on the right image, you see on the orange is an ink that made with only silver and a polymer. And when we put some strain on this, it starts to lose the conductivity. Whereas the liquid metal-based ink can receive a lot of strain and many repetitive cycles and still is functional. So we have started to combine these two words, and our approach was basically to print the liquid crystal elastomer in the first instance, and then print our conductive stretchable ink over this in order to make Joule heating. And so here you see the printing setup with very simple and accessible printer. Is a basic extrusion printer that is able to print both materials. The LC is a little bit more challenging because of the viscosity. The ink is easier to print. So some optimization, I don't go through this, and see here you see a video which shows the LCE basically is being heated by the conductor and then goes back to the original state. So further optimization on the ink printing and some of the applications that you can see here. So here now the idea is that we also integrate microchips, we also integrate sensors, and put a system that is fully printed, and we are able to integrate all of this. So here is an example of what you can see as a combination of an actuator and a capacitive sensor. So it's a touch button that's a capacitive sensor, is able to measure the finger touch. At the same time, is able to deform and change the shape. Is another example where here we have a top receiver, and we have some infrared transmitters here. So here you have one receiver, and there you have another receiver, and here you have a transmitter. So by changing basically the angle of the actuator when we apply a signal, then the infrared transmitter is able to communicate with either one of them selectively. Another example of a sensor integrated into the LCE, where we touch the sensor that starts to move. It's like a kind of a very basic starting point for a mobile robot made out of LCE. And now I want to go a little bit to the system design and computational platform. So what we want to work on is some kind of reconfigurable assistive device that is wearable. So for different purposes, for rehabilitation, for different types of assistive devices, we can use this system. So here we have another component in addition to the actuator, which is a material that changes the stiffness based on an electrical signal or based on the heat. So here, imagine if you have this blue material that changes the stiffness, and the next moment we gain some degrees of freedom here. And so here is an example of a device already with this material. On the left, you see the default case where basically this everything is rigid, then we are able to take some of these out of the equation because we make them soft, so we gain 1 degree of freedom, and then we can gain additional degree of freedom by selectively make these materials to go from the rigid to the flexible case. So here is a design of the system. The concept here is that we basically, by selectively going from the rigid to soft transition, we are able to lock or gain degrees of freedom for an assistive device for the wrist. And so this is an example of, this is a video, I believe. Let me see. Yeah, now. So here is an example of development that we integrated this system inside the hand. So this is the video again from the Professor Liling Yao lab. And what's happening here is that by changing the stiffness of these rods, they are able to add some degree of freedom to one direction, and then by unlocking again another degree of freedom, they can make the movement on both directions. And you also the challenge, of course, a little bit of the challenge here is a computational design, because we are basically working with soft materials that have high degree of freedom, and we do need some sort of machine computation in order to help us to be able to design this system. And so this is based on this software that was also developed at the CMU at Lining Yao's lab. And this software permits to add different actuators and do a sort of simulation. Then the next step is to combine this software with the data that we gain from the patient or from the person that is using, and we want to input this data back to this software in order to improve the functionality of the device using machine computation. And with that, I would like to conclude my talk. Thank you very much.
Okay. Thank you for a very interesting presentation of an extremely complex project. Do we have any questions from the audience? Yes, one over there.
Yeah, it's very interesting. There have been in the past a lot of other attempts to building up this kind of, I mean, as you mentioned, in these kind of soft actuators. I wonder, it seems to me in your presentation that the speed of contraction was not very high. Is this, an unsurmountable limitation, or you can think of structuring like in fibers or making them parallel so that you can increase the speed without losing the traction force, of course?
Yeah, you actually asked the question and answered already. So
Okay.
the problem of these actuators, they act in a reasonable speed, but when they want to retract, go back to the original case, because we have they need to lose the temperature, it takes time. Yeah. Very similar to shape memory alloys. And of course, the solution, as you told, is going to the fibers. So we are actually working. There was a slide I passed because of lack of time, but we are working on making fibers of LCE. And when making the fibers, the transmission of the heat and then losing the heat becomes faster.
Okay. Thanks. Thank you.
What are some of the challenges with customization? Because you would need, for a child versus an elderly person versus, so what are some of the challenges that you're seeing?
Customization.
Yeah.
Well, that's exactly why we focus on LCE, because we can print them. When we can print, printing is very advantageous for customization, because we want to have very specific design that we do the design on the fly, and the next hour we have the design and we are able to test it. When we go, for instance, with dielectric actuators, they have very, also regarding the previous question, they're very fast dielectric actuators. The problem is that they are not quite printable. So it's very labor intensive to make those. That's why we specifically, because of the customization, went to the LCE. liquid crystal elastomers.
Thank you.
Any other questions? I have just one question. Does the person need to have some range of motion still, or the contraction strength is enough for someone that doesn't have any movement, for instance, on his own?
Depends on the application, because in some application we want to do rehabilitation, but when we do these kind of exercises, we want the patient to be locked on one side and be able to move on the other side. Or let's say in this case, the patient is able to move. By a stiffness locking, we just remove 1 degree of freedom so that we are sure that the patient is moving on one side. When it comes to the actuator, the first part, which is LCE, is really to assist the patient that doesn't have enough force to grab the object, to help them to grasp the object in a better. So two different things. One is a stiffness changing, the other one is the actuator that helps really the patient to increase the force of the actuation.
Okay, but even, for instance, if it's a leg where the contraction strength has to be much higher, would these type of materials work as well?
Is a challenge. Again, I think the solution is to go to the fibers, because when we look at the human muscles is also made a lot of muscle fibers, right? And now we are working on the bulk of the material. The next step is that we make these fibers that are coated by a conductive material, and then we can use each of these fibers as one of the fibers of the muscle, and then we twist all of them together to make it much more efficient than exists today.
Thank you. Oh, sorry.
One last question. I think we still have time.
Yeah.
Thank you. Do you think this is tailorable or applicable to things like Parkinson's disease for assistive technologies in that sort of application or not?
Well, I wish one day. I mean, this is one of my personal goals, because I have family suffering from Parkinson. And it would be really good if we could use these devices, because in fact we are now in the sensor side. We have very good wearable sensors that are able to measure the tremor, for instance. In fact, I saw one product is already a wearable device, but it doesn't use the actuator. It uses electrical stimulation in order to block the nerve. So they measure the tremor. When the tremor comes, I think we will get there very soon, in my opinion, and I hope so.
Great. Thank you.
Thank you.
Yeah.
Thank you very much. Yeah.
Thank you.
The next one is Shift HRI, exploring the transfer of agency to older adults in HRI.
Good afternoon, everybody. My name is Jody Ferlizzi. I'm a professor in human-computer interaction in the School of Computer Science, and along with Tiago Guerrero and Alexander Bernardino, we are working on Shift HRI. So our collaboration unfolded very naturally from visits across the ocean and to labs, and in December 2019, we pitched this exploratory grant. And you can see our teams here when we visited in Portugal. And now we're funding 2 PhD students, and we have a master's student at CMU. It's quite exciting to see the growth and interest in human-computer interaction and human-robot interaction and the groups. So our focus is on the aging population, which, as you know, is growing substantially. And ageism is actually the most substantial ism in the world. The detriment to society is huge in terms of abuse, cost, medical cost, illness, and general stress in the population. And the aging population continues to grow, and we don't have enough facilities to take care of people. And so people have turned to robotics, and at CMU, this has been an interest for a long time. And what you see here is almost 20 years ago, one of the first assistive robots for the elder population and their caregivers, Pearl. And what we learned in that effort is that along with engineering efforts, we need design efforts to appropriately design technology that people will use and welcome and that won't end up in a landfill. So this project, Shift HRI, continues that trend. And so the goal in this work is to explore the transfer of agency in human-robot interaction to older adults in order to empower them, and to advance research in HRI to look at new relationships and new interaction modalities for people in this advanced technology. And to do so, we're looking at human values and self-perception of aging. So we want to understand what older adults value and how assistive robots can help them in realizing this, and looking at new ways for people to take control of this technology and program it themselves. And then looking at things like self-efficacy and how that could be used to control robots. So the work I'm presenting here is a set of qualitative data and interviews, and that will be next in turn used to figure out how we should build and program this technology. So our method was to explore values that are predominantly held by elders through 22 semi-structured interviews in 2 continents. We studied people in Portugal and India, and 100 PVQ questionnaires. This is a social science questionnaire that allows people to elicit their values. In the interviews, we asked people to explore their life stories, figure out what people talked about that was important, and use this lens of value-sensitive design, which basically says that we should consider all stakeholders in the design of technology, not just users, but caregivers, family members, and people even in the community that may be called on for ad hoc assistance. So some of the themes emerging from this data, which we're still analyzing, are, for example, self-identity and perception of control. So it turns out that people's personality makeup and what they value influences their goals, which in turn shapes their identity. So for example, when people talked about their identity, some talked about their careers, some talked about their families, with which they were proud, but others talked about frustration and a lack of ability as they aged, or maybe where they lived. I forgot to mention that we did these interviews in 4 contexts, which was really interesting. People who lived independently, people who lived in residential facilities with some services, people who lived in nursing homes, which had much less control, and then people who lived in elder universities, which I believe are unique to Portugal, where people have the opportunity to do lifelong learning. So some of these people experienced a lot of freedom, particularly those in elder universities, and they had the ability to make decisions, learn new things, be creative, and they had a sense of much more control over their lives. And we also saw this interesting use of technology to increase agency and a sense of freedom. So for example, one of our participants used Google Maps to visit the world, zoom in and look at places where they had lived or visited, and then to look at new places. So this was a really inspiring opportunity. People maintain purpose in their life by having goals. So goals are tied to our motivations, and we have both intrinsic and extrinsic motivations and goals. We might have an intrinsic goal of helping people, and this can be operationalized extrinsically, for example, by taking somebody shopping. So people had varying desire to achieve goals, and this was often tied to the context in which they lived. But when they were able to achieve their goals, they had a sense of accomplishment and significance. But some people who lived in full nursing facilities felt unmotivated and lethargic, and we saw some opportunities for technology here to maybe change this. Finally, the stereotypes about aging and technology use. So as we said, one of the themes that we're really interested in is what's called self-perception of aging. And when people have a negative self-perception of aging, it's very detrimental to their health and in turn, public health and society. But people who have positive self-perception of aging are often well and thrive into old age. And people who live in rural Portugal are very healthy, and they are very positive in their self-perception. These people value intellectual and physical challenges. They value adventure, both in physical and virtual worlds. And many people rely on technology to do this. So we are seeing in the research that self-perception of aging can be manipulated in positive ways, and we're interested if we can see how to use robotic technology to do this. So our future work is to continue to analyze this data, to conduct workshops with further participants, to have them experience the technology firsthand, and to design new interactions with these robots that are anchored in what elders value, that match their priorities in life, that maybe compensate for or build on the kinds of places where they're living, and to match their designs for the robots to elders' self-images, their expectations, and their intentions. So my message to take away is that we need not only engineering and computer science, but we need human-computer interaction and design to find best ways to design these technologies to adopt and empower users. And with the appropriate consideration, we can increase technology acceptance, self-efficacy, and self-perception of aging of elders and caregivers and others who are in this ecology. Thanks, and I'll take questions.
Thank you very much. Any questions from the audience? Yes, there's one over there.
This is a question driven by personal experience with my mother. So the question I have is, in terms of the time period of your interviews and your work, how has that overlapped with the pandemic? And how did, shutdowns affect both perception, isolation, and your ability to do your work?
Thank you. Yeah, so the pandemic did affect our ability to do some of the work. It went very slowly. And in general, I think we're going to see a long tail from the pandemic in terms of decreased wellness in this population. People were shut in, many were ill, not moving around as much, not having as much social interaction, not seeing families. All of this was, potentially a drawback. And I think also, though, there's an opportunity to maybe explore how technology could be used in better ways to support the population.
Maybe to bounce back.
Bounce back, yes. Thank you.
Any other questions?
Judy, have you thought about turning the robotic interactions around to say that, well, once the robots have been designed and trained to interact with the elderly, they could turn it around and say, how can you teach younger adults to interact with the elderly? Because the generations are just having such a hard time, interacting with each other. So now use robots to educate and inform the younger.
Thanks. I think that's an excellent question. And I didn't have time to talk about it, but some of the workshops we did do were in elder residences, and younger people were there, and there were some very interesting interactions around that technology. So yes, I think that cross-generational examination of this area is also very important. Thanks.
Right.
I have two questions. The first one, and I know it's a limited size of participants group, but did you see any trends between genders or cultures in terms of what they identify as priorities or their perception of being in control?
We saw some differences between cultures. I think the greater differences, though, were in terms of where people lived, whether they lived independently or in a full nursing home facility. That really seemed to affect sense of self-efficacy, values, etc. And yes, people in those generations had much more traditional gender roles, women taking care of the house and the family. But we also heard some really interesting stories of travel, people moving to new places, taking their families to places where they could have better lives. And these were across genders and socioeconomic status.
Okay. So my other question is, once you have the robots, will you have kind of a threshold for mental state of the person using it? If you have someone already with early dementia or something like this, will this person also be able to participate, or what are you thinking?
Yeah, I mean, I think that's an important consideration. We have to generate designs that everybody can use. We have to create the Gmail of human-robot interaction, and I don't think that's going to be simple. So, yeah, thank you.
One question.
Have you heard of the Longitude Prize 2022?
Yes,
Okay.
thank you.
I have a more practical question. Fantastic work, by the way, but I wondered how the human subjects rules impacted your work, and particularly human subjects rules that crossed EU and US boundaries. Has that provided a particular challenge? Or?
Yes, human subjects regulations provide challenges, but we've been able to actually keep our IRBs separate and look at de-identified data across teams. But it's a huge issue in these multi-institutional projects.
Researchers. So you mean you each observe on your own side, and then at a higher level you collaborate.
And then we de-identify the data and look at it together. That's the current process. But I could talk about that for a long time. So.
Thank you. I'm trying to help someone else, so I will come back to you.
Right, thanks. All right.
Any other questions? All right, thank you.
Thank you.
The third talk is MD to Trust, Trustworthy Data Science for Improving Healthcare Efficiency.
Okay. Hi, everyone. So our work is more on the management of healthcare more than patients themselves. So this will be kind of a new flavor. So this project is about trustworthy data science for improving healthcare efficiency. And we are focusing especially on the medical referral process. So this is from the approved project. So we want to develop a recommended system for referral of specialist care doctors by primary care doctors when a patient comes in and says, oh, I have this pain on my left arm. And the primary care will look up for a specialist, in general, 3 specialist names. And from his head, in 3 seconds, he comes up with 3 names, right? So, and this is something that in, let's say, informal conversations, the medical society says, okay, we remember who we know that is actually matching this person's symptoms. But this is something that we can improve upon, right? So, so what we want to do is twofold. For one, we want to be compatible with current referral practice and not disturb doctors. If they know this doctor, if it's a really good doctor, we don't want to override that. But we also want to encourage this organizational change in a transparent way, in a trustworthy way. And so that the doctors feel confident on looking at the recommendations of this recommending system and say, okay, I agree with, let's say, 1 or 2 or 3 of the names. So this is our problem, and I can tell you it's hard, but it's really exciting. So this is our team. In Carnegie Mellon side, we have Ayin Jesu. This is a very multidisciplinary team. We have people from human-computer interaction. Ai, she's actually now an associate professor. This is a bit outdated. And we have Yun Jie. She's from the electrical and computer engineering department. And and this is 2 of us, me and Chiwei. We are both from Nova University. I'm from the faculty of Nova School of Science and Technology, while Chiwei is more in the data science and management side in the Nova School of Business and Economics. So we had this very multidisciplinary team because the problem is, in fact, multidisciplinary. So in first, we will talk about what is in fact medical referral and what have we retrieved from the data. This work is done with KUF Health. This is important to state. So they are our partners for some time, and we'll talk about that later. Okay, so medical referral. We have this referral mechanism that I more or less summarized. we have the patient consults with the primary care doctor, the primary care doctor, if necessary, will refer this patient to a specialist doctor. And after a while, a few days, the patient will consult with the specialist doctor. This is the standard referral. And this raises a lot of questions. We know that this is the relationship between patient and specialist doctor, or any doctor, by the way, is very important for the success of the treatment. And so we want to assess how these mechanisms will affect different aspects, like patient care, like patient satisfaction, healthcare costs also, and how precisely from data we want to have this knowledge from the data itself, how are referrals done. So, not working. So do people refer within the same healthcare center, between colleagues that know each other? Sometimes this doesn't work. Okay, so our initial data had two databases from CUF Health. One was with consultation transactions, and this is just financial information saying that patient went to the hospital and had an appointment in specialty whatever. And this is what we had. And the other database is medical HR. So we knew which doctors were there, how many specialists, how many primary care, their specialty, some demographics, and some information related to where they studied and where they worked previously. Okay. So we built the referral graphs from these data sets. So we had to create our own labels because nobody knows what is happening inside the clinician's office. Nobody knows the three names that were written on a piece of paper. And so we had to discover that. Okay, so first appointment. Do you have another thing like this? It's not working. Huh? Okay. I'm like clicking tremendously. No, it's not. It's just clicking through the. Thank you. Okay, so when we have from the first appointment to the second appointment less than 1 month, we consider that this was a referral. Okay, and this is the distribution of the interactions, and we see here the 1 month period. This is cumulative, so we have that 30% of the interactions happened after 1 month, before 1 month. So our referral graph will be a weighted bipartite graph, where we have 294 primary care doctors and almost 840 specialist doctors. And this creates, with all the consultations, with all the patients, about 35K edges. So 35K consultations and referrals. Oh, now it's running. Okay. So we checked a few things. So the social graph that we created from the human resources data is we tried to discover the social links. We saw those people that worked, those doctors that work on the same location, those that had the same internship location, those that studied on the same medical school within 2 years interval. And by getting this information, we draw this social network graph or professional knowledge graph, where we had now 120K edges, so relationships between doctors. So where do we come from? Now we know this. What did we do so far? So we formulated this medical referral problem as a link prediction task. And link prediction task, for this link prediction task, we used a graph neural network. And we took from the social graph, we took a few features of each doctor. We compute these centrality measures like degree centrality, betweenness, eigenvector centrality, and we imputed that as, let's say, features of each doctor. And we constructed this bipartite referral graph. One side, the primary care, the other side, the specialist doctors. And we took some attributes, some demographics, we joined with these social network measures, and we performed link predictions with and without the social network measures to actually see if it is true that anecdotal information, that medical referral is actually done by using this, let's say, knowledge of people in the social domain. Okay, and we actually got this information that we had. With information, we always have an increase in accuracy. And next, in our project, we wanted to know, why is this so, right? Why are this neural network interpreting or predicting so well this relationship? So our goal is to discover the kind of mechanics, if you can call that so, of medical referral, and then try to act on them in a transparent way, in order to have other types of incentives for referral. So we did this work of causal explanations for this black box graph neural network, which is very, very difficult to explain because it's a big graph, it's a complex system. So it's something that is really, really complex. And here, people in the research team in machine learning and optimization, like Yunje and me, were really on this topic. Also, the recommended system for specialist referrals, where institutional policy will be applied in a transparent way. And here, HCI is very important to define what is transparency, right? What does it mean? It will be very different according to populations. And then we had a real stakeholder to guide our hypothesis. And this is very important because, for example, we had a few databases and they are legally siloed, right? You cannot join all the data together. It's not possible. So sometimes you have to do machine learning that works in a federated way, but then people working on federated decentralized learning know that this takes a lot of time. So the inferences are not as fast as we would like. So we worked a lot on this too. So another type of problem came up and we addressed it. Okay, so now Chiwi.
Yeah, sure. All right, thanks, Claudia. So as Claudia said, that we have tried to work with this local health care network called CUF. And it all started from the time 5 years ago when we actually tried to build up these academic collaborations. And as you probably know, it's not that easy, especially when you work with health organization, which values a lot about their patient privacy and also about how the academics and the hospital would actually benefit from the both. And basically, at the time that we actually first worked with them as this recommender system, but it was actually before we think about the referral problem. That is, we try to come up with the idea of so-called the personal family doctors for them. So whenever you actually want to go to any hospital network like CUF, and now you probably want to actually first visit your family doctor. And it's not actually that easy for you to find the one doctor that you trust the most. And so we actually try to use the same data and work with the doctors there, and then to try to understand what factors that may affect on the trusting long-term patient-doctor relationship and build up a recommender system for them. And so back then, at the time that it was all started as a collaboration between Nova SBE and the Data Science for Social Good program with Rai Ghani, who is actually now at Heinz College at CMU. And we were actually building up this recommender system as a prototype for the CUF to actually examine whether it will help to promote the patient-doctor relationship at the time. And of course, we start to think about what can be done on top of that, which brought us to think one step ahead, which is that how can we actually further help the doctors to actually make the referral decisions. Okay, so some of the results that we have got, that includes the work that we have tried to work with the machine learning algorithms to make the recommendation system for both the referral network and also the healthcare recommender system by using the healthcare domain knowledge. And we also have a few papers in terms of the optimization of machine learning that is served as our theoretical foundations. Yeah. Yep. Oh, sorry.
Okay. So just to explore a little bit, so we have a few, let's say, complex systems conferences, but we also have machine learning for healthcare, which is one of the top conferences on this specific topic. And we have, again, with the Ungie and the team members, namely Pedro, which is a CMU Portugal PhD student at CMU now, and part of the project also. We have this idea for the multi-token coordinate descent method for vertical federated learning that fits very well with this problem, because we have like this very fast algorithm that can keep some data privacy while being really fast. And we have this causal inference explanation to do take the model and try to take from it all the causality in terms of causal effects of why the model does this type of predictions. You want to talk about the?
Yeah, sure. Yeah, and also in order to to help to train the next generation of aspiring data science who care about the social good and social impact without trying to make up the bias these machine learning models, we also trying to use this data set as an opportunity to work with the master students to develop their thesis opportunities. And here are some of these master thesis examples that have been concluded and under development. That includes ones that allow us to actually look at the referral mechanism and also develop some of this automated system for example, the symptom checker that allow us to actually first to understand what kind of the symptoms that the patient would have in order to make the relevant the recommendations for them.
Okay, so we have developed a few synergies. One was a project from FCT RCCN that was TrustDL. We won this project for computation credits on Google Cloud, and we have applied for the 120K level to do this causal experiments, like taking the graph neural network there and just bombard it with queries so that we have a very, let's say, detailed grid and compute the causal effect there. And when I say causal effect, I say in the sense of UDA Pearl's developments. And we also had an award, the AI Talents Award, and the researcher of the project, Sahil Kumar, was awarded with this AI Talents by Foundation Carlos Gulbenkian from Portugal. So this is also a very rewarding and interesting aspect of the project. Okay, so this is us. Anything, drop us a line. We'll be eager to know your opinions here and afterwards. Thank you.
I believe we have time for only one short question. So if anyone wants to ask one question here, please.
So maybe this is politically incorrect, but I'll ask anyway. So you're looking at the causal modeling that you're now working on is trying to understand which factors lead to a particular recommendation, right? Now I could take a different tack and say, let's look at outcomes. And assuming you have enough data, which you may, say, can I determine whether a recommendation was a good recommendation or a bad recommendation? Now, maybe the doctors wouldn't like it, but maybe the organizations would. So what do you say?
So yeah, so this is a lot of very sensitive stuff. For example, what is a good recommendation? Is it based on the outcome? Is the patient better? Sometimes it's difficult to judge because some doctors, they are so good that they only treat very difficult cases and they have a high mortality, for example. So even if we want to measure the outcome in healthcare, in health returns, it's not easy, but it's very, very, very interesting. And yeah, so even the label that we have, is it a referral or not? We had to construct it because there are so many issues around the data privacy and not being on the consultation area. So you cannot be there. You don't know that the referral was done. You can just infer. But yeah, so there are lots of interesting questions around that area that unfortunately you can only look at them with from far away.
Actually, insurance companies in the US are really looking at this problem. They want, yeah, health insurers looking at this.
Really?
Yeah. Looking at the outcomes, and they're trying to determine the in-network versus the out-of-network, physicians that they want in their plans.
Yeah,
that's
right. That's interesting, because if they do that, how do they kind of measure that with the difficulty of the sickness itself, the pathology? How can they measure?
Yeah, we can talk offline.
Yeah, sure.
Yeah. Thank you all very much, and thank you for the team.
We now welcome Nuno Nunes, National Co-Director of the CMU Portugal program, to introduce our last keynote speaker.
Okay, good afternoon. I'm sure everybody here is already very tired. It was a very exciting second day. We will have the only online keynote speaker, actually the only online presentation that for these 2 days of conference, and it is my pleasure to introduce you Nicolas Magas, who is one of the most important people in Europe. I will have to say that, combining science, art, design, and technology. She's been doing that for over 25 years. She's an innovator advisor of the European Commission and the G7, a creator of Industry Commons, and a member of von der Leyen's high-level roundtable group on the New European Bauhaus, and also an advisory board of CERN Idea Square, and won in 2017 the European Women Innovator Award of the Year. Michaela, I think more than anyone else, could explain how and inspire us in looking forward to the fourth stage of the Carnegie Mellon Portugal partnership and making the connection between the US and the European Union. So I hope that we have Michaela online. The screen is yours, Michaela. It's a pleasure.
Thank you, and thank you for this really generous introduction. I will try and live up to it. And also thank you for being late, because I had the pleasure to listen to several wonderful presentations that are highly relevant, and I wish I could dive in at such a granular level actually with my presentation, but I'm going to keep it slightly more high level because we have to cover a lot of grounds. But at all times I would encourage you to actually pay attention to some of the individual initiatives that we are running, and if those are relevant to you in any way from the research point of view, please get in touch with us because we would love to collaborate. We collaborate with a huge amount of communities outside of our core consortia on our projects. So let me just see if I can launch the slides on here. Oh, we've got the slides. Excellent. So, as I say, I'm here in a triple function. One is as member of President von der Leyen's high-level roundtable for the New European Bauhaus Initiative, and I will explain a little bit about what that is about and why it is relevant to future technology frontiers. But also as someone who has founded inadvertently, and this was sort of accidental at the beginning, a very large prototyping community, multidisciplinary community that spans the globe. It's completely transgenerational and completely inclusive, that is spanning from New Zealand to Alaska. And where we have, for the past 10 years with this community, we have been testing frontier technologies and seeing how they affect human behavior, but also human capability. And this has evolved into enabling systems that we have scaled to industry. So my speech will somehow connect those three dots. So I will start with a statement by President von der Leyen at her inaugural speech in 2020, when she introduced this idea of the New European Bauhaus Initiative, where she was advocating for several multidisciplinary communities to join forces and actually start to prototype solutions for the Green Deal. As you know, in Europe, we are very keen on creating solutions for sustainability. But the initiative united three elements: sustainability, inclusion, and aesthetics, which was very interesting. And it was particularly directed to improving our living environment. Now, I will loop back to this, but it is an interesting junction in the evolution of policy making in Europe. It has proven since to be extremely successful. It has onboarded vast communities and assembled huge amounts of ideas on the ground. But it didn't come from nothing. So what I will do is show you how we have been demonstrating to policymakers why it's important to create spaces for common understanding between disciplines where we can test drive some of our frontier technologies. So I will actually rewind a few years back, and this is in 2016, in the last month of Obama's presidency, when he was asked to curate, to edit actually the edition of Wired magazine and choose some of the technology frontiers. And we were very surprised and very honored to be chosen as one of those with our representative Victoria Modesta, whom at that time I had actually asked to represent our community. So our whole community was listed in a full page, and our representative was there. Now, Victoria does matter a great deal in this story. So I will illustrate first a use case or an expanded use case that really informed policymakers, but also informed our researchers in terms of what technology can really mean when you test it on the ground with multidisciplinary researchers. So this is Victoria, and you will be obviously immediately very aware of the apparent limitations, or at least in the old way of describing people's abilities, we would call these limitations, or we would classify Victoria in terms of her contribution, for example, of closing the Paralympics in London. It is a particular category of people that we place her in. However, Victoria has been fantastic as an advocate for changing the perception and changing how we categorize people. And of course, with the help of technology. She was chosen by me to represent our community when our community rose to over 5,000, because she was such a fierce advocate for changing perceptions. She was also female, and she later became also fellow of MIT. She is also performing in series in the US, sci-fi series in the US, but also very active in technology prototyping. So very interesting use case and very much culture-based. This connects to this idea of the European Bauhaus that has placed culture at the center of prototyping. Now, what we did with Victoria, and we did very, very many experiments, but this is one of them which I wish to highlight, was to connect it to neurofeedback sensors and then allow her to train. Now, this wasn't the case of us finding new ways to interpret the data that the neurofeedback sensor was reading. We flipped this and we started to look at how a person can train to control systems via neurofeedback. And so she was connected to a projection mapping and a lighting system that she could control while she was performing. So during her choreographed movements and during her singing, she was able to express herself in another dimension, starting to train to control systems directly from her brain. And we thought this would be extremely difficult. So she trained throughout a week, but by the end of the week, she was able to do it seamlessly. So this gave us a great deal of hope that we could further experiment in terms of how we can enable people with systems and with new kinds of interfaces that are data-driven, and how we could test their capabilities. And so in oh, by the way, I need to mention this. You will notice how many women are prototyping technologies in our labs. And I must say that this has got a lot to do with the fact that it is very much culture driven, and we do create a level playing field where everyone feels on an equal footing, no matter what background they come from, what sort of area of research. In this case, for instance, you see a few students from MIT, you see a few people from Ars Electronica Future Lab, you will see also the person who later became the first winner of the National Hungarian Video Awards. So very, very accomplished, capable researchers from various different disciplines, but in this case, all women in this photo. And this is a still from a documentary that MIT made about the labs. Now, we took this further in Slush in Helsinki. This is one of the biggest conventions in the world of startups and investors. And we opened Slush by challenging the traditional 3-minute pitch, which we felt could not dive deeply into how technology affects human beings, with a 20-minute performance that allowed the audience to experience the effect of what we had just created that week. And in this case, we placed at the center of a transdisciplinary collaboration a person who is very proud to be a blind singer and a vocal coach from the Sibelius Academy, Riikka Hänninen. And we, again, did various different experiments of how she could be enabled, including very simple use of technology where we hooked audience members to a pulse sensor so that Riikka could establish a communication to them. But what was really interesting is when we took our development of the neurofeedback sensor approach to the next level. And in this case, the system was adapted from clinical trials. The clinical trials for people, particularly who suffer from anxiety attacks, and where neurofeedback is used to visualize brain activity. And brain patterns change before the person is aware of an onslaught of an attack. And therefore, it is used by clinicians to allow them to recognize those moments and start to train to control it. Now, in this case, our neurofeedback team adjusted this system to, instead of usual visualization patterns, allow the user to move up and down the musical scale and start to play music directly from their brain. And what was particularly interesting was that during our experimentation during the week, the lab participants, who included data scientists and interface designers and accessibility specialists, for example, they were all being trained to use the system, and it took on average around 2 hours for people to be able to do this, which was quite an achievement already. But then Riikka, the blind singer, put the neurofeedback sensors on, and she was able to play instantly. And then the neurofeedback team suddenly went, well, this is really interesting. It has never happened to us before. And of course, they immediately had ideas to research further, to write a paper. So this happens by default in our experimental environments. But what was particularly interesting about this was, of course, that someone who in the mechanical era had been classified as being less able-bodied was suddenly proving with these new approaches, data-driven interface approaches, far more talented than the rest of us. And of course, I feed these moments directly to policymakers to illustrate just how much these experiments not only inform the researchers, but actually how significant they are for the future of work or for how we design systems in the future. So these are some examples which I wanted to highlight for you. Now, of course, we don't just leave it to chance. We highly curate these moments. The people who are invited are groups of people who have interest in particular areas from different disciplines and who are sufficiently open-minded to, let's say, relax their area of specialism and be curious about other domains and other areas of specialism. And we also build systems that allow people to register their attribution and their contribution to this co-creation space. So we started doing this a long time ago, more than 10 years ago, about 12 years ago. I started with something that was supported by CERN and Innovate UK, where I created open product licenses for data-driven products that were starting to be built, not as a finished product that's deployed to a market, but as points of departure for others to build upon, whether through customization or through other ideas and other innovations that can build on those. And in 2017, we were already testing registration of intellectual property in real time during the co-creation process, because we wanted each one of these multidisciplinary stakeholders to actually see themselves reflected in the value network. And this loops back later in our work, which I will highlight it. I think you will find that this, for instance, idea of intellectual property tracking pops up quite a lot through our later work. Now, some of the enabling mechanisms we created with a series of pilots back in 2015, one of the first innovation actions in Europe. I will not go into detail of what these were, but they actually did influence 74% of innovation recommendations for the Connect Advisory Forum for the Directorate General of Information and Communication Technologies in the European Commission. And this was all through this type of approach to experimentation. And we every time we do these enablers, what is at the focus is basically observing how people work together and how we can give them the tools to work better or produce better results that turn out to be very, very interesting and often surprising for researchers. So, for example, in this case, with the enablement of tracking and tracing intellectual property in this space, we were able to speed up technology transfer by means of creating embeddedware that could port data into new and create new affordances for new products. And where we thought we could get a couple of new products from our pilots, we ended up with 11. In this particular example that you see on the screen, in month 5, through this technology transfer, we had a seed idea prototyped, a working prototype 4 months later, and already in month 5, because of the clarity of the intellectual property at stake, the product patenting was already initiated, and interestingly enough, not in the domain where it was originally seeded. So we went through prototyping with cheap, easy, accessible, fungible data from the music industry, completely new ways in which we can interact with systems and menus, to actually create a patent for the primary industry and for vehicles in primary industry, interestingly enough. Now, these are some of our heroes. I showed you lots of women earlier. I'm showing now a bunch of men. These are early success stories. There were so many afterwards. I could speak just about the amount of success stories that have come out of this experimentation space. As I say, more than 8,000 contributors, lots of papers, lots of success stories. These are just some MIT innovators under 35, 1 million follow-up funding for neurofeedback research, patenting, or 30 under 30 Forbes Israel, just to name a few. And what was interesting was that while we were initially joined by some of the media companies or lots of tech companies, and lots of public organizations, universities. Not all universities are listed here. We can't actually list them all. There's a whole other page devoted to that. But we were actually also joined by other sectors. You will see here, for example, Volvo, Philips, or ABB joining us. Now, of course, very early enough, this will be familiar to you, we observed the classic problems. So in these hands-on experiments, we saw that, of course, there was never enough data when we were working with AI, problems with interoperability, problems with proprietary IP that can't be released into the system, so we always have to use fungible data, and of course, use cases were unpredictable. And I reacted to this by scaling our enablers to to be useful to industry. So here's a few examples of how these bottlenecks were scaled. I proposed an industry commons already in 2015. It was later adopted as a track by DGRTD in Europe as a space of common understanding between industrial domains. Proposed to scale technology transfer toolkits through various different strategies. Of course, we were originally using APIs for most part because it was easy and agile, but of course they are high maintenance and we need more standardized, stable solutions, and I will come back to that. We also proposed the idea to create this IP stack, which basically builds innovation IP on top of prior IP and research IP. So background IP and research IP, and we already introduced innovation IP into our consortium agreements in 2015. It was one of the reasons why we had quite fast progress with innovation. And then, of course, to the fact that the use cases are unpredictable, there was proof for that because we were finding most of the important breakthroughs were happening in the gaps between the verticals. So it was very interesting from that point of view. And again, I will look back to that. So just to explain on the technology transfer toolkit side of things, one of the things that was basically encouraged as part of the industry commons concept was to create an ontology ecosystem. And this is the OntoCommons project that we are now running. Now, the idea of creating an ontology ecosystem or a point of reference for ontologies is something that can be standardized, that can be more permanent. Of course, it's a non-trivial challenge, and we have been working on it intensively. The other options are, of course, application protocols are very effective. They can be actually created also between domains, but they are, of course, selective, and they result in selective agreements between particular domains. Interfaces, of course, are very agile, but we compare them to toll roads because they are such high maintenance. So as a result, of course, as you can see, one of the biggest gaps that needed to be covered was this idea of an ontology ecosystem. And this is a project that has been now running for the past 2 years. We have just had this week intensive demonstrator workshops with our industry partners, Airbus, Bosch, Siemens, Eibel, etc. Really amazing. I mean, we have now introduced also IKEA into this. We have some really interesting startups in the medical data domain for those who are interested that have just spoken. So if you are interested in how we are approaching this challenge and how we are also testing it with use cases on the ground, please do get in touch. It is a very, very exciting project. On the bottom left corner IP stack, this took a little longer to convince industry that was incredibly important to track and trace intellectual property in these spaces. And this has actually resulted now this year in a very important project too. So the way we look at this idea of intellectual property in these experimental spaces is that we port background IP from research and industry. We very often have to create transfer IP. So we need to lower the entry barrier for entrepreneurs and for those who are opening the routes to, let's say, emerging markets. And this is often done through creating new kinds of affordances, for instance, embedded ware, new kinds of microcomputers that will allow you to port the data over and embed it in new types of solutions. So there's an interesting new twist on the intellectual property discussion. But then, as I said already, we have introduced innovation IP since 2015 as a separate category. And this really helps to stimulate innovators and entrepreneurs to engage with the research and innovation. And as a result, one of the projects that we are now building, we are in charge of intellectual property and industrial agreement strategies and building tests and prototypes, ICT tests and prototypes. So this is the new project Ready, which is for the manufacturing sector, but it's actually uniting all of the platforms that have been created as part of the ICT program for the past several years. So we are working with everyone who's been innovating in this space and building platforms, including sort of fireware and some of the things that would be familiar to some of the researchers who work in this area. It is the first time that there is a harmonization proposed in terms of uniting all of these platforms to create this data as a product digital continuity for the manufacturing sector. As I say, within that, we are insisting that the IP industrial agreements are key enablers and also very important for resilience and business models in this space, which actually drive the behaviors in marketplaces for data in these spaces. Thirdly, we're talking about these gaps between the verticals and the breakthroughs that are happening there. Now, in this sense, what we are looking at is the fact that verticals are slightly disintegrating in the sense that the silos are not so divided anymore because of the high level of connectivity and because they very often share tools. So we have opportunities in these spaces. What we are looking at is, again, we focus from our perspective on the idea of the culture of a domain and the fact that the individual domains cultivate a particular culture that's around a set of notions or the meanings that are accepted and that are tacit or implicit in that domain. Now, in the junction between the cultures, of course, we find opportunities, and this has been proven in our test beds. And of course, where there are opportunities, we can build new values. So this is our approach to this cross-domain space. Now, in order to measure that, already in 2014, I developed together with colleagues at the Connect Advisory Forum this new approach to not rely only on technology readiness, because if we were to wait until TRL 9 for a technology to be completed, this would not be appropriate. We're not talking about technologies that are hugely expensive and require a huge amount of investment and testing before they are deployed. We are looking at a very agile method where we want to examine the levels of risk, number of potential early adopters, and actually allow for a huge amount of data yield from early adoption so that we can start to estimate the impact that this might have on the use of this application. And it's also a good guideline for early investment. So this has been our strategy for involving early adopter communities and our test beds. This does rather connect to this idea of leveraging communities to test drive new solutions on the ground with an European Bauhaus. And after the first 2 years of developing the concept for the new European Bauhaus and launching it based on a set of fundamental principles, we are now at the stage where we want to engage again with technology and seeing how do communities now interact with the technologies that have been created at European level, innovative technologies that can be tested with these communities, but also how can communities inform technology creators in terms of how they affect human behavior and interaction. So we have just launched DG NEB, which is a new project now that's uniting the NEB community with technologies. Now, on the level of feeding policy directly from those experimentations, the European Bauhaus has very much been able to change and shift a few paradigms. And in our vision, I will run you through a few of those in the last few minutes. But what I want to show you is the overall concept of what the industry commons vision is. It's conceived as an ecosystem of trust. It's conceived as a place where breakthrough innovation happens by modeling of current and emerging market possibilities in a space of common understanding where, of course, we assume that we have, at least to a certain extent, solved interoperability between domains. Here I mentioned the Onto Commons ecosystem as one of the main things which we are building. But this doesn't exist in isolation. This whole system needs to exist on a system of enablers. So systems of agreements where, of course, we introduce regulation into the system. We automatize it as much as possible, but we also track and trace individual contributions through intellectual property registration and attribution. Then systems of resilience, where we, of course, observe environmental sustainability. For instance, if anybody is following Kate Raworth's donut economy model, we do not want to exceed certain use of materials and resources. And we also need to build towards resilience against black swan events. Then, of course, systems of responsibility need to be embedded in this, so responsible AI, ethics, and corporate social responsibility. But all of these sit on a foundation of systems of beliefs, our societal values, where we can, for example, embed radical inclusion, and in that sense, mitigate against the bias that's inherent in every data set, but at least reduce it to the extent that we are, as a matter of principle, including everyone in this space of experimentation, and therefore we can see if any of the stakeholders are affected negatively. So in terms of shifting paradigms then from this vision, I am lucky that I have the privilege to work with this amazing group of people and amazing leaders in the European Commission. And these are just some of my fellow members of the high-level roundtable. We have recently onboarded 3 new members that who were born in the African continent. So we are very keen to also have this beyond European perspective. And I can also tell you that on the industry commons side, we are in big discussions already for quite a while with American partners, large American industrial consortia who are very, very interested in this approach. Now, so we are very lucky that we are. It's not something that's just European. It's actually a more of a global approach. Now, ecosystemic approaches. Each one of these paradigm shifts that I'm going to show you has also a little root in one of our labs. So, for example, this was the AI Impact Lab that was done at Örebro University in Sweden, where we were testing our introduction with robots and introducing humans in the loop. When it comes to European paradigms, in Europe currently the dominant paradigm for industry is human-centric. So we've shifted from 4.0 automation to 5.0 human-centric. But through the European Bauhaus, we have actually emphasized already more than human ecosystems if we wish to consider sustainability as our main objective. And of course, as a result, the main conference for industry last winter, was entirely focused on discussing ecosystemic approaches to industry. So if we are going to follow version control, we'll probably go to Industry 6.0 ecosystemic next. Transgenerational, I think this was quite relevant for some of the talks that were a little earlier during the session. And of course, our approach to inclusion is really complete, and this is from our labs in Stockholm. In terms of Industry 5.0, inclusion, of course, is about including several categories of people. Whereas our approach from the European Bauhaus perspective, we recommend the emphasis on where we converge. So a different research question, if you like, at the beginning. Where do we converge? Let's not look at ticking boxes. And this can create a different approach to technology design and implementation. Enablers I mentioned already, and this is us tracking IP in this case. Now, when it comes to how we approach the subject of technology at policy level, of course, ethics has been discussed a great deal at European level, and we assume that this has to be integral to how we approach technology. But we have also recommended through the European Bauhaus that we should rediscover indigenous technologies, and we should actually look at both sets of knowledge. And then finally, there are the moonshots. And this is a nice example where, for instance, famous artist Imogen Heap was there sending her voice to the moon via the Dwingaloo radio telescope in the north of the Netherlands as part of our labs in Stockholm. And 83 people in the high-level labs sent their voices to the moon, and after 2.4 seconds, it was returned into their ear. Now, this is not because it's a scientific breakthrough by any means, but because it puts us in a different mental frame when we then do experiment with technologies. And as a result, when we talk about Industry 5.0, wishing to upskill by training, for us, as part of the New European Bauhaus, the future of work is driven by missions. So finally, I can just say that all of our starting points come from the community, and we have found it incredibly valuable as a source for inspiration for our researchers, for the industry, but also as something that we can really show as evidence-based policy for the policy makers. Thank you for your attention.
Thank you, Michaela. A very interesting keynote, final keynote. I think the right way to finish this two-day event. I think we have time for a couple of questions, very quick ones, because we are already very late. I don't know if anyone in the audience would like to ask a question. If not, then I think we can close it like this. Thank you again, Michaela.
Thank you, and as I say again,
thank you
sorry.
very much. Thank you.
Yeah, thank you. As I say again, anybody who wishes to get in touch, everybody who wishes to get in touch on any of those initiatives or any of those subjects, you're very, very welcome. We would love to hear from you.
Thank you. Thank you.
And to wrap the 2 days of the 2022 CMU Portugal Program Summit, we welcome the closing remarks panel with James Garrett, Provost, CMU, Sir John O'Reilly, Chair, CMU Portugal ERC, and Jose Mora, Director of the CMU Portugal Program at CMU.
Okay. First of all, I'm just going to ask my colleagues here on the panel to say their closing words, because I have and please be short because I have a 2-hour speech and I need to get to my own.
So good afternoon, everyone. I am so pleased to be able to have been here these last 2 wonderful days coming together in support of CMU Portugal. Sir John has been really doing a fantastic job of quoting amazing, relevant quotes. So I'm going to take a shot at it too. In the 16th century, Gavin Douglas first said, "Wow." And so I want to use that as a starting point here. I have had a tremendous and very intellectually interesting visit. And I cannot thank the faculty and the students and the staff and those from the companies enough for all the excellent work that you're doing and being excellent hosts here in Portugal. I especially want to thank my colleague, Professor Jose Mora, the CMU Portugal Program Director, for putting on such a very intense and thoughtful and productive agenda, as well as Inês Lintz and Nuno Nunes, the national directors of this Carnegie Mellon Portugal program. We were able to meet with many members of this community and hear about the work that's going on and the experiences that they're having and the exciting contributions that are both happening academically as well as within the companies that are sponsoring these projects. I also want to thank our partners, Professor Madalena Alves, President of the Portuguese National Science Foundation, and Sir John Riley, Chair of the CMU Portugal External Review Committee. Their collaboration and support are truly valued. It really has been remarkable to hear about the successes of our students and the faculty and the positive impacts and outcomes of this doctoral degree program that the students have been very actively participating in and making contributions. Carnegie Mellon greatly values this partnership that has been forged with the universities here in Portugal, as well as with our industry partners. And we really are excited to see what the future holds in solving these real-world problems that were talked about yesterday and today. So as the university grows its global presence, we are certainly encouraged by the successes that we have had in CMU Qatar, which is located in Doha and focused on undergraduate education, by CMU Africa, which is a campus in Kigali, Rwanda, that is experiencing enormous success at the master's program. And of course, right here in Portugal with CMU's Portugal program that includes strong doctoral programs and research and innovation activities. As I said before, this CMU Portugal program is a gold standard of the kind of relationship that we at CMU want to have with you all. So I thank you for engaging and allowing me to participate with you in this very rewarding visit, and I hope you all found these past few days as exciting and as informative and as amazing as I have. Thank you.
So a few words from me, and I'll try not to be too long, but you know what I'm like. Okay. I can't remember whether I said this to you yesterday or not, but one of my previous jobs was rather special. It was called Director General Knowledge and Innovation for the UK government. And it had three big handfuls, three things that I was responsible for. One was higher education. The second was the research budget, the basic research budget that went out through the councils and so on, a bit like NSF. And the third was innovation, the innovation agency for industry, the associated things, the patent office, and so on and so forth. And when I took that job, I thought about it, Director General, Knowledge of Innovation, responsible for the whole of knowledge, maybe. And I realized, actually, I'd done quite a lot of that during my academic career with industry and so on, and found the three things working together fantastically mutually supportive. Each fed the other. You were incomplete as a country, certainly, if you only gave your emphasis in one or two of those. That was my view. And I referred to it as the knowledge triangle originally, trying to get my way in government, but eventually sort of dumbed it down a bit and said, it's like a three-legged stool. Three-legged stools stand up on their own. Take one leg off and they got a problem. Okay, so I do tend to think in terms of that three-legged stool about things. Now, why do I say that? Well, you've been here for 2 days just like I have. You've seen it in action. Look at what we've seen. Fantastic talent development. Some very, very impressive, very interesting. We sometimes use the word basic research. I prefer frontier research or something like that because it works across the spectrum. But certainly examples of innovation taken further forward. So that's one thing. Now about the universities, a bit in the higher education. When we look at the top universities, we often use the phrase research-intensive universities. And that's right, and that's important, and research plays a very important part in universities. It enhances the quality of the educational experience at all levels, especially vitally important at the PhD level. But personally, and I think probably in some sense brought into sharp focus for me through exposure with this program, I no longer think that's enough. Let's look at some top universities, and I know you are, but I'm going to leave you out for the time being, Provost, if you don't mind, okay? Stanford and Silicon Valley. I'll choose MIT, but you could do more. Look at the Boston area. Go to the UK, look at the situation now around Cambridge and the developments in and around Imperial College and its two campuses. And what you'll see there is what I've been talking about. Excellent, outstanding education, in that sense of the word, outstanding research, but it doesn't stop there. So I increasingly think in terms of not research-intensive universities, but research, innovation, and enterprise, really right along that chain. And that, for me, is one of the things that is a really interesting development of this program. I don't know that it started that way. I was here at the beginning, and I don't think I heard it expressed in that way. It's responded to circumstances, and I think we've seen a change, really. The most recent phase, this third phase, has been different. We've seen some projects, the big projects, led by industry, funded through a different agency, working in partnership with FCT in some sense for the overall program. And actually, there were some very, very interesting and exciting and impressive projects there. But the balance is important as well, isn't it? So I was very pleased to see, when I went up to the posters, what the PhD students were doing. No, really exciting. Very pleased to see those basic things. As the program moves forward into the fourth phase, assuming and hoping that it does, I think that issue of balance is something we will want to make sure that we get it right. To some extent, necessarily, governments look at what is possible at the time. But I think if we can encourage them to look back now over the 15 years, see what's been achieved, and realize that by bringing all those things together in the right sort of balance, in the right sort of way, something very special in ICT has been created here in Portugal in partnership with CMU. And if you want an example of that, from very basic research, right the way through the startup, right the way through to unicorn status companies, in this area, 7 in Portugal, the largest number in any country in Europe. That is a remarkable statement. And of course, as I said at the beginning, correlation doesn't imply causality. But equally, these things don't happen by accident. So my observations there.
I hope you all have enough energy for the next 2 hours, because I look at all I wrote, okay? So thank you to all for participating actively through the different presentations and panels and keynotes. Many of you came from afar. Thank you very much. We appreciate that. Afar means outside Lisbon, and some from the other side of the Atlantic. In particular, thank you to all the presenters and panel leaders. We had today and yesterday a quick snapshot of some of the activities of the CMU Portugal program. We focused on the large projects and some of the smaller exploratory research projects. I'm amazed by the tremendous progress, potential that these different activities showed us. There were posters upstairs that augmented the presentations. I myself had the opportunity to read many. Thank you to the students. I assume they were prepared by the students. Thank you to the students that prepared the posters. They were very informative. Now, you didn't see all the activity. We left out some projects, and we left out most of the research that is being carried out by the 30+ PhD students and the 12 or so affiliated doctoral students. I'm sorry that we couldn't accommodate the works on this marathon of the activities of the program. Let me thank the members of the CMU Portugal board that were present throughout yesterday and today, CMU's Provost Jim Garrett and CMU's Dean of Engineering Bill Sanders. Thank you very much for being here. Let me acknowledge and thank the members of the External Review Committee, chaired by Sir John, president of Khalifa University. That's a new title. And Dr. Fernando Pereira from Google Research, if I'm correct. And Dr. Giulio Sanguini from the Italian Institute of Technology. Finally, I acknowledge the tremendous effort of putting this together. My co-directors, Professor Inês Lins and Nuno Nunes, somewhere, yeah. The executive director of the program in Portugal, Silvia Castro, and her team, João Fumega, please raise, João Fumega, Mariana Carmo, and Alexandra Mendes. Is Alexandra here? She's hiding somewhere, and all the others that helped. And from CMU, the Associate Director, Megan Bertie, and Maya Colacito and Mary Edelson, who are not here, but I hope that you'll transmit them our thanks. Thank you to all of you, the industry partners that showed us what research really means. It was amazing to the talks that we heard from our industry partners and the problems that they brought to the university teams. And I guess the way the university teams have shown that there can be very high quality research, publishing in the best venues, and still contribute to the, let's say, medium-term strategy of their industry partners. It was amazing to see that some of us that are theoreticians in these things that say, oh, of course, that's possible. Why don't you just join university people with companies and things will happen? Well, now we have a proof of concept, okay, at least. Thank you to all. Please go out, enjoy the evening and night in Lisbon. This is like especially made for all of you. So please go and have fun. Thank you.
This now concludes the 2022 CMU Portugal Summit. Students, if you may want to pick up your poster, please head to the 3rd floor. Thank you all for joining us here in Lisbon, and we look forward to seeing you at the next summit.